The information in this book has been carefully checked and is believed to be accurate. However, no responsibility is assumed for inaccuracies. Motorola reserves the right to make changes without further notice to any products herein to improve reliability, function or design. Motorola does not assume any liability arising out of the application or use of any product or circuit described herein, neither does it convey any license under its patent rights nor the rights of others. The software described herein will be provided on an as-is basis and without warranty. Motorola accepts no liability for incidental or consequential damages arising from use of the software. This disclaimer of warranty extends to Motorola's licensee, to licensees transferees and to licensees customers or users, and is in lieu of all warranties whether expressed, implied, or statutory, including implied warranties of merchantability or fitness for a particular purpose. Motorola and registered are registered trademarks of Motorola, Inc. Motorola Incorporated is an equal employment opportunity / affirmative action employer. Motorola Incorporated general policy does not recommend the use of its components in life support applications wherein a failure or malfunction of the component may directly threaten life or injury. Per Motorola terms and conditions of sale, the user of Motorola components in life support applications assumes all risks of such use and indemnifies Motorola against all damages. VME Delta Series, VME modules, Versa modules, I/O modules, operating systems, bus technical summaries, customer support, appendices, module current, supplied current, index 2 animator, Forms 2 and Level 2 AutoIt are trademarks of Micro Focus, Ltd. HDS 200, HDS 300, HDS debug, I/O module, PC/68000, RMS 68K, SYMBug, System V/68, TEN bug, Veridues, Versa module, VME bug, VME module, VME/10, 117 bug and 020 bug are trademarks of Motorola Inc. Conceptual GKS is a trademark of Larson Software Technology. CP/M, CP/M68K, CP/M86 and Digital Research are trademarks of Digital Research Inc. DEC, PDP-11, VAX and VMS are trademarks of Digital Equipment Corporation. Ethernet registered is a registered trademark of Xerox Corporation. Floppy tape is a trademark of Cipher Data Products Inc. Informix is a registered trademark of Relational Database Systems Incorporated. IBM is a registered trademark of International Business Machines, Corp. LARC is a trademark of Control Data Corporation. Microtrack is a trademark of SoftTrack Systems. Oracle is a registered trademark of Oracle Corporation. QChart, QFile, QMenu, and Q1 are trademarks of Quadratron Systems Incorporated. RM/COBOL is a trademark of Ryan McFarland Corporation. SUSE is a trademark of Shugart Associates. 2020ths is a trademark of Access Technology Incorporated. Unify is a trademark of Unify Corporation. Unix is a trademark of AT&T. XNS is a trademark of Xerox Corporation. The bug, MVME 101 bug, 117 bug, 130 bug, M68 bug, M68 bug 2 and M68 bug 3 EPROM sets are copyrighted by Motorola and may be copied only under prior written agreement from Motorola. Bug 1, Bug 2, MVME 101 Bugelf, MVME 101 Bugelk, M68 Bugle M68 Bugle M68 Bug 2L M68 Bug 2LC M68 Bug 2LMC M68 Bug 3L M68 V2 FSBG 130 M68 V2 X SBG 130 M68 V1 X SBG 117 M68 V1 SCSI and M68 Bug 3LC sources are copyrighted and licensed by Motorola. They may be obtained only under the required license agreement with Motorola. MVMX32 bus is a Motorola proprietary expansion bus for use with VMware. VSB, the VME subsystem bus, is a subset of the VMware. Standard warranty. Seller warrants that its products sold hereunder will at the time of shipment be free and clear of all liens and encumbrances and will be free from defects in material and workmanship and will conform to seller's applicable specifications or, if appropriate, to buyer's specifications accepted by seller in writing. If products sold hereunder are not as warranted, seller shall, at its option, refund the purchase price, repair or replace the product, provided proof of purchase and written notice of nonconformance is received by seller within 90 days from date of initial shipment, and provided said nonconforming products are, with seller's written authorization, returned. FOB seller's plant or authorized repair center within 30 days from expiration of said 90 day period. Upon verification by seller that the product does not conform to this warranty, seller will pay the cost of transporting such replacement of repaired goods to buyer's plant within the contiguous 48 United States and Canada. This warranty shall not apply to any products seller determines have been, by buyer or otherwise, subjected to testing for other than specified electrical characteristics or to operating and/or environmental conditions in excess of the maximum values established in applicable specifications, or have been the subject of mishandling, misuse, neglect, improper testing, repair, alteration, damage, assembly or processing that alters physical or electrical properties. This warranty excludes all costs of shipping, customs clearance, and related charges outside the contiguous 48 United States and Canada. In no event will seller be liable for any incidental or consequential damages. This warranty extends to buyer only and not to buyer's customers or users of buyer's products and is in lieu of all other warranties whether express, implied or statutory, including implied warranties of merchantability or fitness. Registered Motorola Microcomputer Systems and Components. Preface. Prepared by Technical Information Center. Following Motorola's tradition of serving current and future needs of the fast-evolving electronic market, the Motorola Microcomputer division offers systems and components ranging from VMbus-based multi-user microcomputers to larger form-factor Verabus microcomputers, plus a broad line of compatible modular components, peripherals and software. System integrators and value-added resellers are provided support for integration and development of today's VMware microcomputer and System v/68 based products with languages and development tools, data management and communications facilities and office applications. OEMs are provided support for development of today's MC68000-, MC68010 and MC68020 based products with instrumentation, hardware, software development tools and the System v/68 and Verabus operating systems. The consistent Motorola MC68000 family migration path and future development tools plus a multi-processor operating system will assure support for the development of tomorrow's MC68030 based leading-edge systems. Printed in USA. 3rd edition. Motorola Inc., 1987. Previous edition copyright 1985. All rights reserved. A rainbow arches over the application world of a general purpose microcomputer product line, particularly the VME Delta series, which utilizes an open VMware architecture, an AT&T validated Unix V operating system, V/68, and the state-of-the-art MC68020 microprocessor, SOR. At one end of the rainbow is a land of applications served by system integrators, value-added resellers and complementary marketing organizations selling limited user systems into business-oriented markets. The other end touches down in a nearly unbounded field of custom OEM applications in such technological areas as graphics processing for CAD simulation and medical scanning, analysis of oil exploration instrumentation data, visions, systems for positioning and attribute detection in robotics, and other factory automation, artificial intelligence, research, in cellular communications and many other leading-edge areas. The current array of VME Delta series products will continue to grow with new markets, offering hardware for system expansion including a cache accelerator, color and monochrome terminals and a remote service modem for remote diagnostics. Support for industry standard communication protocols is available. This includes Intel Legend controllers and supporting software for the IEEE 802.3 CSM-LCD LAN standard and the SNAPES/X.25 protocols. Support for business applications will grow too, through intelligent controllers with supporting software for SNA and BSC and other commonly used protocols, through information retrieval, processing and development packages, through an integrated spreadsheet and color graphics support and a project management system. In time, the VME Delta series line will span an applications world of its own. 1-to-1 PBC 101 PBC 102 VME Delta series data sheets Model 2016 computer system 1-to-2 TM3000 terminals 1-to-6 M68N and TBV68 system V/68 operating PBC 103 system software features 1-to-8 PBC 104 micro focus level 2 COBOL enhanced technology 1-to-12 PBC 105 SNA and BSC communication products 1-to-16 PBC 106 8-port serial controller 1-to-18 PBC 107 Ethernet LAN controller 1-to-20 PBC 108 intelligent communications controller 1-to-22 PBC 109 SMD disk subsystem 1-to-24 PBC 110 Model 2616 computer SYM 1-to-26 PBC 101 registered Motorola VME Delta series Model 2016 computer system highlights Motorola MC68020 processing power 12-slot VME compatible enclosure 2 to 16 MB of main memory 2 to 34 Rs 232 asynchronous ports 85 to 340 MB of integral Winchester disk storage up to 1.3 GB of external SMD capacity 60 MB streaming tape O software compliant with System V interface definition. SVID, Release 3. O comprehensive local and remote diagnostics. General description. The VME Delta series family of 32-bit computer systems is based on the Motorola MC68020 microprocessor, the VMware standard, and UNIXRSYS. TEMV, Release 3. The Model 2016 uses the 16.7 MHz MC68020 and sub ports up to 34 serial devices. The power of the MC68020 plus the expandability and flexibility of the VMware architecture make the Model 2016 an ideal computer solution for commercial, technical, and networking applications. The Model 2016's 12-slot VME card cage adapts to most application interfaces and expands to support large configurations. In addition, the system enclosure accommodates up to 4 disk drives plus a streaming tape. External SMD and tape subsystems are also supported. Both local and wide area communications protocols link the Model 2016 to industry standard networks as well as host computers. Hardware overview. The Model 2016 hardware includes O. the system enclosure, O. the VMware, O. the applications processor and memory, O. I/O and communications controllers, O. mass storage devices, O. local and remote diagnostic capabilities. System enclosure. The VME Delta series enclosure offers a 12-slot VME compatible card cage, a 12-slot VME cable connection area, and an SMD and tape subsystem cable connection area. This provides connectivity to a diverse and large number of peripheral devices. The unit houses a streaming tape drive and up to 4 5-1/4 disk drives. One of the disk drive slots is used for half-height diskette drives when required. By the configuration, all drives are held in shock-mounted drive assemblies. The enclosure contains a 450-watt switching power supply and is cooled by filtered air. VMware. The VME Delta series uses today's leading 32-bit bus standard, the VME bus. The VMware, in conjunction with the double high Eurocard form factor, offers systems integrators and OEMs high performance as well as access to an expanding set of readily available controllers and system components. The Model 2016's 12-slot VME compatible card cage also allows the SYS TEM to grow in a modular fashion to meet future as well as current requirements. In addition, upgrading the Model 2016 to a more powerful model in the VME Delta series family is as Motorola Microcomputer Systems and Components 1-2 PBC 101. Simple as replacing the processor and memory boards. Main processor. Tape alternatives allows the Model 2016 to satisfy a wide spectrum of performance and application requirements. Each intelligent controller uses a 10 MHz MC68000 family microprocessor. The Model 2016's main processor intelligent communications Includes a 32-bit 16.7 MHz MC68020 controllers. The 8-port serial controller can support 8 asynchronous terminal, printer, or modem ports. Because each port can be independently configured, this controller can be adapted by the system integrator or OEM to support a wide range of serial devices. The Model 2016 supports up to 4 serial controllers. VMware compatible controllers are offered for asynchronous devices, terminals, printers, modems, etc. Microprocessor, an optional cache. Accelerator, a memory management unit, and a floating point coprocessor. 2 RS-232 ports are included. These are normally used for a console port and a remote service modem. The MC68020 has an on-chip 256-byte instruction cache. The processor uses the high-speed VME subsystem bus (VSB) for parity memory access and the VMware to interface I/O controllers. The MC68881 floating point coprocessor implements the IEEE floating point standard plus trigonometric and transcendental functions. OSNA, BSC, and X.25 communications. Ethernet local area networking. The intelligent communications memory. Up to 16 MB of main memory are offered on the Model 2016. Both ECC and parity memory options are available. ECC memory comes in 4 MB increments and provides single-bit error correction and double-bit error detection. A 64-bit cache register gives fast access using the VMware interface. Parity memory comes in 2 MB increments and provides byte parity generation and error checking. These memories are dual-ported via Turing concurrent processor and 110 access using the VSB and VMware, respectively. Disk and tape controllers. The Model 2016 supports controllers for 5-1/4 Winchester and floppy disk drives, 8 SMD disk drives, 1/4/1 streaming tape, and 1/2/19 track tape drives. All are intelligent controllers with DMA-VME system interfaces. This selection of VME-compatible disk and controller, Winchester and floppy, SMD, streaming tape, 1/2/9 track tape, 8-port serial communications, Ethernet, form-fit, disk drives, 5-1/4, 5-1/4, 8. Tape drives, 5-1/4, 1/2/9 track, interface, ST506, SA400, ESMD, QIC02, PerTech, RS-232C, RS-232C, CSM-LCD, controllers. Number of channels/drives 2, 2, 2, 6. Transfer rate per second up to 5 bits, up to 250 kbits, up to 25 bits, up to 90 kbits, up to 1.25 bits, up to 19.2 kbits, up to 19.2 kbits, 10 bits. Mass storage devices. Interface unformatted formatted average. Capacity access time. SA 401 MB 655 KB 181 milliseconds. ST 50685 MB 67 MB 28 milliseconds. ESMD 337 MB 269 MB 20 milliseconds. QIC 0260 MB. PerTech 1600 bpi 45 MB. 3200 bpi 90 MB. Motorola Microcomputer Systems and Components. 1 to 3. Controllers. POR. System. 2. 4. Drives. Per system. 2. 4. I. PBC 101. Troller supports bit and byte-oriented protocols like SDLC, HDLC, and BSC. Each port is independently programmable. A 4-channel DMA controller is offered for high-performance applications. The Intelligent Ethernet LAN controller is compatible with Ethernet version 2.0 and conforms to the IEEE 802.3 CSM-LCD LAN standard. The controller interfaces with the network at 10 bits per second. Mass storage devices. The base model 2016 contains a 5-1/4 MB Winchester drive and a 5-1/4 60 MB streaming tape for SYS, TEM backup and software distribution. Some configurations also include a floppy diskette which uses a disk slot. The system can be expanded to 340 MB of Winchester disk storage and 1348 MB of SMD disk storage using 2 SMD disk subsystems. Local and remote diagnostics. The VME Delta series system diagram. Gnostics are oriented to centralized service networks and user participatory fault identification. They enhance the system's overall reliability, serviceability, and maintainability with the following diagnostic features. Hardware integrity verification at system power up and reset. System test and diagnostics in firmware, on standalone disk, and under the operating system. Menu-driven user interface with online help facility. Custom test suite generation, evaluation and debug tools. Remote test and diagnostics with integral service modem. The Model 2016's comprehensive SYS TEM diagnostic facilities are designed to support very cost-effective customer and product service approaches. Software overview. In addition to the following software products, a large number of software applications are available from independent software vendors which will run on the VME Delta series. Unix System V operating system. System V/68 trademark Release 3 is Motorola's version of AT&T's Unix System V. Release 3. Release 3 includes the following new features and enhancements. Remote file sharing which allows users to share files, data, and peripheral devices across computer systems attached to a local area network. Streams which supports application development independent of the underlying network protocols. Virtual memory and demand paging support for efficient memory utilization and simpler application development. Menu interface for system administration functions. Support for the MC68881 floating point coprocessor. Complete backup and restore facilities. System V/68 Release 3 is compliant with AT&T's System V interface definition. SVID. Languages and development tools. OC compiler and Fortran 77. ORM/COBOL-R. O micro focus level. Kobold/ET, animator trademark, and Forms 2TM. OAppSoft Fortran. OQMenor menu development tool. Data management facilities. OUnify trademark relational database management system. OOracle R relational database management system. OInformix R relational database management system. Data communications facilities. O3274 SNA and BSC. O3776 SNA. ORJE/HASP, 2780, and 3780. OX.25 with TCP/IP. O Ethernet with XNS. O Ethernet with TCP/IP. Office applications. O Business Assistant trademark user services. OQ1er word processor. O20/20 trademark spreadsheet. O Office services, electronic mail, calendar, etc. OQ Charm business graphics. O Microtrack trademark project management system. OQ_Philatm information storage and retrieval system. Motorola microcomputer systems and components. 1-4. PBC 101. Specifications. System. VMware, IEEE PL014. Eurocard form factor. Depth, 6.30, 160 mm. Height, 9.17, 233 mm. 96-pin DIN 41612, PL, connectors. 12 double high VME card slots. Processor. MC68020 at 16.7 MHz. Gate array MMU, 1 KB page, compatible with MC68851 PMMU. MC68881 floating point coprocessor, IEEE P754. 16 KB cache accelerator option. 2 RS-232C asynchronous ports. 110 bps to 9 SU bps. VSB memory bus. Memory. ECC memory. 4 to 16 MB. 4 MB increments. 64-bit cache register. 560 NS 32-bit average access. Single-bit error correction. Double-bit error detection. Parity memory. 2 to 8 MB. 2 MB increments. Dual-ported, VMware and VSB. 660 NS 32-bit average access. By 1E parity generation. By 1E parity checking. Winchester and floppy disk controller. 1 or 2 per system. Up to 2 ST506 Winchester drives per controller. Up to 2 floppy disk drives per system. 5 bits per second serial data rates. Multiple sector read/write. Automatic head switching and cylinder positioning. 2:1 interleaving. 32-bit ECC, Winchester. SMD disk controller. Up to 2 per system. 1 or 2 SMD disks per controller. Up to 25 MB per second data rates. 0 latency reads and writes. 1:1 interleave over multiple cylinders. 32-bit ECC. 5V. Streaming tape controller. QIC02 interface. Transfer rate. 90 KB continuous. 200 KB burst. Streams at 5 MB per minute. W9 track controller. PerTech interface. Up to 200 IPS-GCR drive support. Start/stop or streaming support. GCR, PE, or NRZI recording. S port serial controller. Up to 4 controllers per system. 8 asynchronous RS-232C ports. 10 MHz. MC68010 microprocessor. 128 KB RAM memory. 32 KB ROM. Port selectable. 50 to 19,200 bps. 1, 1.5 or 2 stop bits. 5 to 8 data bits. Odd, even, or no parity. DTR, DSR, RTS, CTS, and DCD control functions. Buffered Pipe Communication Protocol. Intelligent Communications Controller. 6 synchronous/asynchronous communications ports. 10 MHz. MC68010 microprocessor. 512 KB RAM memory. 128 KB ROM. SDLC, HDLC, and BSC protocol support. Port selectable. 50 to 19,200 bps. 1, 1.5, 2 stop bits. 5 to 8 data bits. Odd, even, or no parity. NRZ, NRZI, or FM encoding. Buffered Pipe Communications Protocol. Intelligent Ethernet LAN Controller. Ethernet, version 2.0 compatible. Conforms to IEEE 802.3, CSM-LCD, LAN standard. 10 bits per second. 10 MHz. MCS 8000 microprocessor. 512 KB RAM memory. 32 KB EPROM. Buffered Pipe Communications Protocol. Physical specifications. Height, 25.s in. S 5.0 cm. Width, 12.5 inches. 31.8 centimeters. Depth, 28.0 inches. 71.1 centimeters. Weight, 135 IBS. SIKG, fully loaded model 2016. Environmental and safety specifications. Safety. Meets all 478, EDP, and 114, office equipment. Meets CSA 154, EDP, and 143, office equipment. Meets VDE 0806/8.81, office equipment. Meets IEC 380, office equipment. Emissions. Meets VDE 0871/S.78, Class A. Meets FCC Part 15, Subpart J, Class A. ESD. 5000 volts, no observable effect. 12,000 volts, no operator perceived errors. 24,000 volts, no permanent equipment damage. Altitude. Operating, 10,000 feet ASL. Non-operating, 30,000 feet ASL. Acoustic noise level. 55 dBA maximum. Temperature. Operating, 5 degrees Celsius to 40 degrees Celsius. Non-operating, 40 degrees Celsius to so degrees C. Relative humidity. Operating, 10% to 80% RH, non-condensing. Non-operating, 10% to 90% RH, non-condensing. Shock. Operating, 0.5 G. Non-operating, 15 G. Transportation. Packaging and shipping containers and procedures comply with the current NSTA. Pre-ship test procedures. Shipping container. Height, 34.5, 87.6 centimeters. Width, 22.5, 57.2 centimeters. Length, 41.0, 104.1 centimeters. Motorola Microcomputer Systems and Components. 1 to 5. PBC 102 registered. IT IIOTOROLA. VME. Delta Series. TM3000 terminals. Highlights. D alphanumeric, monochrome, color, and graphics models. D-Dec VT220 compatibility. D5 display modes up to 132 columns with 28 lines. D640x300 graphic display. Option. D Tektronix 4105 graphic. Commands. D8 colors from a palette of 64. D concurrent transparent print. Protocol. D RS-232 and RS-422 interfaces. Description. Motorola TM3000 terminals are a compatible family of high-resolution ANSI X3.64 compliant terminals. They support tilt and swivel 14 anti-glare displays with small footprints, ergonomic appearance and low profile keyboards. TM3000 terminals uniquely combine features of DEC, IBM, and Tektronix terminals into a single multifunctional terminal for general office applications. Supported DEC features include complete DEC VT220 terminal emulation, plus many enhancements. Supported IBM features allow comprehensive software emulation of IBM 3179 and 3180 display stations. These IBM features include 4 display modes up to 4105 8-color graphic and 8 color character commands. TM3000 terminals provide the following family members: D color displays, D amber displays, D green displays, D color and monochrome 4105 graphics, D IBM 3179 style keyboards, D Office Touch type keyboards. Features. Enhanced display features. D14 anti-glare display for larger viewing area. D displays up to 3696 characters. D displays 347 unique character symbols. 132 columns with 28 lines including a user programmable status line, IBM D styled keyboards and enhanced full color displays. Supported Tektronix features include compatible Tektronix 5 display modes, column X line 132x28, 132x25, 80x25, 80x 33 asterisk and 80x44 star. D character attributes of underline, intensity, blinking, reverse video, and erasable. D dynamic focus for clear readable characters. D special host programmable user line. D special symbols including IBM 3179 status line symbols. D 3-speed smooth scroll rate for convenient reading of reports. D 10x12 character cell in 80 column mode. D character matrix supports 2 lowercase descenders. Asterisk, 33 and 44 line display use automatic vertical scrolling. Enhanced color features. TM3000 color terminal support. These additional features: D7 colors, sky blue, red, magenta, green, cyan, yellow, white plus black. DBW3 phosphors for brighter blues. Motorola microcomputer systems and components. 1 to 6. PBC 102. O non-embedded attributes per char. Actor, background, 1 of 8 colors. Foreground, 1 of 8 colors plus bold. Blink, underlining and erasable. O optional graphics supports 8 colors from a palette of 64 colors. O enhanced contrast glass reduces light reflections. O dot pitch of 31 mm. Enhanced operational features. O concurrent transparent printing. Protocol allows convenient locally. Attached printer on the RS-232. Printer port to print host data while the display displays and the user. Types. O standard key lock. O tilt and swivel base. O low profile 30mm DIN keyboard. Adjustable to 3 levels. O other terminal emulations, DEC. VT220, VT100, and VT52. O RS-232, up to 300, and RS-422. Up to 2000, host port interfaces. O selectable port rates up to 19,200. BPS. Graphics features. O field upgradable option. O supports Tektronix 4105 compati. BLE graphic commands. O color display supports 8 colors per pixel selected from a palette of 64 colors. O monochrome display supports 8 gray levels per pixel. O 640x300 graphic display. O selectable character and graphic displays. O character display may overlap. Graphic display. DEC VT220 compatible features. O emulates, DEC VT220, DEC VT100/102 and DEC VT52. O programmable function keys. O downloadable character sets. O 80 and 132 column displays. O compose character key. O split screen smooth scrolling. O 13 resident national character sets. North American, United Kingdom, Canada, French, Denmark, Finland, France, Belgium, Germany / Austria, Holland, Italy, Norway, Spain, Sweden, and Switzerland. O line graphics and other special symbols. Keyboard features. O Office keyboard, 107 key type. Writer-styled keyboard layout for efficient touch typing and general Office application usage. O IBM-styled keyboard, 122 key. Board styled after IBM 3180 and 3179 display stations keyboard. For efficient data entry operations. And for compatible operations. O word processing and data processing key legends. O extra escape and line feed keys. O low profile 30mm DIN keyboard. O adjustable to 3 levels, 5, 10, and 15 degrees. O detached with coiled cord. O step sculptured keys. O selectable on/off audible key click. O separate numeric keypad. O separate editing keypad. O compose character key. Print features. O concurrent transparent print. O transparent print. O print screen. O auto print. O print cursor line. Operation modes. O monitor. O full duplex. O selectable local echo. O conversational local. O setup, menu driven, non-volatile. Specifications. Display. Viewable display area, horizontal, 240 mm. Vertical, 180 mm plus or minus 5 mm. Display mode display type character cell. Column X line. 80x25. 132x25, 132x28, 80x25, 132x25, 132x28. Monochrome, monochrome, monochrome. Color, color, color. 10x12, 8x12, 8x11, 10x12, 7x12, 7x11. Physical. Monitors, monochrome color. Height, 14.1, 358 mm, 15.6, 395 mm. Depth, 13.7, 348 mm, 16.2, 411 mm. Width, 13.3, 338 mm, 15.3, 388 mm. Weight. Articulation. 25 IBS, 11.3 kilograms, 39.8 IBS, 18.1 kilograms. Tilt, plus 5 degrees, 20 degrees. Rotation, plus or minus 45 degrees. Keyboards. Height. Depth. Width. Weight. Power. 1.2, 30 millimeters. 7.4, 188 millimeters. 20.4, 519 millimeters. 3.3 IBS. 1.5 kilograms. Monochrome. RMS power, 30 watts. Heat output, 102 BTU/hour. 26 kcal/hour. Rated current. Color. 64 watts. 242 BTU/hour. 61 kcal/hour. 60 Hz, 110 VAC, 1 amp 2 amp. 50 Hz, 220 VAC, 0.5 amp 1 amp. Safety. Meets all 478, EDP, and 114, office equipment. Meets CSA 154, EDP, and 143, office equipment. Meets VDE 0806/8.81, office equipment. Meets IEC 380, office equipment. Emissions. Meets VDE 0871/6.78, Class A. Meets FCC Part 15, Subpart J, Class A. ESD. 12,000 volts, no operator perceived errors. 24,000 volts, no permanent equipment damage. Altitude. Operating, 0 to 10,000 feet. Non-operating, 0 to 20,000 feet. Temperature. Operating, 5 degrees Celsius to 40 degrees Celsius. Non-operating, minus 40 degrees Celsius to 60 degrees Celsius, storage. Relative humidity. Operating, 20% to 80% RH non-condensing. Non-operating, 10% to 90% RH non-condensing. Transportation. Packaging and shipping containers and procedures. Comply with the current NSTA pre-ship test. Procedures. Motorola microcomputer systems and components. 1 to 7. I. M68N and TBV68. Registered. Motorola. Advance information. VME. Delta series. System V/68 operating. System software features. Highlights. D compliant with AT&T's Unix registered. System V interface definition. D object code compatible with. System V/68 release 2. D transparent sharing of data and peripheral devices across A. Network. D. Applications can be run independent of the underlying network. D. Virtual memory provides optimum utilization of physical memory. D. Fast file access and reliable file system. D. Efficient use of disk space and memory through shared libraries. D. Supports MC68881 floating point coprocessor. General description. The System v/68 Release 3 operating system is the standard operating system for the M68000 family of microprocessors. It affords users a powerful computing environment for developing, executing and supporting technical, commercial, and network applications. Compliant with AT&T's Unix system v interface definition, SV10. System v/68 Release 3 provides users with the ability to share data, applications and resources among different computers transparently. Release 3 is object code compatible with System v/68 Release 2. It offers an efficient kernel which provides process scheduling and 1/0 facilities to all programs. In addition, a powerful command processor, the shell, provides for interactive control. An extensive set of tools and utilities, /T processing, provide support for program development, text processing, electronic mail and system-to-system communication. Overview. The kernel. The kernel supports a multitasking, multi-user software development and OEM application execution environment. As the heart of the system, the kernel schedules tasks and manages system resources. It acts as a dispatcher of tasks competing for the SYS/TEM resources and as a traffic coordinator for the data flowing through the system while managing and allocating memory as required. Virtual memory. The demand-paged virtual memory feature of System v/168 Release 3 has several advantages over swapping. D. Programs larger than physical memory can be executed. D. Only the portions of a program which are actually being used reside in memory at any particular time. D. External fragmentation is completely eliminated. D. 32 MB process space. D. 2-level page table. Berkeley signals. A new set of system calls is provided in Release 3 of the System v/68 operating system which resemble those of the Berkeley 4.2 BSD signal interface. The new implementation provides enhancements to the existing System v/68 inter-process signaling mechanism while preserving the System v/68 signal semantics. Motorola Microcomputer Systems and Components 1-8 M68N and TBV68 Process fork mechanism. This feature allows processes to fork without duplicating the data area of the parent. It is commonly referred to as copy on write and essentially allows the child process to share the parent's data area. Modified pages are duplicated for each process before the access takes place. This feature provides the performance improvement of the Berkeley 4.2 BSD mechanism without affecting compatibility with the System v/68 fork system call interface. The shell The shell interprets user commands and calls system tasks to perform the requested operations. It accepts commands one at a time or in a series, called a pipe, where output from one job becomes input to another job. Features of the shell include control flow primitives, parameter passing, variables and string substitution. In addition, constructs such as while, if, then else, case and for are available. Two-way communication is also possible between the shell and the commands. String-valued parameters, typically file names or flags, may be passed to a command. A return code is set by commands that may be used to determine control flow, and the standard output from a command may be used as shell input. The shell can modify the environment in which the user command runs. Input and output can be redirected to files and processes that communicate through pipes can be invoked. Commands are found by searching directories in the file system in a sequence that can be defined by the user. Commands can be read either from the workstation or from a file, which allows command procedures to be stored for later use. The System v/68 file system. The System v/68 file system comprises a uniform set of files and directories organized as a hierarchical tree-like file structure of arbitrary size. Branching from the beginning of the file system, also known as the root directory, are several system directories, including the user directory. A directory can contain any number of subdirectories and files, which allows for almost any kind of branching structure that is required for the filing system. Major features of the file system are a 1024-byte file block size, simple and coherent naming conventions, file linking across directory boundaries, automatic file space allocation and allocation, mountable file systems, hashed one-node file and directory lookup, device independence. Each physical 1/0 device is treated like a file, thus allowing for uniform file and device 1/0. Flexible directory and file protection modes allows for the setting of read, write and execute authority separately for the owner, for a group of users and for all other users. These protection modes are altered dynamically. Facilities are provided for creating, moving, accessing and processing groups of or single files and directories. Optimal block allocation and allocation provides for fast access of files where data resides in the disk cache. Additionally, a configurable feature is included in Release 3 which causes all writes to the file system to be synchronized with the disk. This configurable feature reduces the likelihood of lost user data in the event of a system crash and improves the robustness and reliability of the file system. Remote file sharing. The remote file sharing, RFS, via Tour allows users to share files, data, and peripheral devices, such as tape, drivers and printers, transparently across different computers on a network. Existing applications can be installed and executed in an RFS environment. without any modifications, and these programs can access remote files. The full file system semantics, including named pipes and file and record locking, are preserved when accessing remote resources. File and record locking preserves data integrity by protecting files from simultaneous access by two or more users. Extensive administrative tools allow each computer on the network to control the specific resources it makes available for sharing, as well as the specific remote resources it makes available to local users. Security features are provided to enable a local system to accept or deny access to local resources on a per remote SYS, TEM and per remote user basis. Streams. The streams mechanism provides network protocol and media independence by allowing applications software to be independent of the underlying network. A change in the transmission medium or protocol can be accommodated by substituting streams modules without modifying the application's software. Streams modules can be combined to perform sophisticated network services, and the same modules can be used over different media and in different network architectures. Motorola Microcomputer Systems and Components 1-9 M68N and TBV68. In addition to modularity, Streams provides the following facilities: O simple user interface, O buffer management, O flow control, O scheduling of streams protocol modules, O efficient message passing, O multiplexing, O error and trace loggers. The streams mechanism is implemented as an independent subsystem, which allows protocols implemented using streams primitives to be easily ported or migrated. This allows protocols to be implemented in a way that is independent of the underlying machine architecture. Transport Level Interface Library. The Transport Level Interface, TLI, along with the Transport Provider Interface, TPI, provide a specific mechanism that allows a user to run applications independent of the underlying network. An application written using the TLI library will work without modification over any network implement according to the TPI specification. The traditional YUP commands have been modified to use the TLI library. The changes make the YUP family independent of the underlying network and usable across all streams-based transport providers. This change eliminates the need for different file transfer commands for different networks, communications and network support. The System v/68 operating system provides support for electronic mail communications and networking. Electronic mail allows users to communicate with one another using the system as a mailbox or as a bulletin board. The communications utilities allow a System v/68 user to communicate to mainframe computers. The tools and utilities supported under System v/68 Release 3 include AutoIt, Unix to Unix copy program, is a utility used for communication between Unix systems. OCU is a utility used to call up another Unix system. OMail sends mail and reads mail sent by users to other users within a system. O interprocess functionality include shared memory, messages, and semaphores. The data communications products supported under System v168. Release 3 include O3274 SNA and BSC, O3776 SNA, ORJE/HASP 2780 and 3780, OX.25 with TCP/IP. Networking support allows several computers to be linked together, either through dedicated links or by dial-up connections. Ethernet Local Area Net Working, LAN, support with XNS or TCP/IP is provided by System v/68, so that the software can be easily upgraded to other protocols. Each module corresponds to a specific layer of the OSI interconnection model. Software development tools, languages provided as an integral part of System v168 are the C language, compiler, CC, and the high-level C code optimizer. The C language has established itself as one of the most popular and widely used commercially supported programming languages, and produces portable application software. The optimizer is an added phase for the compilers, derived from the MC68000 software generation system, SGS. It aids the code generator to produce code, which results in 10% to 20% performance improvements. The System v/68 operating system also provides support for the Fortran language by including a Fortran 77 compiler F77, a rational structured Fortran preprocessor RATR, and an extended Fortran language preprocessor F1. Floating point support is also provided for both the C and Fortran 77 compilers. The MC68881 coprocessor provides the following features: 08 general purpose floating data registers, each supporting a full 80-bit extended precision real data format, OA 67-bit arithmetic logical unit to allow very fast calculations, OA 67-bit barrel shifter for high speed shifting operations. O fully conforms to IEEE P754 standard, draft 10.0, plus a full set of trigonometric and logarithmic functions. O overlapped instruction execution enhances throughput while maintaining the programmer's model of sequential instruction execution. An MC68000 assembler, as an A linker loader, ID, complements the C and Fortran language compilers, specifically designed to make software development easier. The System v/68 programming environment also provides a set of software tools to aid in efficient and professional tuning and maintenance of application software. These tools include the following. Oakflow is a tool that generates a C flow graph by analyzing a COL lection of C, YAC, LEX, assembler, and object files and builds a graph charting the external references. Motorola Microcomputer Systems and Components 1 to 10, M68N and TBV68. DSDB is a symbolic debugger. dprof is a code profiler that provides, for external symbols, the percentage of time spent between a given symbol and the Next, together with the number of times that functions are called. Dsize is a command that provides section size information for the text, data, and BSS, uninitialized data, sections of the common object files. The total size for the module is also provided. DNM is a command that prints the symbol table of each common object file name. DAR is the archive and library maintainer for portable archives. DMake is a tool to maintain, update and regenerate programs, make only updates a module if it depends on modules that are newer than it. Ddump is a command that provides a dump of selected parts of an object file. Dlint is a checker for C programs. It attempts to detect features of C programs that are likely to be bugs, non-portable or wasteful. DCB is a C program beautifier that produces code with spacing and indentation that displays the structure of the code. CBCAN onicalizes the code to the style of Kernighan and Ritchie. DKexref is a tool that analyzes a collection of C files and builds a cross-reference table. Programmer's Workbench. The Programmer's Workbench is a collection of tools that support the development of large systems of software in a professional and automatic manner. In particular, this includes Source Code Control System, SCCS, which provides the facility to store, update and retrieve all versions, past and present of source code modules. Text processing. Support for text processing under the System v/68 operating system is provided by the inclusion of 4 EDI, TORs, 6, ED, X and SED. X and 6 are full screen editors. ED is a line editor, and SED is a non-interactive stream-oriented editor. The 6 and X editors support a large number of existing terminal types. Through the use of the terminal data base term info, additional entries to term info can be added by the user to support other terminals. System maintenance. RAM-based logical disk allows Release 3 to be booted from tape and run with a memory-based file system. In order to repair a disk or install software on an empty disk, this enhancement allows use of selected system utilities without the use of a hard disk while preserving the standard System v/68 user interface. This capability is intended to facilitate system maintenance and installation. Backup and restore facility. The backup and restore facility is enhanced with a menu interface. This facility provides attended full and incremental backups, scheduling of unattended incremental backups, selective backup/restore of directories, files and subtrees, as well as selective backup restore of files owned by user. Menu interface. A menu-based interface package is provided in System v/168 Release 3. This interface, designed to simplify system administration functions, also serves as a helpful front end for interfacing to System v/68 utility programs. This facility allows command lines to be built interactively and teaches the user command options. As such, this feature is useful for the novice user, and the experienced user can utilize this facility to create and modify menus as well. Motorola microcomputer systems and components. 1 to 11. 2. PBC 104 registered. Motorola.A. VME. Delta Series. Micro Focus Level 2 COBOL. Enhanced Technology Trademark. Highlights. DGSA certified to the Federal High-Level COBOL Standard. D Super High Performance. Execution. D Powerful File Handling. D Program Performance Analysis. D Optimized Memory Utilization. D Powerful Development Tools. General Description. The Micro Focus Level 2 COBOL Enhanced Technology TM Compiler allows large existing ANSI 74 COBOL applications written for mini computers and mainframes to be transferred to VME Series 20 trademark computer systems with minimal code modification. It uses advanced code generation techniques which lead to very high execution speeds, permitting the VME Series 20 computer system to equal the performance of a VAX registered computer running COBOL. Complementing the Level 2 ET compiler is a set of development tools, namely, the Animator debugging facility, the Forms 2 trademark, Forms Generator and Upgrade 3 trademark, a RM/COBOL registered to Level 2 ET source. Code Conversion Utility. The Micro Focus Level 2 COBOL ET compiler meets the Federal High-Level ANSI 74 COBOL standard, with 0 error established by the U.S. Government General Services Administration GSA, and also conforms to the COBOL standard defined by the X/Open Group of European computer manufacturers. For application developers, Micro Focus LE, L2 COBOL ET permits COBOL application programs written for most mainframe and mini computers to be ported onto the VME Series 20 computer systems operating under the System v/68 trademark operating SYS TEM. The System v/68 operating system is derived from AT&T's Unix registered System v. The available application software consists not only of the large base of Level 2 COBOL applications, but also other COBOLs such as RMI COBOL. Additionally, the Level 2 COBOL ET application development environment increases programming productivity by allowing programmers to create, modify, and maintain more applications faster and with greater quality than otherwise possible. The fast compile speed of the Level 2 COBOL ET package reduces the time spent during the debugging cycle, because the programmer typically needs to compile several times in order to stabilize the program. This allows VME Series 20 computer SYS TEMs to be used as cost-effective, highly productive application development and maintenance stations at data processing mainframe installations. For end users, Micro Focus Level 2 COBOL ET provides access to a wide range of existing application packages written in Level 2 COBOL. This permits the VME Series 20 computer SYS TEMs to be employed as departmental systems using the existing suite of mainframe COBOL application programs. Description. The Micro Focus Level 2 COBOL ET compiler supports all the features included in the Federal High-Level standard and contains extensions to complement and take advantage of The interactive benefits and capabilities of the VME Series 20 computer SYS. TEMS operating under the system v/68 operating system. Significant attributes include Motorola microcomputer systems and components. 1 to 12. PBC 104. GSA high-level conformity. With zero error, the level 1/COBOL. ET compiler meets ANSI X 3.23 1974. COBOL to the federal high level, the highest level of COBOL implementation defined by the U.S. government. The GSA test consists of 225,000 lines of COBOL program source code that comprises 5,500 different tests, designed to ensure that the standard is followed absolutely. This compiler is the only Unix-based system COBOL compiler to have passed these tests with zero error. Enhanced interactive screen handling. Extensions beyond ANSI 74 COBOL to the accept and display verbs. Facilitate more flexible user configurability. Screen handling. Extensions include cursor addressing, protected fields, automatic zero suppression, calculator style input with function key handling and highlighting, data verify, cation and cursor position detection. The extensions enhance the ANSI standard to allow COBOL program MERS to handle screen input/output. File support. 4 file formats are supported by the compiler: relative, sequential, line sequential and index sequential. Relative files allow random and sequential access to records in a mass storage file. Each record in a relative file is identified by an integer value greater than 0, which specifies the record's position in the file. Sequential and line sequential files allow records to be accessed sequentially in the order they were written. The line sequential structure is an extension to ANSI 74 COBOL, which allows for reading files created by a text editor. Line advancing is a feature that allows the user to create files for printing. These files have the necessary control characters to print on a standard printer. Index sequential file handling is implemented through a fast B-tree structure that is self-balancing. It allows use of alternate keys with duplicates. Records can be accessed randomly or sequentially. Each record in an indexed file is uniquely identified by the value of one key within the record, and can have up to 63 alternate keys. A data record and its key can be deleted from a file. Its space in the index and data files is then made available for another record to be added. The maximum file size can be up to 1 byte, limited only by the disk size. Index key length extends to 120 bytes. And the maximum record length is 8,191 bytes. The file handling facility allows data files to expand as required by the application. This ensures that disk space is used efficiently. Cross-reference listing. The Micro Focus Level 1/COBOL ET compiler's cross-reference facility provides users and programmers with an additional compiler listing to aid debugging. Large program size allowed. A Level 1/COBOL ET program can include multiple segmented procedural code of 16 bytes per segment, up to 800 bytes of code. In addition, The programmer can arrange to dynamically load as many as 100 programs, segmented and / or non-seg meant. There are virtually no limitations on the table size. An addressable data item can be as large as 256 bytes. Enhanced multi-user support. Multi-user support is available with the CISAM registered package, which allows file sharing and record locking for indexed files. The Level 1 / COBOL ET communication module is full / Y implement to the GSA standard. The Level 1 / ET compiler also supports file locking for sequential, relative and line sequential files and record locking for sequential and relative files. Motorola Microcomputer Systems and Components 1-13 I. PBC 104 Runtime specification of file names. The Level 2 COBOL ET package allows programmers and users to specify external file names, program names and Unix pipes dynamically at runtime. For example, the printer spooler can be specified directly. Fast compilation. The Level 2 COBOL ET compiler produces intermediate code from the programmer's source in a single pass. This allows very fast compilation, typically more than 1000 lines per minute. Testing and debugging is carried out using this intermediate code, thus keeping the development cycle as short as possible. Finally, when the code is fully debugged, the intermediate code is converted to machine code just once using the appropriate native code generator. Optimized memory utilization. Optimized memory utilization eliminates the need for each user to have a copy of the development software in memory. This capability frees valuable memory space, thereby increasing system performance. Performance analysis tool. A programmer may use a compiler directive that allows the creation of a file dynamically at runtime, which will contain statistical data reflecting the overall usage of a paragraph handler section. This data can be accessed by an analysis utility to provide specific areas that may be enhanced to increase the speed and performance of the application. Full Unix support. Level 2 COBOL ET supports all SYS TEMV/68 operating system features, including terminal handling, directory handling, calls to C subroutines, Unix utilities, programs in other programming languages, file handling, performance analysis and dynamic memory capability. Source maintenance flexibility. Source code can be kept in other variations of COBOL, such as RMI COBOL, and passed through a very fast preprocessor during every program compilation, or the program can be converted a single time to micro focus Level 2 COBOL ET source code by using the preprocessor as a converter. This gives the application programmer the option of keeping and maintaining the source code in either dialect of COBOL. Powerful development tools. Complementing the Level 2 COBOL ET compiler is a powerful set of optional development tools, the ONI Matter source code level program analysis and debugging tool to help debug and maintain programs, and the Forms 2 source code generator, which automates the writing of Active screen display programs. Animator allows direct observation and control of a program's execution, statement by statement at the source code level. In addition, it allows the programmer, at any point during the run, to break in and halt the execution of the program. Access is then provided to a main menu of commands that allow interrogation and modification of data values, alteration of the control flow, replay of any part of an execution, what-if analysis, and many other program analysis and debugging capabilities. The animator software speeds up the debugging process of new programs, but it also makes it easier to understand and maintain existing programs. The Forms 2 generator is a powerful visual programming tool designed to speed the creation of interactive screen handling programs. The Forms 2 product is extremely user-friendly. It allows the programmer to use the keyboard to paint a form directly on the screen, exactly as it will appear to the user at runtime. The Forms 2 software then automatically generates the COBOL source code to handle the screen. Motorola Microcomputer Systems and Components 1-14 PBC 104 Specifications. Verbs. Except at. From CRT. From console. Add dash. Giving. Corresponding. Atter. Call using. Cancel. Close. Computer. Copy. Replacing. Delete. Disable. Display at. Upon CRT. Upon console. Divide into. Rounded. By. Remainder. Enable. Enter. Exit. Program. Go dash. Depending. If and slash or. Else. Next sequence. Inspect tallying. Replacing. Tallying slash replacing. Merge ascending. Descending. Move. Corresponding. Multiply. Open input. Output. -1 to 0. Extend. Perform through. Through times. Through until. Through varying. Read into. Next. Receive. Release. Return. Rewrite. Search varying. All. Send. Set dash. Up by. Down by. Sort ascending. Descending. Stop. String. Subtract from rounded. From giving. Unstring. Use after. Debugging. Procedure. Debugging data. Write from. Before. After. File types. Relative. Sequential. Line sequential. Index sequential. Access mode. Dynamic. Random. Sequential. Conditions. Alphabetic. And slash or. Equal. Greater slash less. Not. Numeric. Positive slash negative. 0. Documentation. The following manuals form the documentation set for the Micro Focus Level 2 COBOL Enhanced Technology Product. Language Reference Manual. Level 2 COBOL ET Operating Guide. Getting Started Manual. Animator Operating Guide. Optional. Forms 2 Operating Guide. Optional. The Error Message Manual. The Upgrade 3 Operating Guide. Motorola Microcomputer Systems and Components. 1 to 15. I. PBC 105 Registered. Motorola. VME. Delta Series. SNA and BSC. Highlights. 03274 SNA Interactive. 03770 SNA RJE. 03274 ESC Interactive. 02780 RJE. 03780 RJE. OHASP RJE. General description. The VME Series 20 supports a broad offering of system network architect, tour, SNA, and binary synchronous BSC communication facilities which run with the System v/68 trademark operation system. Both interactive and batch protocol products are supported on the Series 20. All protocol products are supported by an intelligent communications controller which uses a Motorola 68010 microprocessor and features 512 KB of dynamic RAM to offload the main system application processor from supporting the communication protocol. 3274 SNA description. The 3274 SNA product provides 3274 type commands, orders, field and character attributes, attentions, control characters and address sequences. The following IBM 3274 devices are emulated. 03274 Model 51C Control Unit. 03278 Model 2 and 5 Display Stations. 03287 Model 2 Printer, DCS and SCS modes. Communication products. 03279 Models 2A and 2B Display Stations. Attributes of the IBM 3278 Model 2 PlayStation are supported. These include Protect, Non-Display, High Intensity and Numeric. Attributes for Extended Highlighting and Extended Color are also supported. The work stations display 24 lines with 80 characters per line or 27 lines with 132 characters per line. 3274 SNA features. OEBPIC character set. OList and dial line support. 1200 to 9600 bps over half duplex. Facilities. 024 programmable function, PF. Codes. User menu. Multiple sessions on each terminal. System status line. 3770 SNA description. VME Series 20 supports unattended operation for the transfer of files. The user is provided with system status capability. For example, record counts may be displayed on the terminal card reader. Files and console keyboard input data are accepted. Output device files include printer and card punch files. 3770 features. Compatibility with IBM 3776 or 3777 Model 3 or 4, SNA MLU. Multiple logic unit devices. O unattended operation. O leased or switched line support. O up to 9600 bps, half duplex. O console support. O space compression and X. Pansion. O transparency. O decompaction of host to terminal. Data streams. O spooled and direct print kappa. Bilities. The 3770 SNARJE product enables 3274 ESC description. The user to transfer batch data to and the 3274 binary synchronous COM from an IBM SNA host. The system. Motorola Microcomputer Systems and Components. 1 to 16. PBC 105. Communications program emulates the 3274 BSC system. It provides support for 3274 type commands, orders, field and character attributes, attentions, control characters and address sequences. The following IBM 3274 devices are emulated. O3274 Model 51C Control Unit. O3278 Model 2 and 5 Display Stations. O3287 Model 2 Printer. O3279 Model 2A and Model 2B Display Stations. Attributes of the IBM 3278/3279 DIS. Playstations are supported. These include Protect, Non-Display, High Intensity and Numeric. Attributes for Extended Highlighting and Extended Color are also supported. The work stations display 24 lines with 80 char actors per line or 27 lines with 132 characters per line. 3274 SSC features. D-leased and dial-up line support. O1200 to 9600 bps over half duplex. Facilities. OEBC to C character sets. O24 programmable function, PF. Codes. O system status line. O user menu. O multiple sessions on each terminal. 2780/3780/HASPRJE description. These batch transmission products enable the user to communicate to another system or to a host computer using standard IBM 2780/3780/HASP RJE protocols. A range of printers is available to support hard copy output. Unattended operation allows the SYS TEM to send and receive files without operator intervention. Leased or dial up capability supports from 1200 bps to 9600 bps over half duplex, leased or private, non-switched lines and from 1200 bps to 4800 bps over half duplex dial, switched lines. The 3780/HASP space compression and expansion features are supported. Consecutive spaces are compressed from the data prior to transmission and consecutive spaces are inserted as data is received. Transparency allows any 8-bit data configuration to be sent or received. This enables object code and binary files to be transmitted to another system. 2780/3780/HASP RJE features. OIO devices include card reader, card punch and printer files. O unattended operation, auto answer and auto disconnect. O leased and switched line sup port, 1200 to 9600 bps. O space compression and expand. Xyon, 3780 NHASP. O transparency. O point-to-point configuration. O console support. Motorola microcomputer systems and components. 1 to 17. PBC 106 registered. Motorola. VME. Delta series. 8-port serial controller. Highlights. D8 asynchronous RS-232C. Ports. D up to 4 controllers per system. D up to 19,200 bps on all ports. D 10 MHz MC68010. Microprocessor. D VMware compatible with. Double high Eurocard form. Factor. D buffered pipe communications. Protocol. D driver for Motorola system. V/68 operating system. Available. General description. The 8-port serial controller provides the VME Series 20 with an 8-chan NEL asynchronous interface between its VMware and serial peripheral devices. Built around a MC68010 microprocessor, the controller improves the speed of data transfer and offloads the system's central processor from serial communications controlling tasks. It handles I/O-related functions without having to interact with the central processor, thereby increasing overall system performance. Each serial port can operate individually at speeds up to 19,200 bps. Typical applications for the 8-port serial controller include connections to asynchronous devices such as terminals, printers, and modems. Hardware overview. Controller microprocessor and memory. A powerful MC68010 running at 10 MHz is the microprocessor on the controller. This processor controls all connect devices through local data address and control buses. Local memory includes 32 KB of EPROM and 128 KB of dynamic RAM. The EPROMs contain the firmware resident ICC program that is copied to and executed from RAM after power up reset. The RAM also holds the intermediate I/O data to be processed and transferred. VMware interface. The MC68010 microprocessor accesses VME system memory through a VMware master interface with software selectable address mod. IFIR codes. VMware is the leading 32-bit industry standard bus. This important fact gives systems integrators and OEMs the flexibility to build high-performance systems for many different types of applications. Peripheral interface. 4 serial communication controllers are utilized, each providing 2 independent channels. These controllers perform the peripheral data transfer and data link control functions at the hardware level. Port speeds, ranging from 50 to 19,200 bps, as well as data characteristics and control functions, are all software selectable. Timers. The serial controller has a time slice. Motorola microcomputer systems and components. 1 to 18. PBC 106. Generator, which is a programmable counter that generates periodic interrupts to the local microprocessor. Controller firmware requires these interrupts RUPS for its time slice-based executive. Concept. The watchdog timer is a free-running counter which is periodically reset by the executive. Should the executive lose control, the watchdog counter will time out and turn on the fail LED on the board. Software overview. The 8-port serial controller has DED ICAted firmware in local ROM for controlling 8 asynchronous communications channels, each with individual character processing and control functions. The controller has a standard I/O independent interface. It receives macro commands through a pipeline structure in system memory, which is shared by the VME series main processor and the serial controller. The serial controller resident firmware program interprets and executes macro commands, and returns status messages through the second pipeline. After completion, the transfer of commands and status messages follow Motorola's buffered pipe protocol for interprocessor communications. Character processing during input is controlled via 3 user tables: the Receive Translation Table, RTT, the Immediate Receive Action Table, IRAT, and the Receive Action Table, RAT. The equivalent tables for output are the Write Action Table, WAT, Trans. MIT Action Table, TAT, and the Trans. MIT Translation Table, TTT. RTT and TTT can be used to translate from one standard to another, and from lowercase to uppercase. The translation tables can also be used to accommodate keyboards encoded in different languages. Serial controller firmware also contains self-test routines, which are executed after system reset, as well as diagnostics. Driver support for Motorola System V/68 operating system, an enhanced version of AT&T's Unix System V, is available. Specifications. 8-port serial controller. Up to 4 controllers per system. 8 asynchronous RS-232C ports. 10 MHz MC68010 microprocessor. 128 KB RAM. 32 KB ROM. Port selectable. 50 to 19,200 bps. 1.5 or 2 stop bits. 5 to 8 data bits. Odd, even or no parity. DTR, DSR, RTS, CTS, and DCD control. Functions. Buffered Pipe Protocol, BPP, for communications. Environmental. Power requirements, +5 VDC, plus or minus 5%, 2.6 A, tip. 3.2 A, max. Operating temperature, 0 degrees to 55 degrees Celsius. Non-operating temperature, 40 to 100 C. Relative humidity, 0% to 90%, non-condensing. Physical height, 9.2 inches. 233 millimeters. Depth, 6.3 inches. 160 millimeters. Motorola Microcomputer Systems and Components. 1 to 19. IPBC 107. Registered. Motorola. VME. Delta Series. Ethernet LAN controller. Highlights. O Ethernet, version 2.0. Compatible. O conforms to IEEE 802.3 LAN. Standard. O performance up to 10 bits per second. 010 MHz MC68000. Microprocessor. 512 KB RAM memory. 32 KB EPROM. Buffered pipe communications. Protocol. VMware compatible with double high Eurocard form. Factor. General description. The Ethernet LAN controller is an advanced communications processor, which gives the VME Series 20 family of computer systems interface capabilities to a high-performance Ethernet local area network. It conforms to the IEEE 802.3 local area network specification CSMLCD and VMware Indus TRI standards. The controller is also fully supported by Motorola System V/68 operating system, an enhanced version of AT and 1's Unix system V. The LAN controller helps to free the VME Series 20 CPU from a significant protocol burden by means of a double high Eurocard design, insert, porting an MC68000 microprocessor SOR and a VLSI LANs controller. Data transfer across the physical VMware interface between host and LAN module is accomplished using a shared memory interface. Hardware overview. Controller, microprocessor and memory. The 10 MHz MC68000 microprocessor is responsible for moving commands and data to and from system memory, and responding to and generating VMware interrupts. Other functions include executing the network and transport XNS layers, providing timer functions and controlling the LANs in its execution of the data link protocol. The Ethernet LAN controller has 512 KB of dynamic RAM with parity. The memory is accessible from the VMware LANs and the MC68000 MPU for use by protocol processing software. The Ethernet LAN controller has a timer, which causes the onboard MPU to be interrupted every 2 milliseconds. Local area network controller for Ethernet LANs. The LANs is a VLSI device used for interfacing the microprocessor system to the Ethernet local area network. It is designed to operate in an environment comprising local memory and the microprocessor. Memory serves as Motorola microcomputer systems and components. 1 to 20. PBC 107. The communication link between the microprocessor and the LANs, and as a buffer for the Ethernet packets. LANs operates at a 10 bit per SEC on data rate and is MC68000 compatible. Some of its specific features include a 16-bit data bus, a multiplexed address/data bus, a DMA controller with 24-bit addressing, and a 48-byte data buffer. The 48-byte data buffer reduces the initial response time so that once DMA is initiated between LANs and local memory, an average of one word is transferred each 1.6 microseconds. It also features diagnostic aids, 3 modes of destination address comparison, executes a CSMA/CD net work access algorithm and provides extensive error reporting. Individual packet errors reported by LANs include CRC error, framing error, and overflow and underflow. VMware interface. The Ethernet LAN controller's interface is today's leading 32-bit bus standard, the VMware Along with the double high Eurocard form factor, the VMware interface allows the LAN controller to be an important part of the VME Series 20's modularity. This modularity offers both systems integrators and OEMs a high performance Ethernet LAN controller that will meet both present and future needs. Software overview. Operating system, and provides a communications executive kernel which controls the LAN's hardware. The software is highly modularized and supports Oslo's 7-layer interconnection model. Transfer of commands and status messages follow the Motorola standard buffered pipe protocol BPP. System v/68 drivers. Device drivers running under the Motorola System v/68 operating SYS TEM are also provided. For further flexibility and ease of use, the bus interface between the host system and the LAN controller utilizes a shared MEM/ORI protocol. Communications executive kernel. The LAN controller kernel performs all functions required for controlling and monitoring the LAN controller hardware. Kernel functions include managing LAN status registers and LAN's controlled message descriptor rings, performing timer functions, and managing interrupts and retrieving LAN's generated statistics. The communications executive executes on the LAN controller microprocessor to supervise the LAN's chip in its processing of XNS. A VLSI serial input/output adapter provides Manchester encoding/decoding for the Ethernet interface. Protocols for higher layer software. The Ethernet LAN controller is sub-XNS implementation is featured as applied with VME Series 20 specific soft higher layer software support for the ware and firmware. The software sub-LAN controller. The following XNS Pro ports the Motorola System v/68 tokens are included. O Internetwork Datagram Protocol formats Internet packets and performs Internet addressing and routing. O Transport Layer Protocol, RES. Ident protocol that handles echo, error, sequenced packet exchange and routing in formation. Self-tests and diagnostics. Upon power up or system reset, the Ethernet LAN controller executes a series of ROM-based self-tests to determine that the controller is functioning properly. Tests include a LAN's register and loopback test, a microprocessor test, a memory test for the dynamic memory, an EPROM checksum test and a status and control register test. Specifications. LAN communications and standards. Ethernet, version 2.0 compatible. Conforms to IEEE 802.3, CSMNCD, LAN standard. Buffered Pipe Protocol, BPP, for communications. Performance. Up to 10 bits per second. Microprocessor. 10 MHz MC68000. Connectors. VMware, DN #41612C96. Ethernet transceiver port cable, AMP74S094-1. Power requirements. 3.8 Na plus SVDCC, S%. 0.6 AI/I plus 12 VCC, S%. 0.1 A, A12 VDC plus or minus S%. Environmental tolerance. Operating temperature, SOC to SO degree C. Storage temperature, 40 degrees Celsius to 8 SOC. Humidity range, 0% to 9%, non-condensing. Mechanical specifications. Height x depth, board 9.2, 234 mm, x 6.3. 160 mm. Height x width, front panel 10.3, 262 mm, x 0.79. 20 mm. Motorola microcomputer systems and components. 1 to 21. IPv6 108. Registered. Motorola. VMware. Delta series. Intelligent communications. Controller. Highlights. D6 synchronous / asynchronous. Communications ports. DSDLC, HDLC, and BSC protocol. Support. D up to 2 controllers per system. D10 MHz MC68010. Microprocessor. D5 12 KB dynamic RAM, 128 KB. ROM. O buffered pipe communications. Protocol. O VMware compatible with double high Eurocard form. Factor. General description. The Intelligent Communications Controller supports SDLC, HDLC, and BSC, and is designed for use in the high-performance VMware Series 20 family of computer systems. As an intelligent controller, it can handle I/O-related functions locally, thus relieving the applications processor of the serial communications control functions, often required in networking applications. The Intelligent Communications Controller features control and interfaces for 6 high-performance, asynchronous or synchronous serial ports, with a 4-channel DMA controller. Each serial port is port selectable and can operate from 50 to 19,200 bps. Based on a high-performance MC68010 microprocessor with 512 KB of RAM memory, the Intelligent Communications processor has a double high Eurocard form factor, making it a highly flexible controller for many types of applications. Hardware overview. Communication transition modules. Any of the 6 serial channels can be individually configured for RS-232C operation using communication transition modules. Each serial port can be configured independently as data CIR, quit terminating equipment, DCE, or as data terminal equipment, DTE, by means of jumpers on the transition module. Communications processor and memory. The main processing unit on the Intelligent Communications controller is a 10 MHz MC68010 microprocessor. It has 8 32-bit registers with a 24-bit address bus and a 16-bit data bus. The communications processor has 512 KB of RAM memory and 128 KB of ROM memory. Data is written and read from RAM without MPU or DMAC wait states. The generation and checking of byte parity is performed automatically during RAM accesses, and a detected parity error causes interrupts to the communications processor. Refresh of the dynamic RAM is automatic with local arbitration logic controlling the access/refresh cycles. VMware interface. The Intelligent Communications Controller supports the leading industry standard VMware. By doing so, it represents a high-performance controller for integrators and OEMs who offer the VME Series 20 family of systems, Motorola microcomputer systems and components. 1 to 22. PBC 108. Transfer of commands and status. Messages follow the Motorola standard buffered pipe protocol for inter-processor communications. 2 access modes are provided. The window addressing mode, in which a 4 MB local address map is used as a window to the VMware, and the alternate addressing mode, in which an address attention register is used to obtain mapping of a contiguous 16 MB address space. Peripheral interface. 4 ports can be configured for OMA data transfer, offering 4 half-duplex or 2 full-duplex OMA channels to the VMware. Under local OMA control, data can be transferred between SYS TEM and local memory, between SYS TEM memory and devices on the serial channel, and between local memory and devices on the serial channel. Transfer of both bit and byte data is supported, and each port can be programmed for a number of different synchronization modes, both monosynchronous and bisynchronous modes, with or without CRC generation and checking, can be used for byte data transfer. The SOLC and HOLC protocol with automatic CRC generation and checking can be used for the transfer of bit data. An underrun causes generation of an interrupt to the communications processor. For the synchronous transfer of byte or bit data, odd, even or no parity may be programmed, and NRZ, NRZI, or FM coding may be selected. When asynchronous data transfer is desired, the following parameters can be programmed: 50 to 19,200 bps. Baud rates, odd, even or no parity, 1, 1.5, or 2 stop bits, 5 to 8-bit character lengths, and NRZ, NRZI, or FM data encoding. Software overview. The Intelligent Communications Controller supports 2780/3780 BSC, 3274. SNA 3770 SNA 3274 BSC, and HASP. BSC communication protocols. The controller also has power-up self-test and internal diagnostic capabilities. Specifications. Intelligent Communications Controller. Up to 2 controllers per system. 6 synchronous/asynchronous communications ports. 10 MHz MC68010 microprocessor. 512 KB RAM. 128 KB ROM. SOL. HDLC and BSC protocol support. Port selectable. 50 to 19,200 bps. 1, 1.5, 2 stop bits. 5 to 8 data bits. Odd, even or no parity. NRZ, NRZI, or FM encoding. Buffered Pipe Protocol, SPP, for communications. Environmental. Power requirements, plus 5 VDC, plus or minus 5%, 3.8A, tip. 4.4A, max. Operating temperature, 0 to 55 degrees Celsius inlet air, forced air. Cooling. Storage temperature, 40 degrees to 100 degrees Celsius. Relative humidity, 0% to 90%, non-condensing. Physical. Form factor, double high Eurocard VME board with front panel. Board dimensions. Height, 9.17 inches. 233 millimeters. Depth, 6.3 inches. 160 millimeters. Front panel dimensions. Height, 10.3 inches. 262 millimeters. Width, 0.79 inches. 20 millimeters. Motorola Microcomputer Systems and Components. 1 to 23. PBC 109. At Motorola VME. Delta Series. SMD Disk Subsystem. Highlights. D337 MB to 1348 MB of unformatted storage capacity. D 20 milliseconds average. Positioning time. D low acoustical noise level. D drive MTBF of over 20,000 hours. DMC 68000 based intelligent controller. D0 latency reads and writes. D1:1 interleave over multiple cylinder. D data rates up to 24 bits per second. General description. The SMD disk subsystem includes DSMD disk drive, DSMD controller, DSMD subsystem enclosure, SMD disk drive. The SMD8 disk drive provides 337 MB of unformatted storage capacity in a compact module. The average positioning time of 20 milliseconds and the data transfer rate of 2.458 megabytes per second combined to maximize data throughput and system efficiency. A high-speed version of the industry standard SMD interface is provided as part of the onboard electronics. The SMD disk drive is highly reliable. This high reliability is assured by providing a contamination-free environment. Advanced Winchester technology simplifies the disk mechanism, and the head IC prevents read errors caused by external electrical noise. With these features, the SMD disk drive assures a mean time between failures, MTBF, exceeding 20,000 power on hours. 1 or 2 disk drives can be configured in one enclosure for a total capac ITY of 674 megabytes. The VME Series 20 supports 2 SMD disk subsystems with 4 drives for a capacity of 1348 megabytes. Using 2 controllers. SMD controller. The SMD controller supports the following important features. D virtual buffer architecture with onboard MC68000 processor. D supports up to 2 SMD disk drives. D ultra high-speed DMA with bus throttling. D onboard 32-bit ECC. D scatter/gather commands. The SMD controller is a powerful and intelligent controller with data rates up to 24 bits/section. It utilizes the power of the Motorola MC68000 microprocessor. The virtual buffer architecture is the key to zero latency operation. This important feature maximizes data transfer and reduces disk latencies. Memory overruns and underruns often found in less sophisticated FIFO designs are eliminated. Using a large pool of dynamically allocated buffers, data is read as soon as the head lands on the track and then immediately Transfers all sectors of interest regard less of their order on disk. This process never takes more than a single disk revolution to transfer an entire track of data. The number of interrupts the host must process and the amount of I/O it must perform to accomplish each transaction is minimized. This frees the host. Motorola Microcomputer Systems and Components 1-24 PBC 109 Processor and the system bus for other activity. By operating the DMA at a high speed, once it is on the bus, the SMD controller preserves bus bandwidth. Thus, it minimizes the time required for each transaction, thereby preserving the bus bandwidth for other system activity. Another advantage of the virtual buffer design is that after requested sectors are read and transferred, the SMD drive specifications. Storage capacity, unformatted 337.10 megabytes. Storage capacity, formatted 269 megabytes. Disks, 8-inch 6. Heads, read/write, 10. Servo, 1. Track capacity, unformatted 40,960 bytes. Tracks per cylinder, 10. Cylinders, 823. Sectors, fixed 2 or more, max 128. Positioning time, track to track, 5 milliseconds. Average, 20 milliseconds. Maximum, 40 milliseconds. Average latency time, 8.3 milliseconds. Rotational speed, 3,600 rotations/minute. Recording density, 19,734 bits/inch. Track density, 683 tracks/inch. Data transfer rate, 2,458 megabytes/second. Recording code, RLL, 2/7. Interface code, NRZ. Interface, HSMD. Controller will continue to read and cache sectors. When subsequent requests from the host are made for that data, it is transferred from cache. Without disk access. SMD subsystem enclosure. The enclosure is identical in appearance as the VME Series 20 system enclosure except for the filler and operator panels. The drives are cooled by fans that provide low operating temp. Physical specifications. Height, 25.6 inches. 65.0 centimeters. Width, 12.5 inches. 31.8 centimeters. Depth, 28.0 inches. 71.1 centimeters. Paratures which extend the life of the drives. Each drive is housed in a subassembly. The drive subassembly slides in and out of the enclosure. The drive can be functionally tested and inspected when slid out the front of the enclosure, while still protected in its subassembly. The operator panel provides indicators for power, ready, and fault for each drive. Weight, 135 IBS. 61 kilograms, fully loaded. Environmental and safety specifications. Safety. Meets all 478, EDP, and 114, office equipment. Meets CSA 154, EDP, and 143, office equipment. Meets VDE 0806/8.81, office equipment. Meets IEC 380, office equipment. Emissions. Meets VDE 0871/6.78, Class A. Meets FCC Part 15, Subpart J, Class A. ESD. 5000 volts, no observable effect. 12,000 volts, no operator perceived errors. 24,000 volts, no permanent equipment damage. Head positioning method, servo-controlled track following. Start time, 50 seconds, nominal. Altitude. Operating, 10,000 feet ASL. Non-operating, 30,000 feet ASL. Stop time, less than 40 seconds. Mean time between failures, MTBF more than 20,000 power on hours. Error rates, recoverable errors, 10 per 10 bits read. Unrecoverable errors, 10 per 10 14 bits read. Seek errors, 10 per 10 seeks. Acoustic noise level. 55 dBA maximum. Temperature. Operating, 5 degrees Celsius to 40 degrees Celsius. Non-operating, 40 degrees Celsius to 60 degrees Celsius. Relative humidity. Operating, 10% to 80% RH, non-condensing. Non-operating, 10% to 90% RH, non-condensing. Shock. Operating, 0.5 G. Non-operating, 15 G. Transportation. Packaging and shipping containers and procedures comply with the current NSTA. Pre-ship test procedures. Shipping container. Height, 34.5, 87.6 centimeters. Width, 22.5, 57.2 centimeters. Length, 41.0, 104.1 centimeters. Motorola Microcomputer Systems and Components. 1 to 25. IPBC 110. Registered. Motorola. VME. Delta Series. Model 2616 Computer System. Highlights. 1 Motorola MC68020 Processing Power. 012 slot VME compatible enclosure. 02 to 12 MB of main memory. 02 to 34 Rs 232C asynchronous ports. 085 to 728 MB of integral Winchester disk storage. 0 up to 1.3 GB of external SMD capacity. 060 MB streaming tape. 0 software compliant with System.v interface definition, SVID. 0 comprehensive local and remote diagnostics. General description. The VME Delta series of 32-bit computer systems is based on the Motorola MC68020 microprocessor, the VMware standard, and Unix SYS. TEMV Release 3. The Model 2616 uses the 16.7 MHz MC68020 and supports up to 34 serial devices. The power of the MC68020 plus the expandability and flexibility of the VMware architecture make the Model 2616 an ideal computer solution for commercial, technical, and networking applications. The Model 2616's 12-slot VME card cage adapts to most application interfaces and supports large configurations. In addition, the system enclosure accommodates up to 4 disk drives plus a streaming tape. External SMD and tape subsystems are also supported. Both local and wide area communications protocols link the Model 2616 to industry standard networks as well as host computers. Hardware overview. The Model 2616 hardware includes J. The system enclosure, O. The VMware bus, O. The applications processor and memory. System enclosure. The VME Delta Series floor enclosure offers a 12-slot VME compatible card. Cage, a 12-slot VME cable connection. Area, and an SMD and tape subsystem. Cable connection area. This provides connectivity to a diverse and large NI chamber of peripheral devices. The unit houses a streaming tape drive and up to 4 5-1/4 disk drives. One of the disk drive slots is used for half-height diskette drives when required by the configuration. All drives are held in shock-mounted O1/0 and communications con drive assemblies. Trollers O. The enclosure contains a 450 watt mass storage devices switching power supply and is cooled. O local and remote diagnostic by filtered air. Capabilities. Motorola microcomputer systems and components. 1-26. PBC 110. VMware bus. The VME Delta series uses today's leading 32-bit bus standard, the VMware bus. The VMware bus, in conjunction with the double high Eurocard form factor, offers systems integrators and OEMs high performance as well as access to an expanding set of readily available controllers and system components. The Model 2616's 12-slot VME compatible card cage also allows the system to grow in a modular fashion to meet future as well as current requirements. In addition, upgrading the Model 2616 to a more powerful VME Delta series model is as simple as replacing the processor and memory boards. Main processor. The Model 2616's main processor includes a 32-bit 16.7 MHz MC68020 microprocessor, a zero-weight state cache accelerator, an MC68851 paged memory management unit PMMU, and a floating point coprocessor. 2 RS-232C ports are included. These are normally used for a console port and a remote service modem. The MC68020 has an on-chip 256-byte instruction cache. The processor uses the high-speed vSphere for parity memory access and the VMware bus to interface 1/0 controllers. The MC68881 floating point coprocessor implements the IEEE floating point standard plus trigonometric and transcendental functions. Memory. Up to 12 MB of main memory are offered on the Model 2616. Both ECC and parity memory options are available. ECC memory comes in 4 MB increments and provides single-bit error correction and double-bit error detection. A 64-bit cache register gives fast access using the VMware bus interface. Parity memory comes in 2 MB increments and provides byte parity generation and error checking. These memories are dual-ported via Turing concurrent processor and 1/0 access using the vSphere and VMware bus, respectively. Disk and tape controllers. The Model 2616 supports controllers for 5-1/4 Winchester and floppy disk drives, 5-1/4 ESDI Winchester disk Drives, 8 SMD disk drives, 1/4. Streaming tape, and 1/2 9-track tape. Drives. All are intelligent controllers. With DMA-VME system interfaces. This selection of VME-compatible disk and tape alternatives allows the Model 2616 to satisfy a wide spectrum of performance and application requirements. Intelligent communications controllers. VMware-compatible controllers are offered for asynchronous devices, termin, ALS, printers, modems, etc. LSNA and BSE communications. And Ethernet local area networking. Each intelligent controller uses a 10 MHz MC68000 FAME microprocessor. The 8-port serial controller can support 8 asynchronous terminal, printer, or modem ports. Because each port can be independently configured, TH's controller can be adapted by the system integrator or OEM to support a wide range of serial devices. The Model 2616 supports up to 4 serial controllers. Controllers. Controller. Winchester and floppy. Winchester. SMD. Streaming tape. 1/2 9-track tape. 8-port serial. Communications. Ethernet. Interface. ST506. SA400. ESDI. ESMD. OIC02. PerTech. RS232C. RS232C. CSMLCD. Number of channels/drives. Transfer rate per second. Up to 5 bits. Up to 250 kbits. Up to 10 bits. Up to 24 bits. Up to 90 kbytes. Up to 1.25 bits. Up to 19.2 kbits. Up to 19.2 kbits. 10 bits. Controllers. For system. Mass storage devices. Form-fit interface unformatted formatted average drives. Capacity access time per system. Disk drives. 5-1/4 SA401 MB 655 KB 181 milliseconds to 5-1/4 ST50685 MB 67 MB 28 milliseconds for 5-1/4 ESDI 182 MB 161 MB 16.5 milliseconds for 8 ESMD 337 MB 269 MB 20 milliseconds for tape drives. 5-1/4 OIC 0260 MB 1/2 9-track PerTech 1600 BPI 45 MB 3200 BPI 90 MB. Motorola Microcomputer Systems and Components 1 to 27 I PBC 110. The Intelligent Communications Controller supports bit and byte oriented protocols like SDLC, HDLC, and SSC. Each port is independently programmable. A 4-channel DMA controller is included for high performance applications. The Intelligent Ethernet LAN controller is compatible with Ethernet version 2.0 and conforms to the IEEE 802.3 CSMLCD LAN standard. The controller interfaces with the network at 10 Mbps. Mass storage devices. The base model 2616 contains an 85 MB or a 182 MB 5-1/4 Winchester drive and a 5-1/4 60 MB streaming tape for system backup and software distribution. Some configurations also include a floppy diskette which uses a disk slot. The system can be expanded to 728 MB of Winchester disk storage and 1348 MB of SMD disk storage using two SMD disk subsystems. Local and remote diagnostics. The VME Delta series system diagram. Gnostics are oriented to centralized service networks and user participatory fault identification. They enhance the system's overall reliability, service ability, and maintainability with the following diagnostic features. D. Hardware integrity verification at system power up and reset. D. Firmware-based system tests and operating system-based confidence tests. D. Menu-driven user interface with online help facility. D. Custom test suite generation, evaluation and debug tools. D. Remote test and diagnostics with integral service modem. The Model 2616's comprehensive SYS TEM diagnostic facilities are designed to support very cost-effective customer and product service approaches. Software overview. In addition to the following software products, a large number of software applications are available from independent software vendors which will run on the VME Delta series. Unix System V operating system. System VL68 Release 3 is Motorola's version of AT&T's Unix System V. Release 3. Release 3 includes the following new features and enhancements. L. Remote file sharing, which allows users to share files, data, and peripheral devices across computer systems attached to a local area. Network. L. Streams, which supports application development independent of the underlying network protocols. And virtual memory and demand paging support for efficient memory utilization and simpler application development. J. Menu interface for system administration functions. L. Support for the MC68881 floating point coprocessor and complete backup and restore facilities. System VL68 Release 3 is compliant with AT&T's System V interface. Definition, SVID. Languages and development tools. ANSI compiler and Fortran 77. NRM/COBOL. -1 Micro Focus Level 2 COBOET, Animator, Forms 2, and Runtime System. OAppSoft Fortran. RJQ Menu Development Tool. Data Management Facilities. 2 Unify Relational Database Management System. J. Oracle Relational Database Management System. J. Informix Relational Database Management System. Data Communications Facilities. O3274 SNA and BSC. and 3776 SNA. ORJLHASP, 2780, and 3780. O Ethernet with XNS. O Ethernet with TCP/IP. Office Applications. O Business Assistant User Services. OQ1 Word Processor. O 2020th Spreadsheet. O Office Services, Electronic Mail, Calendar, etc. OQ Chart Business Graphics. O Microtrack Project Management System. OQ File Information Storage and Retrieval System. Motorola Microcomputer Systems and Components. 1-28. PBC 110. Specifications. System. VMware, IEEE P1014. Eurocard form factor. Depth, 6.30, 160 mm. Height, 9.17, 233 mm. 96 pin DIN 41612, P1, connectors. 12 double high VME card slots. Processor. MC68020 at 16.7 MHz. MC68851 PMMU. MC68881 floating point coprocessor. IEEE P754. 16 KB zero weight state cache accelerator option. 2 RS-232C asynchronous ports. 110 bps to 9600 bps. VSB memory bus. Memory. ECC memory. 4 to 12 MB. 4 MB increments. 64-bit cache register. 560 NS 32-bit average access. Single-bit error correction. Double-bit error detection. Parity memory. 2 to 8 MB. 2 MB increments. Dual-ported, VMware and VSB. 235 NS 32-bit write, VSB, cache enable. Mode. 280 NS 32-bit read, VSB, cache enable mode. Byte parity generation. Byte parity checking. Winchester and floppy disk controller. Up to 2 per system. Up to 2 ST506 Winchester drives per controller. Up to 2 floppy disk drives per system. 5 Mbps serial data rates. Multiple sector read/write. Automatic head switching and cylinder. Positioning. 2:1 interleaving. 32-bit ECC, Winchester. ESDI disk controller. Up to 4 ESDI disks per controller. Up to 10 Mbps data rates. 0 latency reads and writes. 1:1 interleaving. Scatter/gather. 32-bit ECC. SMD disk controller. Up to 2 per system. Up to 2 SMD disks per controller. Up to 24 Mbps data rates. 0 latency reads and writes. 1:1 interleave over multiple cylinders. 32-bit ECC. 5-1/4 streaming tape controller. QIC02 interface. Transfer rate. 90 KB continuous. 200 KB burst. Streams at 5 MB per minute. 1/2 9-track controller. PerTech interface. Up to 200 IPS GCR drive support. Start/stop or streaming support. GCR, PE, or NRZI recording. 8-port serial controller. Up to 4 controllers per system. 8 asynchronous RS-232C ports per controller. 10 MHz MC68010 microprocessor. 128 KB RAM memory. 32 KB ROM. Port selectable. 50 to 19,200 bps. 1, 1.5 or 2 stop bits. 5 to 8 data bits. Odd, even, or no parity. DTR, DSR, RTS, CTS, and OCO control. Functions. Buffered Pipe Communications Protocol. Intelligent Communications Controller. 6 synchronous/asynchronous. Communications ports. 10 MHz MC68010 microprocessor. 512 KB RAM memory. 128 KB ROM. SOLC, HDLC, and BSC protocol support. Port selectable. 50 to 19,200 bps. 1, 1.5 or 2 stop bits, 5 to 8 data bits, odd, even, or no parity, NRZ, NRZI, or FM encoding, buffered pipe communications protocol, intelligent Ethernet LAN controller, Ethernet, version 2.0 compatible, conforms to IEEE 802.3, CSMLCO, LAN. Standard 10 Mbps 10 MHz MC68000 microprocessor 512 KB RAM memory 32 KB EPROM Buffered Pipe Communications Protocol Physical specifications Height 25.6 inches 65.0 centimeters Width 12.5 inches 31.8 centimeters Depth 28.0 inches 71.1 centimeters Weight 135 IBS 61 kilograms fully loaded model 2616 Environmental and safety Specifications Safety meets all 478 EDP and 114 office equipment 110 VAC only meets CSA 154 EDP and 143 office equipment 110 VAC only meets VDE 0806/8.81 office equipment 220 VAC only meets IEC 380 office equipment emissions meets VDE 0871/6.78 Class A 220 VAC only meets FCC Part 15 Subpart J Class A ESD 5000 volts no observable effect 12,000 volts no operator perceived errors 24,000 volts no permanent equipment damage altitude operating 10,000 feet ASL non-operating 30,000 feet ASL acoustic noise level 55 dBA maximum temperature operating 5 degrees Celsius to 40 degrees Celsius non-operating -40 degrees Celsius to 60 degrees Celsius relative humidity operating 10% to 80% RH non-condensing non-operating 10% to 90% RH non-condensing shock operating 0.5 G non-operating 15 G transportation packaging and shipping containers and procedures comply with the current NSTA pre-ship test procedures shipping container height 34.5 87.6 centimeters width 22.5 57.2 centimeters length 41.0 104.1 centimeters Motorola Microcomputer Systems and Components 1 to 29 I Motorola Microcomputer Systems and Components 1 to 30 Microprocessor applications range in complexity from those using board-level products in systems of 8/16-bit data/address paths and having modest data transfer rates to those for which solutions will be found using the 32-bit MC68020 which accesses 4 GB of linear memory space and executes 2.5 million instructions per second. For those applications requiring a system providing rugged mechanical structure, non-multiplexed and asynchronous data transfers, a powerful interrupt structure, flexible data and address paths, support for system failure, detection and data transfer rates up to 40 megabytes per second, Motorola's VMbus compatible board level prod. UX, VM modules, can offer a quick solution. Since its introduction in October 1981, the VMbus interconnect system has gained such acceptance that it has become a de facto world standard. The bus is presently being standardized by both the IEEE and the IEC. Both a VMbus manufacturers group and a VMbus users group have been formed, the former to assure a high degree of technical compatibility between products, and the latter to promote understanding of the bus, related hardware, operating systems, and application software. VM module compatibility with VMbus results in many benefits for board-level product users. One benefit is that, since VMbus is based on the Eurocard standard, which specifies not only the board format but also the enclosures, card racks and connectors, there is a high degree of mechanical and electromechanical interchangeability between the products of all vendors. Presently, there are more than 500 products available from the more than 100 vendors worldwide, giving the user an ever-widening range of choices for his designs. In addition, Motorola, Synutix, and others are committed to the design and production of LSI-implemented bus support functions which make interfacing the VMbus easier and will result in the availability of an even greater variety of powerful VMbus-compatible products. 2-to-1 VM module datasheets. Micro MAP 1-7 Manufacturing Automation Protocol Software. 2-to-3 Bug VM Bug Debugging Package. 4 MVME 110-1. 2-to-7 Bug 1 VM Bug Source Object. Modules on Veridus. DSKT. 2-to-7 Mixed Cock 1 Cache Accelerator Module. 2-to-10 Mixed Cock 2 Cache Accelerator Module. 2-to-10 MVME 117 Bug 117 Bug Debug Monitor. 2-to-16 MVME 025 System Controller. 2-to-20 MVME 050 System Controller Module. 2-to-22 MVME 101 MC 68000 MCU Mono Board. 2-to-27 MVME 101 Bug Debugging Package 4 MVME 101 MPU Module. 2-to-36 MVME 101 BUGLF 101 Bug Source Object. Module on Veridus. DSKT. 2-to-36 MVME 101 BUGLF 101 Bug Source Object. Module on Veridus. Card. 2-to-36 MVME 104 VMbus Processor Module. 2-to-39 MVME 105 VMbus Processor Module. 2-to-39 MVME 106 VMbus Processor Module. 2-to-39 MVMM 107 VMbus Processor Module. 2-to-39 MVME 110-1 MC 68000 MCU Mono Board. 2-to-45 MVME 117 3 Mono Board MCU. 2-to-52 MVME 117-3 FP Mono Board MCU. 2-to-52 MVME 117-4 Mono Board MCU. 2-to-52 MVME 121 VMbus MPU Module. 2-to-56 MVME 123 VMbus MPU Module. 2-to-56 MVME 130 32-bit Mono Board MCU. 2-to-60 MVME 130 132-bit Mono Board MCU. 2-to-60 MVME 130 Bug 130 Bug Debug / Diagnostic Monitor. 2-to-67 NVMe 130 XT 32-bit MCU with cache. Accelerator 2 to 71. NVMe 131 XT 32-bit MCU with cache. Accelerator 2 to 71. NVMe 133 32-bit monoboard MCU. 2 to 82. NVMe 133-132-bit monoboard MCU. 2 to 82. NVMe 133 a 32-bit monoboard MCU. 2 to 89. NVMe 264 KB DRAM module. 2 to 96. NVMe 201 256 KB DRAM module. 2 to 96. NVMe 202 512 KB DRAM. 2 to 102. NVMe 204-11 MB/2 MB DRAM WIVSB. 2 to 106. NVMe 204-21 MB/2 MB DRAM WIVSB. 2 to 106. NVMe 204-2 F2 MB DRAM module WIVSB. 2 to 110. NVMe 211 static RAM/ROM/EPROM. Memory module. 2 to 114. NVMe 214 static RAM/ROM WLVSB. 2 to 117. Continued. NVMe 372 Set 2 Map Network Interface. 2 to 211. NVMe 372 Set 3 Map Network Interface. 2 to 211. NVMe 390A Graphics Interface Module. 2 to 215. NVMe 701 110 Transition Module 4. NVMe 050. 2 to 22. NVMe 705 6-channel Serial Transceiver. VMware Module Datasheets. Module. 2 to 166. NVMe 820 VMware Plug-in Mass. Continued, Storage Module. 2 to 221 NVMe 821 VMware Plug-in Mass. Storage Module. 2 to 221. NVMe 822 VMware Plug-in Mass. NVMe 215-1 256 KB CMOS RAM Module. 2 to 120 Storage Module. 2 to 221. NVMe 215-2 512 KB CMOS RAM Module. 2 to 120 NVMe 833 Mass Storage Unit 4. NVMe 215-3 1 MB CMOS RAM Module. 2 to 120 NVMe 945. 2 to 232. NVMe 222-1 1 MB DRAM Module. 2 to 102 NVMe 834 Mass Storage Unit 4. NVMe 222-2 2 MB DRAM Module. 2 to 102 NVMe 945. 2 to 232. NVMe 225-1 1 MB DRAM. 2 to 123 NVMe 910-3 VMware Module 200 W. NVMe 225-2 2 MB DRAM. 2 to 123 Switching Power Supply. 2 to 225. NVMe 300 IEEE 488 Listener/Talker/NVMe 911 VMware Module 300 W. Controller Module. 2 to 126 Switching Power Supply. 2 to 225. NVMe 310 Intelligent Peripheral NVMe 920/20 Slot VMware Backplane. 2 to 225. Controller Module. 2 to 134 NVMe 921 9-slot VMware backplane. 2 to 225. NVMe 315 Intelligent Peripheral Interface NVMe 922 5-slot I/O channel. Module. 2 to 139 backplate. 2 to 225. NVMe 319 Intelligent Peripheral NVMe 930 VMebus Extender Module 2 to 225 Controller Module 2 to 145 NVMe 931-1 VMebus Wire Wrap Module NVMe 320A Winchester/floppy DJSK Double High 2 to 225 Controller 2 to 149 NVMe 932 VMebus Extender Module 2 to 225 NVMe 320A1 Winchester/floppy disk NVMe 933-1 VMebus Wire Wrap Module Controller 2 to 149 Single High 2 to 225 NVMe 321 VMebus Disk Controller NVMe 935 Adapter, I/O Channel 250 Winchester and Floppy 2 to 153 Pin Header 2 to 225 NVMe 330 LAN Controller 2 to 158 NVMe 940-17-810 TV VMebus, 10 slot I/O NVMe 331 LAN Controller 2 to 158 Channel Chassis with 200 NVMe 332 LAN Controller 2 to 158 Watt Switching Power NVMe 331 6-channel Synchronous/Supply 2 to 225 Asynchronous NVMe 941 9-slot VMebus, 10-slot I/O Communications Channel Card Cage 2 to 225 Controller 2 to 166 NVMe 942 20-slot VMebus Card NVMe 332 8-channel Intelligent Cage 2 to 225 Communications NVMe 943-1 VMebus Chassis Assembly 2 to 229 Controller 2 to 175 NVMe 943-2 VMebus Chassis Assembly 2 to 229 NVMe 333-2 6-channel Synchronous/NVMe 944-1 VMebus Chassis Assembly 2 to 229 Asynchronous Controller NVMe 944-2 VMebus Chassis Assembly 2 to 229 With DMA Communications 2 to 179 NVMe 945-1 VMebus Chassis Assembly 2 to 232 NVMe 335 Serial and I/O Module 2 to 188 NVMe 945-2 VMebus Chassis Assembly 2 to 232 NVMe 340 VME Module Interface Timer SYS 1121 UI 221 VMebus Modular System Module 2 to 190 with System V/68 2 to 238 NVMe 350 Streaming Tape Controller 2 to 194 SYS 1131 DVLP Software Development NVMe 360 SMD Disk Controller/System 2 to 246 Formatter 2 to 198 SYS 1131 UI 231 VMebus Modular System NVMe 360 UX SMD Disk Controller/with System V/68 2 to 238 Formatter 2 to 198 SYS 1131 UI 331 VMebus Modular System NVMe 360 VX SMD Disk Controller/with System V/68 or Formatter 2 to 198 Veriduce 4.5 2 to 251 NVMe 372 Advanced Map Network SYS 1131 UI 341 VMebus Modular System Interface 2 to 204 with System V/68 2 to 258 MVME 372 BeebKit Map Broadband Network SYS 1131 VY331 VMware Modular System. Developers Kit 2-207 with System V/68 or MVME 372 BeebKit 2 Map Broadband Network Veriduce 4.5 2-251. Developers Kit 2-207 SYS 1131 VY341 VMware Modular System. MVME 372 Set 1 Map Network Interface 2-211 WNERS Aduce 4.5 2-264. Motorola Microcomputer Systems and Components 2-2. Micro MAP 1-7. Micro MAP Manufacturing Automation Protocol Software. The 7-layer Open Systems Interconnection, OSI. Reference model is the result of work begun by an National Standards Organization Committee in 1977 to provide a starting point from which beneficial compatibility among future network architectures could be realized. To provide network data communications for their factory environments, General Motors Corporation developed the Manufacturing Automation Protocol, which currently observes 6 of the OSI model layers. Micro MAP object code is an implementation of the MAP 2.1 specification for the Motorola MVME 372 Advanced MAP Network Interface VM module. For porting to another board or host system, source code is available in a variety of packages. Supports all map layers, per MAP 2.1 and ISO/IEEE. Specifications. Map layers implemented as separate, independent modules. Consistent interfaces between layers. Source code available. Entire micro MAP. Host resident, System v68 dependent code. Operating system independent, MVME 372. Resident code. Layers 1 to -7 option. Layers 1 to 4 option. Layers 5 to 7 option. Implemented in C for high portability. Certified by ITI. System v/68 support. System v/68 driver, common environment. Interface, application task interface utility. Libraries. MVME 372 Advanced Map Interface Support. MC68824 Token Bus Controller and MC6802032. Bit microprocessor-based implementation of MAP 2.1. VRTX Real-Time Kernel. Common Environment Interface. No software limit on number of concurrent, full, duplex connections. Supports MC68824 Token Bus Controller chip. Micro MAP layer descriptions. In the micro MAP implementation of MAP, the coaxial cable and the node modem, for example, the MVME 371 FS MAP Network Interface Broadband Modem, comprise Layer 1. The functions of Layer 2 are provided partly by the MC68824 Token Bus Controller and its driver, and partly by Logical Link Control and Media Access Control software. Figure 1 diagrams the correspondence of the Open System Interconnect model layers to the layers of the micro MAP implementation of MAP 2.1. Figure 2 shows the locations of the various elements of the micro MAP system. LAYEE1, physical. The physical layer provides the electrical/mechanical connection for transmission of data between nodes. It performs the electrical encoding of the data for transmission over and regulates access to the network cable, thus freeing the other micro MAP layers from dependence on the physical medium. Layer 2, Logical Link Control/Media Access. Control. The Logical Link Control software design provides a connectionless service which conforms to the IEEE 802.2 standard for Type 1 service, ISO 8802/2. The Media Access Control, MAC, is realized using the MC68824 Token Bus Controller chip and conforms to the IEEE 802.4 standard, ISO 8802/4. Together, these sublayers form the data link layer of the OSI model. Layer 3, Internet. The micro-MAP Internet layer corresponds to the ISO 8802/2 network layer standard, DIS 8473. It provides a connectionless service for message routing and relaying between cooperating nodes on the same network, or on interconnecting networks. Services provided by the internet layer are independent of the distances separating the source and destination nodes. The key characteristics of Internet services are transparency of transferred information, composition, decomposition, segmentation, and re-assembly of the data units. Internetwork routing. Layer 4, Transport. The ISO 8073 transport layer specifies a guaranteed transfer of data between cooperating session tasks in different network nodes. The layer also performs control of data flow between itself and a remote node transport layer. Motorola microcomputer systems and components. 2-3. Micro-MAP 1-7. The micro-MAP transport provides expedited data share, VICE, extended sequence number formats, user data on connect request/confirm and disconnect request, sub sequencing of acknowledge messages and can check sum all message data. Layer 5, Session. The intent of the session layer, ISO 8327, is to provide cooperating tasks on different network nodes with the means to organize, synchronize, and regulate the orderly exchange of data. The micro-MAP session layer provides fundamental session kernel capability which is to connect, transfer data, and disconnect. In addition, it supports full duplex capability. Layer 6, Presentation. Since the MAP 2.1 specification does not define a presentation layer, many of the applications and utilities of Layer 7 directly use the services of Layer 5, the session layer. Layer 7, Application. Layer 7 provides user tasks access to network services offered by lower layers. The primary means for using the network is a collection of network application programs which reside in the application layer. These include Case Common Application Service Elements, ISO, DP, 8649, Kernel, MAP 2.1, FTAM, File Transfer, Access and Management, ISO 8571, 1-4, Agent Network Management Agent, MAP 2.1, DIRSRVS Directory Services, MAP 2.1. In addition to these application programs, micro-MAP also provides manufacturing message format standard MMFS support. The MMFS application resides in the host computer and is accessed through the MMFS user interface library. Common Application Service Elements, CASE. The Common Application Service Elements, CASE program is an interface utility residing in the application layer that is designed to relieve user application grams of much of the effort required when micro-MAP communication services are used. Case includes a facil. ITY for making and breaking associations with remote user programs and for transferring data to / from remote applications. A framework is provided for authentication and authorization of users. File transfer, access and management, FTAM. The file transfer, access, and management program, FTAM, resides in the application layer and uses the services of the session layer. FTAM provides the following services: establish and terminate connections to a remote FTAM, select existing files, create new files, delete files, read and write files, read a file's attributes on a remote system. The micro-MAP FTAM implementation includes an address resolution capability for transforming a logical address into the corresponding service access point, SAP, to facilitate the writing of hardware-independent software. Network Management Agent, Agent. The micro-MAP Network Management Agent, Agent, is an application program residing in Layer 7 that interacts with a remote node network manager. Typically, the remote manager requests information from specific layers on the local node via agent. However, while a connection with the network manager exists, agent may, on its own, report on local system performance parameters that have exceeded threshold values. Micro-MAP layers that interact with agent are Internet, Transport, Session and Case. Using System Management Protocol units, SMPDUs, the Network Management Agent uses the services of Case to communicate with the remote network manager. VRTX, Micro-MAP operating system. All micro-MAP layers are implemented as tasks that execute under the control of the VRTX real-time, multitasking operating system. Post and pend message services are used for communicating with each micro-MAP task. The operating system co-resides with the common environment programs in a PROM set on the NVMe 372. Advanced Map Network Interface Module. The VRTX operating system is supplied by Motorola under license to Hunter and Reddy Inc. The common environment. To communicate with a remote host, an application task executing on the local host requires a path over the VMware and through the micro-MAP software layers to the network. On the NVMe 372 module, firmware comprising 2 executive modules and the VRTX kernel, collectively called the common environment, facilitate this vital function by providing a standard interface between the NVMe 372 and the host. The host driver and the common environment communicate over the VMware using a standard Motorola buffered pipe protocol that provides the non-busy interface required for optimum data rates. Typical outgoing communication sequence. The user task passes its message to the common environment driver on the host. The driver passes the message to the common environment on the NVMe 372 map network interface module. The common environment passes the message to micro-MAP. Micro-MAP transmits the message out onto the network. Typical incoming communication sequence. Micro-MAP receives an incoming message from a remote node. Micro-MAP passes the message to the common environment. Motorola Microcomputer Systems and Components 2-4. Micro-MAP 1-7. The common environment passes the message to the common environment driver on the host processor module. The driver passes the message to the recipient task. User interface libraries. To make individual micro-MAP functions readily able to application tasks, user interface libraries written in C are provided that offer the most often used map services. Appropriate libraries are linked with the host resident application program to obtain the desired functions from the micro-MAP software residing on the map network interface module. Essentially, the libraries veil the complexities of the MAP 2.1 protocols by reducing the need for the user to acquire in-depth knowledge of the map layer's software interfaces or of the common environment facilities. The following user interface libraries are provided with Micro-MAP Case Common Application Service Elements MMFS Manufacturing Message Format Standard FTAM File Transfer, Access and Management. The other Layer 7 application programs do not require user interface libraries since they are normally called only by other micro-MAP applications. If the services offered by DIRS RVS and agent are required, however, they may be obtained through direct interface by a user task. Case User Interface, CUI. The Case User Interface, CUI, is a library of function calls that allows case services to be used without PLYING with the details of the Layer 7 interface to the case application. A user program may simultaneously communicate with multiple remote user applications, have Layer 7, Layer 6, Layer 5, Layer 4, Layer 3, Layer 2, Layer 1, OSI model, application, presentation, session, transport, network, data link, physical, ISO, 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 IEEE/ISO, IEEE/ISO. Simultaneous multiple communications with one remote application, or both. All CUI services are performed synchronously, i.e., a user task having made a request must wait until the request has been satisfied, successfully or unsuccessfully, before proceeding. FTAM User Interface, full. The FTAM User Interface, FUI, is a library of function calls that allows the use of FTAM services on the NVMe 372, without complying with the details of the Layer 7 to FTAM interface. User programs may simultaneously communicate with the FTAM on multiple remote nodes or have multiple simultaneous communications with any remote node or both. All FTAM services are performed synchronously, i.e., a user task having made a request must wait until the request has been satisfied, successfully or unsuccessfully, before proceeding. MMFS User Interface, MUL. The MMFS User Interface, MUI, library provides function calls that eliminate the encoding and decoding of MMFS messages. Each function call uses CUI to establish, maintain and release connections. Downloading Micro-MAP. The Micro-MAP software and applications reside in RAN. DOM access memory, RAM, on the NVMe 372 Advanced Map Network Interface Module. When power is applied at a node or when a node is initialized, the Micro-MAP Software must be loaded into the NVMe 372 RAM. Down. Load software is supplied with micro-MAP to perform this function. Micro-MAP implementation. Application. Null. Session. Transport. Internet. LLC, TBC, CTRLR. Modem. Coax-1. Map 2.1/1S0. Map 2.1/1S0. Map 2.1/1S0. Map 2.1/1S0. Map 2.1/1S0. IEEE/ISO. IEEE/ISO. Figure 1. Correspondence of OSI model to micro-MAP. Motorola Microcomputer Systems and Components. 2-5. I. Micro-MAP 1-7. I. Physical location of the map application user interfaces and map layers. I. System v/68 operating system. Host computer. MMFS user interface, MUI. FTAM user interface, FUI. Common case user interface, CUI, user. Environment application. Interface. Station management console tasks. Driver, FTAM virtual file store, FVF. MMFS application task. V. M. E. B. VME 372 board. U. VRTX operating system, PROM, S common. Environment, per, BPP. Micro-MAP layer 7, map applications, RAM. DIRSRVS, case, FTAM, agent. Micro-MAP layer 6, presentation, null, RAM. Micro-MAP layer 5, session, RAM. Micro-MAP layer 4, transport, RAM. Micro-MAP layer 3, internet, RAM, F. Micro-MAP layer 2, logical link control and MAC, RAM. R. I.00 cable to map physical layer 1 modem card. Figure 2. Physical location of micro-MAP elements. Ordering information. Part number description. Micro-MAP 1-7 map 2.1 object code including layers 1 to 7 for use with NVMe 372 advanced map. Network interface in system v/68 host system. Supplied on 5-1/4 floppy disk. Readable by system v/68 host. Includes both host resident and NVMe 372 resident. Micro-MAP and common environment object code. Micro-MAP 1-4 map 2.1 object code including layers 1 to 4 for use with NVMe 372 advanced map. Network interface in system v/68 host system. Supplied on 5-1/4 floppy disk. Readable by system v/68 host. Includes both NVMe 372 resident micro-MAP and common environment object code. Micro-MAP 1-7S map 2.1 source code for layers 1 to 7. Includes micro-mappers. Does not include common envs. Supplied on 5-1/4 floppy disk readable by system v/68 host. Micro-MAP 1-4S map 2.1 source code for layers 1 to 4. Does not include common envs. Supplied on 5-1/4 floppy disk readable by system v/68 host. Micro-MAP 5-7S map 2.1 source code for layers 5 to 7. Does not include common envs. Supplied on 5-1/4 floppy disk readable by system v/68 host. Micro-MAP HRS map 2.1 host resident source code. Includes user interfaces for FTAM, case and MMFS, MMFS code, FVF, virtual file store and forward, network management. Console source code for parameter download, table download, and monitor. Download features. Supplied on 5-1/4 floppy disk readable by system v/68 host. Includes host resident common environment source. Common envs map 2.1 common environment source code. Includes driver information using NVMe 372 Advanced Map Network Interface VMware module as a porting example. Motorola microcomputer systems and components. 2-6. VMware debugging packages. For the VMware module. Mono board. Microcomputer. VMware resident package. EPROM resident system debug monitor. More than 30 commands for debug, up/down line. Load. Single line assembler disassembler for assembly. Language program development. Full speed execution of system and user developed. Programs operating in the VMware module mono board. Microcomputer system. Virtual terminal capability for up/downline load from an EX or Max development system or from across computer. Powerful software and system debug command set. Allows access to all VMware module 110, control and memory facilities plus the full 16 MB direct address range of the VMware system bus. Includes all required installation and operation. Documentation. Includes Bootstrap loader for both NVMe 420, SUSE. Peripheral adapter and the M68RWIN1 disk control. LR. VMware bug source and relocatable object module. Package. Source and relocatable object modules for VMware bug. On diskette or cartridge disk. Relocatable object modules allow users to include only the VMware bug items needed in their end system. To link in their own up/downline loader, and /or to link in their own Bootstrap loader. Source modules allow user modification of VMware bug as desired. Bug. BUG. The VMware module monoboard microcomputer debug pack. VMware bug is available as two separate product offerings. VMware bug is an EPROM-based resident package ready for installation and immediate use with the VMware module mono board microcomputer installed in a VMware-based back plane. Such a backplane is provided within Motorola's VME module chassis, MVME 940. VMware bug source and relocatable object modules are a separate product available on either Veridus compatible diskette or cartridge. VMware bug provides a powerful evaluation and system debugging tool for VMware module systems. The EPROM resident package will operate ILJ 32 KB of ROM space. VMware bug uses the first 1152 words of RAM storage for interrupt vectors and temporary storage. The EPROM resident package is delivered in 4 8 KB EPROMs. Table 1 lists the commands available to the user. The package permits execution of system and user developed programs operated in a VMware module mono board microcomputer system environment under complete operator control. VMware bug may be utilized with a VMware module mono board microcomputer in a standalone environment with only a user-provided standard RS-232C asynchronous ASCII terminal. Alternately, it may be used with a second serial 110 port connected to a host computer for up/downline loading of programs in Motorola's record format. When connected to a host computer in this manner, the VM module nmebug/ operator terminal combination appears as a normal asyn. ASCII terminal, a virtual terminal, to the host op. Errating system. The second serial I/O port, the host computer. Interface, would be implemented through an 1i0 module board. Or other similar functional element. VMware may also be used with the MVMe 420 or the M68 RWIN1 controllers, or both, and appropriate disks to load programs from disk to memory. In a typical debug session, the user will download his program to a VM module monoboard from the host computer, used for software development. After loading, VMware commands may be used to examine and modify memory, set breakpoints to run particular program segments, and track program progress. The user may set up and examine a variety of conditions using any of the powerful commands listed in Table 1, such as the register display/set series and the Motorola microcomputer systems and components. 2-7 Bug 1. Memory block manipulation commands. The data conver Zion command serves as an aid in examining and modifying data by converting hexadecimal to decimal, and decimal to hexadecimal. If corrections or program patches are required, these may be performed and checked in the VM module. The user may have a corrected copy to the host computer files by using the memory dump command for upline load. Creating program patches may be aided by use of the display offsets command to assist with relocatable and position independent code. The user may also copy all traffic to the serial port debug terminal on a printer attached to an auxiliary parallel port by use of the attach printer command. This may be useful for desk debugging following a debug session. The parallel printer interface port may be implemented through the appropriate 1i0 module board. The user may communicate with the host computer as a terminal for purposes other than up/down line load by exe, executing the transparent mode command or the send message to port 2 command. By using the port format command, the serial port may be reconfigured for such attributes as baud rate, stop bits, and number of data bits. In the transparent mode, the two serial ports must operate at the same baud rate. Bootstrap load and dump commands permit the user to bootstrap from several controller/device combinations. The controller boards currently supported are the MS8 RWIN1 Winchester disk controller and the MVMe 420 SUSE peripheral adapter. The drives currently supported are the 5% Winchester and the 5114 floppy or 8 floppy on the MS8 RWIN1, and the 8 Winchester and 8 floppy on the MVMe 420. The boot dump command permits the user to write his operating system to a diskette/disk in Bootstrap load format for subsequent use in boot loading. The lop command permits the user to create the diskette/disk format required. VMware may be used for debug in total systems environments which include the VM module monoboard microcomputer and with other Motorola VM modules as well as user developed VMware compatible modules. The source and relocatable object module package provides users with the information to link VMware into their specific systems in either modified or unmodified form. The relocatable object modules are designed to permit creation of a load module with or without the S-record up/down line loader. Users may also apply the relocatable object modules Substituting their own device Bootstrap loader for the VMware. Disk Bootstrap loader. Source modules permit the user to modify or customize any of the VMware functions as desired. Table 1, VMware commands. Command description. MD memory display / disassembly. Memory modified disassembly / assembly. MS memory set. .AO, .A7 display / set address register. .do, .D7 display / set data register. .PC display / set program counter. .SR display / set status register. .SS display / set supervisor stack pointer. .US display / set user stack pointer. DF display formatted registers, all. BF block fill, with 1s bit data word, memory. BM block move. BS block of memory search. By block initialize. BT block test of memory. DC data conversion. Of display offsets. .RO, .RS display / set relative offset register. Motorola Microcomputer Systems and Components. 2-8. Bug 1. Table 1, VMware commands, continued. Command description. BR breakpoint set, up to 8. NOBR, breakpoint remove, any or all. Go execute program. GT go until breakpoint, sets temporary breakpoint. GD go direct, no breakpoint or track set, and no exception vector changes. TR trace, set for number of instructions. TT trace to temporary breakpoint. PA printer attach, print as well as display. NOPA reset printer attach. PF port format, set serial port attributes. TM transparent mode, 2 serial ports. Transparently connected. Asterisk text. Send message to port 2. He help, display VMware commands. Do. Dump, S record upline load. Low, equals text load, S record downline load. VE equals text verify, S record downline load verify. BD boot dump. BH bootstrap halt. Bo bootstrap operating system. Lot 1/0 physical to disk. Lot 1/0 teach to disk. Command line edit and control functions. Break, abort command. Del, delete character. Control D, redisplay line. Control H, delete character. Control W, suspend output star. Control X, cancel command line. CR, send line to memory. Asterisk when, Control W, is used, the user can cause the output display to continue by entering any character. Ordering information. Part number description. Bug VMware, the VMware module monoboard microcomputer system debug package. Includes EPROM set asterisk and user's manual. Bug 1 source and relocatable object modules for the VMware system on Veridus. Diskette for the EXORMAX development system asterisk includes user's manual. Bug/DM VMware debugging packages user's manual. Asterisk the bug EPROM set is copyrighted by Motorola and may be copied only under prior written agreement from Motorola. Bug 1 and Bug 2. Sources are copyrighted and licensed by Motorola. They may be obtained only under the required license agreement with Motorola. Motorola Microcomputer Systems and Components. 2-9. VMware module trademark. Mixed Cock 1. Mixed Cock 2. Cache accelerator module. For VME-based modular 32-bit microcomputer system. Provides 25% to 100% system performance increase. 1. Requires no program modification. 16 KB cache, organized as 4K, 32-bit entries. Supports both program and data transactions. Zero-wait state operation. 2. Parallel MMU operation with page detection circuitry. Supports both VMware and vSphere. Data fill on vSphere byte and word reads. Supports all MC68020 bus transfer and sizing modes. Diagnostic mode. Cache memory systems are often employed to speed up the performance of microcomputers by compensating for the typical speed mismatch between a fast CPU and the relatively slow associated dynamic RAM memory (SYS). TEM. The cache accelerator performs this function for microcomputers built around the NVMe 130 family of M68020 based microprocessor modules. The cache accelerator is a small, fast memory system that provides concurrent storage of data most recently stored in main memory. Consequently, on subsequent accesses to these cached locations, the much slower main memory access can be circumvented, thus speeding up the communication cycle. Since the cache accelerator has a much smaller MEM or capacity than the system memory, little used data stored in the cache memory is routinely replaced with more active data, based on the bus traffic between the microprocessor module and the VMware and vSphere MEM or interfaces. General description. The mixed-cock external cache accelerator is a plug-in cache module, supporting the NVMe 130 family of monoboard microcomputers in VMbus-based microcomputer systems. It is designed to enhance the operation of these MC68020 based systems by providing a typical 25% to 100% increase in performance without modification of existing programs. One software transfer in C is achieved through the utilization of a physical address memory structure, coupled with a VMware monitor. The monitor automatically cleanses the cache of stale data, and enables the cache accelerator to operate. One actual performance improvement varies with program applications. 2. With MMU bypass card installed, and dependent on MC68020 clock 2. Address strobe timing. In both single and multi-processor environments without software intervention. The accelerator is a single set, direct mapped cache, comprising 16 KB of high-speed static memory, organized as 4K, 32-bit data entries. Each entry replicates a 32-bit word located in VMware or vSphere memory space and is updated concurrently with a processor write access or initial read access. Any combination of bytes from an access can be cached at a time, and a data fill function implemented for vSphere enables the caching of an entire 32-bit entry for byte and word read operations. The accelerator caches both program and data transactions throughout, and it can be configured by function code to cache data from any combination of supervisor program, supervisor data, user program, and user data mode accesses. The cache accelerator module supports any speed MC68020 microprocessor, and it is jumper selectable to support either the MC68851 memory management unit or M68K VMMB851 memory management board, or an MMU bypass board if the MMU function is not required. With an MMU installed, the page detection circuitry on the cache enables its RAMs to operate in parallel with Motorola Microcomputer Systems and Components. 2 to 10. MVM XCOC 1, Mixed COC 2. VMEADR. R. V address. ICPU ADR. Multiplexer cache RAM. V. Cell tag. I7. CPU paging timing I. Cache / data. VMEBUS. N. Loss. N. Hit / miss. Monitor. MMU control. Control. PA control. VME bus CPU USCPL control. I7. VMEBUS MVME 130, PMMU socket. Figure 1. Mixed COC functional block diagram. The MMU address translation RAMs to maximize system performance. A cache page is defined by the physical address bits PA08 PA13, and if they remain the same on a following cycle, then the address access time of the cache RAMs is buried in the MMU address translation. Period. With the bypass board installed, the cache receives the address signals directly from the MC68020 microprocessor, and zero wait state operation is obtainable. Zero wait state operation is achieved at a processor frequency of 12.5 MHz to, and it may be achieved at 16.67 MHz when faster static RAMs become available. The cache accelerator provides direct access to the cache RAMs for diagnostic and inquiry purposes, and provides a test mode of operation to establish general system confidence. Basic cache operation. When the processor drives an address for a readoperation, the index section PA02-13 addresses the tag and data RAMs to select one entry from the cache. The remaining address bits from the processor are then paired to the corresponding address bits read from the tag section of that entry. If they match and the address valid bit is set, and if the byte valid bits for the bytes the 2 with MMU bypass card installed, and dependent on MC68020 clock 2. Address strobe timing. Processor is requesting also match, then the cycle hits, and the cache supplies the requested data to the processor and terminates the cycle. If any event does not match, then the cycle misses and a VME or VSB access is initiated. The cache entry is updated with the new address and data information, and the valid bits are set appropriately. Note that a write cycle will always cause a miss since the processor, and not the cache, is supplying the data. Several other factors determine the hit qualification and cacheability of a processor cycle. These include the control bits, the type of processor cycle, the MMU cache enable signal and the onboard address decoder. Form factor. The form factor of the module is a double high Euro card that plugs into the MMU socket resident on the MVME 130/131 monoboard microcomputer module. The MMU is relocated from the monoboard to the cache module, and the 2 Euro card stack plugs into 2 consecutive card slots of the VMEBUS chassis. A double wide front panel with card ejector handles is provided for mechanical stability and ease of handling. Motorola Microcomputer Systems and Components. 2 to 11. I. Mixed COC 1, Mixed COC 2. Table 1. Mixed COC, Memory Organization. Tag Section. Dash Physical Address Dash. Index. A02, A13, A14, A31. T. 4kx18. Address. Memory organization. AV star. 4kx1. ADR. VLD. The complete memory section of cache accelerator is organized as 4K entries of 55 bits per entry, see Table 1. It consists of a tag section and a data sequence, where the tag section stores the physical addresses of the offboard memory locations, and the data section stores the data residing at those locations. The lower address bits, PA0 to PA13, form an index that directly addresses the cache RAMs to select the particular entry to be used, and the remaining address bits, PA14 PA31, are stored and read from the tag RAMs as data. An address valid bit, AV, is generated internally for each entry to indicate that the address stored in the tag is valid in formation. It may not be valid either because the tag entry has not been written to since power up or since the cache was last cleared, or because the VMware monitor has set the entry invalid. The data RAMs contain the corresponding bytes that were cached from the bus, and the 4-byte valid bits, BVO BV3, are generated internally to qualify those bytes. BVO is associated with byte address of the long word entry, and operates on the most significant byte of the data bus, D31 D24. The other byte valid bits operate in sequence. VMware monitor. The VMware monitor is a separate machine on the cache accelerator that operates asynchronously with the processor to prevent stale data from remaining in the cache. It operates automatically so that the host user benefits from the performance advantages offered by the cache without even being aware that the cache accelerator has been installed in the system. Data section. Data 031-23-023-16-015-08007-00 4kx32. Data 4kx4. Byte. VLD. Stale data could occur in the cache when other VMware masters modify data in main memory which was previously cached. To prevent this, the bus monitor has a 2-level FIFO register stack which captures the addresses of write operations initiated by bus masters other than the host, and presents the addresses to the cache for processing. The cache services the monitor by comparing the captured address with the corresponding entry in its tag memory. If the tag is valid and compares, a monitor hit occurs and the cache invalidates the entry by resetting its address valid bit. If the processor then accesses that physical address, the cache will miss because of the reset address valid bit, and the cycle will be routed out to main memory for the new data to update the invalid entry. User interface. The user interface in Table 2 shows the devices on the cache accelerator used to control and diagnose its operation. These consist of cache control and mask registers and 2 hard-decoded address spaces used to directly access the cache RAMs for diagnostic and inquiry purposes. The cache powers up in a cleared and disabled state, and can be enabled for software transparent operation by storing a F1 to the cache control register. In addition, the cache can be tested or configured for a specific user application through the various control bits shown. Since the entire user interface address space can safely be accessed without the cache accelerator installed, a cache utility can be implemented without prior knowledge of its presence in the system. Motorola Microcomputer Systems and Components. 2 to 12. Mixed Cock 1, Mixed Cock 2. Table 2. Mixed Cock, User Interface. Cache Control Register, Address FCO Mask Register, Address FFFC0001. 031, Reset State equals FF, 024 023, Reset State equals XF, 016. Ivepson imonen /MLBK /MBLC /CCLRI Queenie CRENX /R-2X--x-MSORIMSP-comma-MUO-1MUPI. Data Access Space, Address FDU FFFD3FFC. Data Entries, OOOFFF. Tag Access Space. Read Only. 031000. Addresses, FOFFFE3FFC. Tag Entries, OOOFFF. ByteOI. 031-024. Byte 1I. 023-016. Byte 2I. 015-008. Definitions. Vepson, VMware Cache Enable. Monin, VMware Monitor Enable. Byte 3. 007-000. MLBK Monitor Loopback, for diagnostic use. MBLC, Monitor Block, for diagnostic use. CCLR, Cache Clear. CWEN, Cache Write Enable. CREN Cache Read Enable. CTST Cache Test, for diagnostic use. MSD Mask Supervisor Data. Benchmark Test Results. Tests run 0 feet 1 inch at 12.5 MHz NVMe 130 microcomputer. Module used in conjunction with the cache accelerator. Have demonstrated impressive improvement in performance. The results 0, 2 sets of benchmark programs are tabulated in Table 3. The first set utilized EDN bench marks which perform commonly used character and data manipulations, the second utilized user-supplied routines performing data-intensive array operations. The tests run for 4 combinations of cache memory utilization, indicate the degree of improvement attributable to the use of the cache accelerator. D31, D14, D07, D03 do. Pad 31, Pad 14, INAIAV, IBVO, BV3. Mask Supervisor Program. Mask User Data. Mask User Program. Address Valid Status. MSP. MUD. MUP. AV. BVO. BV1. BV2. BV3. Byte valid status for D31 D24, byte address 0. Byte valid state for D23 D16, byte address 1. Byte valid status for D15 D08, byte address 2. Byte valid status for D07 do, byte address 3. Table 3. Performance test results. MC68020. And no MC68020 mixed cock. Test cache. EDNA. Char. String search, 285 141 131 99 PS. EDNF. Set/rest test bit, 60 36 33 30 PS. EDNH. Link list insertion, 121 194 70 70 PS. EDNI. Quick sort, 22,320 11,792 11,072 9001 PS. EDNK. Bit matrix. Translation, 243 173 159 136 ps. Customer. Benchmark 125 104 73 68 seconds. EDN, September 16, 1981. Motorola Microcomputer Systems and Components. 2-13. I. Mixed Cock 1, Mixed Cock 2. Mechanical and Environmental Specifications. I. Characteristic Specification. Cache Implementation Single Set, Direct Mapped, Physical. Memory Organization 4K, 32-bit data entries. Replacement Algorithm Single Entry, Write Through. Hit Timing, No MMU, 60 nanoseconds. Loss to DSACKX with MMU, 70 nanoseconds, page hit. 130 nanoseconds, page miss. Power requirements plus 5 VDC, 6.4 AMAX. 4.3 atypical. Operating temperature 0 degrees to 50 degrees Celsius. Storage temperature minus 40 degrees to 85 degrees Celsius. Relative humidity 5% to 95%, non-condensing. Physical characteristics. Height 6.30 in, 16.00 m. Width 9.19 in, 23.34 m. Thickness 0.062 in, 0.157 m. Component projections. Component side 0.50 in, 1.27 m, max. Solder side 0.067 in, 0.17 m, max. Except for interconnect header. Ordering information. Part number description. Mixed Cock 1 cache expansion kit for the NVMe 130/131 processor module. Does not include hardware memory management. Includes users manual. Mixed Cock 2 same as Mixed Cock 1 with hardware memory management. Includes users manual. NVMe 130XT VM module 32-bit monoboard microcomputer with MC68020 CPU and 16 KB cache. Includes users manual. NVMe 131XT same as NVMe 130XT with hardware memory management. Includes users manual. Related documentation. Part number description. NVMe 130/D NVMe 130 Users Manual. NVMe 130 Bug/D 130 Bug Users Manual. M68KVM MB851/D M68KVM MB851 Users Manual. NVMe 204-1/21D NVMe 204-1/2 Users Manual. MESIB/D1 VSB Specification Manual. HB2121D VMware Specifications Manual. Motorola Microcomputer Systems and Components. 2-14. MVM Mixed Cock 1, Mixed Cock 2. The VME System. NWG, 3. New. Mixed Cock. Cache. Accelerator. 1. U, A. Awk. RU, A colon, UA colon. MVMe 33. 6 channel. COM. Controller. A colon. U, UCL. NOA colon, dash CL. ILN. MVMe 320A. Weenie/floppy. Disk CTLR. MVMe 350. QIC02. Streaming. Tape CTLR. VMware. A typical high-speed NVMe 130/131 XT microcomputer VME system. The Mixed Cock Cache Accelerator Module. conforms to the VMware interconnect system, which has emerged as a worldwide standard for 8/6/32-bit microcomputers. It is part of the VMware module product family whose M68000 based processing power, Eurocard mechanical format, PAL, ERFL Veridu's real-time software support and international multiple sourcing have made it one of the most popular product lines in the industry. The VMware system architecture and a board-level component complement that relate to the cache accelerator are illustrated in the above block diagram. Of particular significance are the well-established functional versatility of the VMware whose non-proprietary technical specification is widely used for system implementation, an auxiliary MVM's bus for high-speed memory expansion, an MC68020 32-bit CPU board, NVMe 131, utilizing the latest advances in microprocessor design, a large repertoire of peripheral, controller, modules and memory boards. The unrivaled acceptance of the VMware system philosophy has yielded a selection of compatible board-level products from well over 100 vendors, to offer systems manufacturers the basic tools with which to implement their designs quickly, efficiently, reliably, and cost-effectively. Motorola Microcomputer Systems and Components 2-15 I. Advance Information 117 Bug Debug Monitor Firmware Monitor EPROM Resident Debug Monitor for NVMe 117 41 Powerful Commands One-line assembler/disassembler for convenient program monitoring/modification Full-speed execution of system and user programs operating in a NVMe 117 microcomputer system. Virtual terminal capability for up/download to any host computer using Motorola S records. Provides access to I/O, control, and memory facilities of a NVMe 117 based system plus a 16 MB direct address range of the 824 VMware. Permits display and modification of the NVMe 117 clock/calendar. Permits configuration of bit/char, baud rate, and PAR ITY for both NVMe 117 terminal ports. Includes boot facilities for loading the Veridu's operating system. SCSI/SUSI firmware support. Includes disk controller initialization and disk I/O commands for SCSI and SUSI controllers, compatible with ANSI X3T 9.2/82-2 revision 14 small computer system interface draft. Includes low-level functions to support SCSI/SUSI. Supports disk controllers in the initiator role. Supports arbitration and reselection. Interface protocol allows user-defined command sequences. The debug monitor for the NVMe 117 mono board microcomputer 117 bug is supplied as two separate products. For resident use, the object code is supplied in 232 KB EPROMs which plug into sockets provided on the NVMe 117 mono board microcomputer, and for customization, the source code is supplied on 5-1/4 diskettes. Readable on systems running the Motorola Veridu's operating system. The monitor, 117 bug for short, is a versatile, effective tool permitting full-speed execution of system and application programs under complete operator control. It offers 41 powerful commands for application program development and modification and for NVMe 117 system Hardware diagnosis and debugging. For standalone. NVMe 117 bug. Mode operation, only a power supply and an RS-232. Asynchronous ASCII terminal connected to one of the NVMe 117 serial ports is required. This mode allows full use of the 117 bug software and hardware debugging capabilities and is commonly used for the final debugging of an application program, so that its powerful hardware/software development capabilities and storage capacity may be employed. A host computer can be connected to the second serial port on the NVMe 117 for up/downloading of programs in Motorola's record format. For this purpose, 117 bug includes commands used to place the microcomputer in the transparent mode and to configure its serial ports for the desired communication protocol. Bootload support. Loading of an operating system and programs from floppy or hard disk into the NVMe 117 system RAM is supported by 117 bug. Controllers supported include those for the SCSI/SUSI bus. In addition, the Motorola M68RWIN1 Winchester Disk Controller I/O Module / NVMe 316 I/O Channel Interface Module combination is fully supported. Connection of an SCSI controller to the NVMe 117 microcomputer is eased using an NVMe 708 transition module, which provides the conversion from DIN to industry standard connectors for serial, parallel, and SCSI bus interfaces. Self-test capabilities. 2 tests are incorporated in 117 bug. 1 executes during the power-up sequence and tests the MC68010 microprocessor, ROM, and RAM resources required to bring up the monitor. This test can be enabled or disabled using the PT or NOPT command. The second test, self-test, performs more extensive testing and displays a greater number of diagnostic status and failure messages. In addition to the resources tested by the power-up test, it tests the parity logic, parity, RAM, CMOS RAM, serial port, real-time clock, program, Mabel timer module, MC68881 peripheral, if installed. NCR5380 SCSI interface chip, if installed, fail LED, abort. Button, front panel switch and, if desired, a disk controller and disk drive. The option of including the testing of a system disk controller and associated disk drive is provided when the ST command is invoked to start the tests. Motorola microcomputer systems and components. 2-16. NVMe 117 bug. Support of the NVMe 117 SCSI interface. SCSI interface. The SCSI interface on NVMe 117 is based on the NCR5380 device, which is a VLSI implementation of the Small Computer Systems Interface, SCSI, defined by the ANSI X3T 9.2 Committee, Revision 14. The interface takes advantage of the chip to provide full support of SCSI bus communication features, including bus request/arbitration, selection/reselection, initiator/target roles, and the 6 SCSI information transfer phases listed in Table 1. Table 1. SCSI information transfer phases. Phase name description. Data out, transfer data from initiator to target. Data in, transfer data from target to initiator. Command transfer, command from initiator to target. Status transfer, status from target to initiator. Message out transfer SCSI level message from initiator to target. Message in transfer SCSI level message from target to initiator. Communication between the NVMe 117 microcomputer and peripherals on the SCSI bus is effected using several levels within 117 bug. Data is interchanged between the high level and the lower levels using a standard protocol and a complement of 9 callable functions. These directly manipulate the NCR 5380 to obtain read, write, and other activities from disk drives connected to controllers on the SCSI bus. The 9 functions, which can be called using the trap number 15 instruction of the MC68010 microprocessor, are listed in Table 2. Table 2. Trap number 15 callable SCSI interface functions. Function code. Hexadecimal, description. 10 read. 11 write. 12 attach device. 13 detach device. 14 format disk with / without defect list. 15 assign alternate sector, SCSI. 16 assign alternate track, SUSI. 17 custom SCSI sequence. 18 SCSI bus reset. 19 SCSI controller reset. Because of the complexity of the task of writing a driver to interface the NCR 5380 chip, use of the 9 callable functions within 117 bug to obtain disk 1/0 could save a significant portion of the software engineering resource expenditure. One of the functions, custom SCSI sequence, provides a means for communicating with a SCSI controller which is not supported by the callable functions within 117 bug. NVMe 117 system power up / reset sequences. On power up or reset, the 117 bug monitor checks the initial event flag in memory to differentiate between power up and reset. If a reset is required and certain essential vectors are present in the RAM from 0 to 3FF used by the monitor, a warm start is performed. If it is an initial event, power up, the power up sequence is entered and the power up test switch in battery-backed RAM is checked. The power up tests are not performed if not selected. A command is included in the 117 bug set to allow the switch to be toggled. If selected, the tests are run and monoboard registers, vectors and onboard RAM initialized. Following RAM initialization, the first 4 bytes in every 8 KB block in memory from $180,000 to $40,000 are checked for indication that ROM boot is wanted. If a boot is wanted, control is given to the indicated code. A checksum command is included in the 117 bug command set to aid the user in preparing and installing a boot program module in ROM. If the ROM boot indication is not found, system RAM is sized and discontinuities noted, following which the auto boot software switch in battery-backed RAM is checked to determine if an auto boot is wanted or not. In the latter case, a cold start message is given and a cold start performed. On finding that an auto boot is wanted, 117 bug causes the desired operating system or application program to be loaded into system RAM from the device and controller specified in the auto boot data area. Should the auto boot switch and associated device and controller identification have been lost from battery-backed RAM, 117 bug informs the user and reinitializes the auto boot data to default values. An auto boot command is included in the 117 bug set as a mechanism for toggling the auto boot switch and specifying the device and controller to use. Motorola Microcomputer Systems and Components. 2-17. MVME 117 bug. Callable 117 bug functions. A trap number 15 handler is included in 117 bug, which allows calls from a user program to input, output, and other useful functions. Such a system call is made by including in the source program a trap number 15 instruction line file, load by a dc.w instruction containing the number of the desired function. Use of these functions provides a means of quickly preparing a small test program to aid in system development. The callable 117 bug functions used for debugging are listed in Table 3. Table 3. Trap number 15 callable debug functions. Function code. Hexadecimal, description. 0 return to 117 bug. 1 input data from console. 2 output data, CR/LF to console. 3 input data from specified port, no echo. 4 output data, CR/LF to specified port. 5 output data to specified port, no CR/LF. 6 output data to printer port, no CR/LF. 7 convert ASCII string to 8-digit hex number. 8 convert 1 hex digit to ASCII string. 9 convert 2 hex digits to ASCII string. A convert 4 hex digits to ASCII string. IB convert 6 hex digits to ASCII string. LC convert 8 hex digits to ASCII string. Debug facilities. The 117 bug monitor is a command-driven program which has facilities for accepting and executing commands entered at the system console. The debug command set includes commands for examining and modifying registers and memory, commands which allow blocks of memory to be filled, moved or searched for the occurrence of specified data, breakpoint commands which allow program segments to be run, trace ordering information. Part number. Commands for examining the execution of instructions or small program portions, commands for beginning execution at a specified address, and commands for displaying the offset registers. Other commands in the set facilitate host/MVME 117 communications, the formatting of the MINO boards, serial ports, and attaching/detaching the system printer. Another utility converts the number base of data. Program debugging. In a typical debug session after loading the program under development, appropriate commands from the debug set are invoked so that operation of a particular program portion can be checked and, if necessary, the code modified. Often, using the powerful register display/modify, memory display/modify, and block MEM or remove commands, trial conditions for a program are established and the code executed. Results can be determined by examining the processor register or memory values. An alternative method is to set a breakpoint in place of an appropriate instruction to halt execution and obtain automatic display of processor register values. A more detailed examination of program validity is offered by the trace commands, which allow execution of one instruction at a time, with accompanying processor register display following each execution. If required, program code is easily modified with the aid of the one-line assembly/disassembly function provided by the memory modify command. The data conversion command, which converts values from decimal to hexadecimal or Hexadecimal to decimal is also a useful modification tool. Debugging of modular code is greatly eased by the support of the offset registers provided by the 117 bug command set. When the program is fully debugged, it is saved, or the dump srecords command used to format and upload the code to the host for storage. Description: MVME 117 bug. 117 bug, the debug monitor for the MVME 117 mono board. Microcomputer. Includes set of 232 KB EPROMs and user's manual. M68V1X SBG 117 source modules for 117 bug monitor and relocatable object modules. .RO, for SCSI firmware. On 5-1/4 diskettes, readable on any system. Running the VeraDOS operating system. Includes user's manual. M68V1 SCSI source modules for SCSI firmware, providing bus arbitration, handshaking and data transfers to and from SCSI bus. On 5-1/4 diskettes, readable on any system running the VeraDOS operating system. Motorola microcomputer systems and components. 2-18. MVME 117 bug. MVME 117I equals firmware monitor commands. Nojab auto boot enable / disable. IBDJ, jboot dump. BF pattern block fill. BHJ. By. BM address 2, address 3 block move. Bo1, controller I bootload. Nudge aber, count, 2 breakpoint set / clear. BS. BS. BT. CS. DC. DF display formatted registers. Do. GO. GD. GT. He help. 10C1/0 command. LOP 1/0, physical. LOT J. Load J, load S records. MDJ1, options JDIG, 5, memory. Display. MMI, memory modify. MS memory set. NOIPA J printer attach. Of display offset registers. PF1 port format. PT power up test. Set date / time. ST self test. Time display date / time. TRJJ trace. TT trace till. Ta terminal attach. TMJ transparent mode. VEJ, J equals verify S records. 6 vector initialize, cold start. AO-A7 display / modify address. Register. .do-.d7j display / modify data register. .ro-.r7 display / modify offset register. .pcj display / modify program counter. .ssp display / modify supervisor. Stack pointer. .uspj display / modify user stack pointer. .srj display / modify status register. .dfc 68010 display / modify data function code. .sfc 68010 display / modify supervisor function code. VEIR 68010 vector base register. Break, abort command or process. Control D, redisplay line. Control H, delete character. Control S, suspend output, any character to continue, user selectable. Control X, cancel command line. Motorola microcomputer systems and components. 2-19. IVM module. System controller. The MVME 025 system controller offers the arbitration, monitor and utility functions usually required in a VMware bus. System. In one module it combines clock generation, AC fail, and system reset control, bus timeout, and error control and bus arbitration, eliminating the need for these functions on other modules. The module is especially useful in multi-processor and intelligent DMA device applications. Figure 1 is a functional block diagram of the system controller module. Provides VMware system clock, AC fail, system reset, and system test utility functions. Arbiter with selectable priority or round-robin select modes. Supports 4 levels of bus request/allocation. Supports VMware system power fail timing for orderly power down. Selectable power fail input polarity. Supports VMware system power restart timing for power up and self-test. 16 MHz system clock. Bus watchdog timer, period selectable from 4 to 8192 microseconds. Long word access error detector. Front panel Burp *LED indicator. Front panel sysfail *LED indicator. Double high Eurocard form factor. VMware compatible. Bus arbiter. Bus arbitration is used to prevent simultaneous access of the VMware by two masters and for scheduling bus allocation to optimize resource use in a multiprocessor configuration. The system controller module has a header for jumper selection of one of two arbitration modes, priority or round-robin select. In the priority mode, when more than one bus request is pending, the arbiter will grant the bus to the requester of highest priority level. This mode is typically used in systems where bus loading by fixed-rate masters such as DMA devices is nearly 100%, where it is desirable to uniformly distribute the bus loading available to non-fixed data rate masters. The round-robin select mode is used. This mode assigns the bus on a rotating priority basis. Advance information. MVME 025. AC power fail and reset provisions. A means for executing an orderly power down in the event of a power failure is a requisite for any computer system. Such a means is provided by the arbitration structure of the VMware, which also provides a system reset line and an AC power fail line for use in conjunction with an external power monitor module whose function is to detect power failure and also reset the system on power up, initiating a power up self test. Both the system reset and AC fail lines are available at connector P2 on the system controller module, which has logic for detecting the AC fail signal and for asserting the VMware AC fail * and sysreset * signals using proper timing. The module also has a header by means of which positive true or negative true AC power fail input signal polarity can be selected or the signal disabled. Logic on the module, in addition to detection of the signal from the power monitor, also causes an approximately 500 millisecond assertion of the sys fail signal on 1, detection of the AC fail assertion, 2, operation of the front panel push button reset switch, and 3, execution of power up bus watchdog timer. To provide a mechanism for recovering from errors, the module has bus watchdog timer circuitry which terminates a data transfer cycle if a response is not received from a slave within a selected period of time. The circuitry monitors the as DS1 and DS2 lines and starts the timer when any of these is asserted. Lines stack * and Burp are also monitored, and when either is asserted in a normal data transfer sequence, the timer is stopped. In an instance where timeout occurs before either is asserted, Burp is driven low and remains low until as DS1 and DSO* are driven high regardless of the state of DAC*. The module has a jumper header for selection of a timer period in microseconds. A value equivalent to any of the 12 powers of 2 between 4 and 8192 can be selected. Motorola Microcomputer Systems and Components 2-20 MVME 025 Figure 1, System Controller Module Block Diagram. Priority I. Round Robin EXT AC Fail Reset Manual Reset Power Fail and Reset Long Word Error Detector Circuitry which checks the accessed location against the size of the data being transferred can be a valuable tool for preventing one common software error. The module monitors the word asterisk and A01 lines and when word asterisk is asserted. At the start of a long word transfer asserts Burp asterisk if A01 is high, indicating an incorrect double word transfer. Burp star remains high until as asterisk, DS1 asterisk, and DSO asterisk are driven high regardless of the state of DAC*. 4. LS to 8,192, LS. Clock. Generators. Front panel indicators. On its front panel, the module has LED indicators for the Burp asterisk and sysfail asterisk lines, each of which lights when the corresponding signal is asserted. System clock. The system controller provides a clock output to VMware. Specifications, SYSCLK. SYSCLK is a 16 MHz symmetrical system clock which can be used by other modules on the VMware for general clocking functions. Electrical, mechanical, and environmental specifications. Characteristics specifications. Bus allocation speed 100 ns, tip, 130 ns, max. Form factor double high Eurocard. Power requirements plus 5 VDC at 0.5 A, tip. Plus 5 VDC at 0.8 A, max. Temperature. Operating 0 degrees C to plus 55 degrees C. Storage, 55 degrees Celsius to plus 85 degrees Celsius. Humidity 8% to 80%, non-condensing. Physical characteristics. PC board height 9.2 inches. 234 millimeters. PC board depth 6.3 inches. 160 millimeters. Ordering information. Part number Descarlon. MVME 025 VMware module system controller with 2-mode bus arbiter, AC power fail circuitry. Watchdog bus timer and system clock. Includes user's manual. MVME 025/D1 VMware module system controller user's manual. Motorola Microcomputer Systems and Components. 2-21. E. 2 system controller. And 1/0 transition. Modules. System controller. 4-level priority bus arbiter. Power up system reset. Front panel system reset. System clock generator. Serial bus clock generator. Bus access monitor /timeout bus error generator. Time of day clock, with optional battery backup from +5 standby or MVME 701. Printer port, Centronix parallel port. 2 serial ports, RS-232C multi-protocol. Global interrupter, for processor-to-processor interrupts. 2-digit front panel diagnostic display, user program. Mabel. Green and red LED S showing VMware sysfail * status. Front panel 8 segment software readable switch. 8 28-pin sockets for EPROM/RAM. Full 32-bit VMware slave interface for NVMe 050 MEM. ORI, EPROM/RAM sockets. A 32/824D32/D16/D8 VMware slave interface for EPROM/RAM sockets. A 16D8 for I/O. The NVMe 050 system controller module is a combination system controller, system utility, and debug/diagnostic board. It is designed to implement functions that are only required once in a multiprocessing system, such as bus arbitration, bus timeout, system clock generation, and time of day clock. This capability frees up space on the processor modules, avoiding the waste of having functions duplicated on every processor in the system, where only one can be enabled. Figure 1 is a functional block diagram of the NVMe 050. The NVMe 701 I/O transition module is an optional, Euro format, double high companion board to the NVMe 050. It may be attached by a ribbon cable to the NVMe 050 P2 connector, providing standard connectors for the system controller's serial and parallel ports, and optionally, batteries for backup of the NVMe 050's time of day clock. There are no active components on the NVMe 701. Bus arbiter. MISO. NVMe 701. Bus arbitration is straight 4-level priority arbitration. All 4 VMware request lines are continuously monitored. As each request is put on the bus, its priority is compared with all other requests, with bus grant being given to the highest priority requester as soon as the current bus master releases the bus. Several requesters may be daisy-chained on a given priority line, producing positional priority at that level. The bus arbiter also issues a bus clear signal whenever there is a requester with higher priority than the current master. System reset. On power up or when the front panel reset switch is pressed, the NVMe 050 activates the sysreset * line of the VMware to reset all boards on the bus together. As a further option, especially for OEMs configuring a VMware system inside of a larger system, a 4-pin connector on the companion NVMe 701 board allows attachment of a remote system reset switch, which may be used to activate sysreset * system clocks. Both the 16 MHz VMware system clock and the VM's bus serial bus clock are driven by the NVMe 050. Both are derived from an onboard 32 MHz oscillator. Bus timeout. To avoid bus hang-up and to tell a bus master that it has attempted to access an invalid location, the NVMe 050 can generate a bus error if no board has responded to a bus access within a preset time. The timeout time is user selectable between 2.5 and 160 microseconds, jumpers. Motorola microcomputer systems and components. 2 to 22. I. 3. 0. T. 0. 0. 0. 3. 0. 0. CMOs. Time of 0 day clock. 3. MC146818. C. C. T. colon. MI \. 0. N. NU. T. M. 3. N Z 0 0 3 C 0 Z M J 2 serial ports Z T N multi protocol RS232C R68560 I L F L __. Figure 1, MVME 050 functional block diagram. I2 IIT 1 switch 1 reset and 1 display 1 system 1 power up reset control monitor and logic registers BTO logic T sysreset comma 2.5-160/1s acfail sysfaili Burp data strobe 8 RAM/EPROM DAC sockets dash 16-512 KB 7 I 16 mH T equals SYS clock and serial clock dash R bus 1 I bus I interrupter R MC68153 MC68153 IL I1 parallel port 4 level VMware interface Centronix 32-bit VMware M address data compatible arbiter control interface 2L P2J VMware connector P1 S CJ1 S A L I MVME 050 MVME 701 time of day clock. A Motorola MC146818 clock chip keeps track of date, year, month, day, and time, hours, minutes, seconds. With an accuracy based on a 0.001% quartz crystal. The clock can generate VMware interrupts at a software SE. Select time of day, or daily at a selected time, or at periodic intervals ranging from 100 microseconds to 500 millisec. ONS. Optional PowerShell backup operation is available either from batteries on the companion MVME 701 IO TRAN Session module or from the VMware Plus 5 standby, as selected. By jumpers. Printer port. A buffered Centronix type parallel port at the MVME 050s. P2 connector is provided for a system printer. When the MVME 050's P2 connector is cabled to the companion MVME 701 IO transition module, a Motorola standard 50 pin Centronix parallel port connector is provided. 2 serial ports. Using the Rockwell R68560 multi-protocol communications controller, MPCC, each serial port can operate in full duplex, asynchronous, or synchronous protocols, at up to 19,200 baud, async, or 1 MHz, sync. Baud rate limitation will be determined by the restrictions of the software being used. Synchronous operations supported include several bit and character-oriented protocols, such as SOLC, HOLC, X.25, OICMP, X3.28, or ISO IS1745. With the MVME 701 connected to the MVME 050's P2 connector, the RS232C signals are routed to 2 standard 25-pin OB25 connectors on the front edge of the MVME 701. Global interrupter. A global 4-channel interrupter allows one processor Module to interrupt another in a multiprocessor system. This could be used to signal process completion in a task. Sharing system or to signal semaphores which control access to shared resources in a multi-user system. The global interrupter function is implemented by the Motorola MC68153, a 4-channel interrupter chip, with program Mabel levels and vectors for each channel. One channel may optionally be connected to the VMware sysfail* line. Front panel displays. There are 2 front panel displays on the NVMe 050, 2 sysfail* LEDs, and a diagnostic display. 2 LEDs on the front panel display the status of the VMware sysfail* signal, a red LED for sysfail* active, and a green LED for sysfail* inactive. A 2-digit hexadecimal display, capable of displaying the decimal digits 0 through 9 and the letters A through F, representing the values in the base 16 number system, may be used to display diagnostic information in case of system error, or any other user-defined information. The display can show 100 decimal numbers from 00 to 99, or 256 hexadecimal numbers from hex 00 to hex FF. Software readable switch. An 8-segment software readable switch on the NVMe 050. Front panel allows an operator to choose one of 256 different binary codes to select different system modes or other functions a system designer may assign to the switches. The switches might, for example, be used to select system diagnostic modes or to select between different primary bootload disks. RAM/EPROM. 8 28-pin memory sockets on the NVMe 050 may be used to provide system RAM for common data structures, such as semaphores or job queues. The sockets may also provide system EPROM for common test routines or boot loaders or a combination of both. Headers allow for configuration of each socket quad, group of 4 sockets addressed together by a 32-bit VMware access, as necessary, to accommodate a wide variety of memory devices. Maximum capacity is 64 KB of RAM, 88K x 8 static RAM, or 512 KB of EPROM, 864K x 8 EPROMs, or a RAM/EPROM. Combination with 32 KB of RAM and 64 KB of EPROM. The VMware interface to the memory on the NVMe 050 is designed in anticipation of the 32-bit VMware systems of the near future, with a full 32-bit interface, a 32:032. It remains compatible with today's 16-bit systems, supporting 24-bit addressing and 16 or 8-bit data transfers as well. A24:016/08. Switching between modes is automatic, depending on the mode in which it is accessed. Even in a multiprocessing environment with mixed 16 and 32-bit processors, this capability could provide common system memory for all. Note, all devices in a quad must be of the same type. Address map of NVMe 050. RAM/EPROM memory. Address is jumper definable for EPROM and RAM independently, on boundaries equal to 8 times the device size. Example, a quad of 2K x 8 RAMs, e.g. the Motorola MCM65116, could be set at VMware address, hex 000000, or hex 004000, or hex 008000, etc. I/O memory. The short I/O address space occupied by the NVMe 050 is a 512-byte block, odd bytes only, which may be located On 512 byte boundaries starting at FUO, e.g. FUO, FF0200, FF1000, etc. Note, factory jumper position is FF1000, as shown below. FF1000 Rs232C serial port 164 bytes. FF1040 Rs232C serial port 264 bytes. FF1080 parallel printer port 32 bytes. FF10AO read, switch/write, display 32 bytes. FF10 co-interrupter 1, MVME 050 interrupts, 32 bytes. FF10EO interrupter 2, global interrupts, 32 bytes. FF1100 time of day clock 128 bytes. FF1180 unused. R. FF1200. Motorola Microcomputer Systems and Components. 2-24. MVME 050, MVME 701. Mechanical and Environmental Specifications, MVME 050. Characteristics Specifications. EPROM/RAM IO. Configuration OTB slave, A24/A32A16. 08/016/03208. Arbiter, priority, 4 level. Interrupter, any one of I1, 1, 7, dynamic. Form factor double high Euro card. Card dimensions. Height 9.2 inches. 234 millimeters, width 6.3 inches. 160 millimeters. Front panel dimensions. Height 10.2 inches. 261 millimeters, width 0.83 inches. 21 millimeters. Power requirements +5 VDC at 3.7A, tip, 4.4A, max. +12 VDC at 140 mAh, tip, 170 mAh, max. -12 VDC at 35 mAh, tip, 42 mAh, max. Environmental limits. Operating temperature 0 degrees Celsius to 50 degrees Celsius. Inlet air temperature for 200 LFM airflow. Forced air cooling. Storage temperature -40 degrees Celsius to 85 degrees Celsius. Humidity 5% to 90% relative humidity, non-condensing. Mechanical and Environmental Specifications, MVME 701. Characteristics Specifications. Configuration MVME 050 transition card, no VMware connection. Form factor double high Euro card. Card dimensions. Height 9.2 inches. 234 millimeters, width 3.1 inches. 80 millimeters. Front panel dimensions. Height 10.2 inches. 261 millimeters, width 0.83 inches. 21 millimeters. Power requirements none, no active components on MVME 701. Environmental limits. Operating temperature 0 degrees C to 50 degrees Celsius ambient. Storage temperature -40 degrees Celsius to 85 degrees Celsius. Humidity 5% to 90% relative humidity, non-condensing. Motorola Microcomputer Systems and Components. 2-25. MVME 050, MVME 701. I. Ordering information. Part number description. MVME 050 System Controller Module and User's Manual. MVME 701 I/O Transition Module for MVME 050. Includes User's Manual. MVME 050/D MVME 050 System Controller Module and MVME 701 I/O Transition Module User's Manual. Related documentation. Part number description. MVME/DVME System Architecture Guide. 68650 N06 Rockwell, R68560 Product Description. MC68153/D Motorola MC68153 VBIM Datasheet. MC146818/D Motorola MC146818 Time of Day Clock Chip Datasheet. Motorola Microcomputer Systems and Components. 2-26. VMware Module. Mono Board. Microcomputer. High Performance 16-bit Mono Board Microcomputer. MC68000 16-bit MPU. 1632-bit data, address and stack registers. 14 addressing modes. 16 MB direct addressing range. Memory mapped I/O. 56 powerful instruction types. Operations on 5 data types including bit, byte, word, long word and BCD. Provides interlock instruction for multiprocessor SYS. TEMS. 256 multilevel vectored interrupts including internal X, sept ions, traps, and external interrupts. Architecturally optimized for efficient support of high-level languages. VMware compatible. Double Eurocard form factor. Up to 128 KB of onboard ROM. Up to 64 KB of onboard RAM. Full operation isolated from VMware. Multiprocessor mode. 2 RS-232C serial I/O ports. 20 programmable I/O lines. Triple programmable 16-bit counter timer. Accessible from off-board. Hexadecimal LED status display. 7 jumper selectable interrupt priority levels. VMware Arbiter. 0°-70°C operating temperature range. The NVMe 101 monoboard microcomputer is a high-performance processing module designed to function as a standalone microcomputer, as a single CPU/controller in a VMware system or as a single CPU element in a multi-pro. Advanced information. SES or VMware configuration. This module features Motorola's MC68000 16-bit microprocessor with an address range of 16 MB. Sockets are provided for up to 256 KB of user-supplied memory. Synchronous and asynchronous serial communication at up to 19.2 kB is supported through 2 front panel ports and 2 independent 8-bit parallel communication channels are available at a rear panel connector. Access to a triple 16-bit programmable timer is also provided. The NVMe 101 monoboard microcomputer in combination with the VMware module chassis, other VMware modules, and the Veridu's real-time operating system can provide a complete design environment which frees the system designer to develop the unique software/firmware required for an application. Figure 1 diagrams the major functional components of the NVMe 101 monoboard microcomputer. Data organization in memory. To provide asynchronous byte addressing over the 8 megaword range accessible using address lines A01 through A23, the MC68000 separates its 16-bit data word into a lower data byte, 000-007, and an upper data byte, 008-015. Rather than address line A00, the external signals lower data strobe, corresponding to the lower data byte, and upper data strobe, corresponding to the upper data byte, are used to access a byte within a data word. Accordingly, any memory block for the MC68000 must be made up of 2 identical blocks, one connected to the lower data lines and activated by the lower data strobe LOS, the other connected to the upper data byte lines and activated by the upper data strobe UDS. Motorola Microcomputer Systems and Components. 2-27. I. MVME 101. Figure 1, MVME 101 Functional Block Diagram. Module. Status Clock. Control Circuit. Reg. MVME 101 Memory Array. DAC. Generator. BTO. Counter. An array of 8 28-pin sockets connected as 4 pairs. Is provided on the module for user-supplied RAM or ROM. These can be any JEDEC standard byte-wide static memory. In a 24 or 28-pin dual inline package and of 2K, 4K, 8K, 16K or 32K size, of single plus 5.0V operation, having high IMPT-ANS, MOS, inputs and 3-state outputs and meet the timing requirements described in the MC 68000 MON. Board Microcomputer User's Manual, MVME 101/D1. Address Map Configuration. The module has address decoding logic which divides the interrupt handler, reset, circuit, serial, communication, interface, 16 MB address range of the MPU into high, middle, and low blocks, as shown in Figure 2. All accesses by the MPU of the middle block, from 100,000 to foo, are direct off-board to the VM bus. Accesses of the 00000002 off low-range addresses and of the foo to FFFFFF. High-range addresses are decoded by a decoder PROM and onboard device selection logic. According to the internal ROM program, high and low block accesses are directed to global memory and memory map devices, local IO devices and the 4 local memory device socket pairs. The decoder PROM, organized as 512 x 4 bits, divides the 2 MB of high and low block addresses into 512 4K. Motorola Microcomputer Systems and Components. 2-28. MVME 101. Figure 2, Address Map Configuration. MPU address. I. FFFXXX. FFEXXX. High block. F01XXX. F00XXX. I/EFFXXX. EFEXXXF./ 101XXXFI. 100XXXI/. 0FFXXX. 0FEXXX. 001XXX. 000XXX. Byte segments. Use of this programmable device provides a means of mapping local and global resources into separate memory areas as required by an application. The mono board is shipped with the decoder PROM program to provide the map organization shown in Table 1. Local 1/0 devices and the module control and status registers are mapped by the PROM as shown in Table 2. The PROM program and the MVME 101 debug package accommodate the requirement of the mono board for ROM in memory socket pair number 4. ROM is required since, following power up or reset, the MPU on the first 4 cycles fetches the supervisor stack and program counter values from the first 8 locations of the memory socket pair number 4 address area. Note also that the RAM, in socket pair number 1, required by the debugger is reflected in the decoder PROM program map. Selected device. VME standard address. Decoder PROM. Address data. -1 FFF VME standard address. 1 FEE VME short 1/0 address. D. C. B not used. A. 1019. 1008 local 1/0 devices. 0FF7 ROM in socket pair 4. 0FE6 ROM in socket pair 3. 5 ROM in socket pair 2. 4 ROM in socket pair 1. I. 3 invalid. I. 2 RAM in socket pair 3. I. 0011 RAM in socket pair 2. I. RAM in socket pair 10000. Local memory device configuration. The module has 4 jumper headers which are used to configure the module for use with the specific type and size of memories installed in socket pairs 1 through 4. An other header allows jumper selection of the proper timing for the type of ROM devices used. VMware arbiter/requester. A system which permits multiple master type modules to share the data transfer bus must use a means of dealing in an orderly manner with concurrent requests for use of the bus. The VMware means is to use modules having bus request handler bus arbitration capabilities and to designate one master type module as the system controller. The MVME 101. Motorola Microcomputer Systems and Components. 2-29. MVME 101. I. Address. FFFFFF. FUO. FEF. FE 1000. FEF. FIO. FDFFFF. F04000. F03FFF. FU. F. 003000. 002FFF. 002000. 001FFF. 0010000. UF. 000800. 0007FF. 000400. 0003FF. 000000. Table 1, MVME 101 address map. As shipped. Contents. VMware short I/O addresses. VMware standard addresses. Onboard I/O registers. Only odd addresses used. VMware standard addresses. MVME 101 bug debug package. Or user-provided program. VMware standard addresses. User program/data. User program/data. User program/data. MVME 101 bug data/stack. MPU exception vectors. Selected devices. Global I/O devices. Global memory. Or memory map devices. Local I/O devices. Global memory. Or memory map devices. 2x8 KB local ROM. In memory socket pair 4. Global memory. Or memory map devices. 2x2 KB local RAM. In memory socket pair 3. 2x2 KB local RAM. In memory socket pair 2. 2x2 KB local RAM. In memory socket pair 1. Motorola Microcomputer Systems and Components. 2-30. MVME 101. Table 2, 1/0 register address map. As shipped. Device address mode. MCRFEOF1R/W. MSRFEO1R/W. PTM FEOF red. FEOF right. FEO red. FEO right. FEO red. FEO right. FEO9 red. FEO9 right. FIO7 read. FIO7 write. FIO5 read. FIO5 write. FIO3 read. FIO3 write. FIO1 read. FIO1 write. FIO1 write. PFOOC7 r/w. FOOC 5 r/w. FOOC 5 r/w. FOOC 3 r/w. FOOC 1 r/w. FOOC 1 r/w. PCI2 FOOB 7 r/w. FOOB 5 r/w. FOOB 3 read. FOOB 3 write. FOOB 1 read. FOOB 1 write. PCI1 FOOA 7 r/w. FOOA 5 r/w. FOOA 3 read. FOOA 3 write. FOOA 1 read. FOOA 1 write. Module uses a programmable logic array to implement bus requester and arbiter functions which comply with the bus arbitration protocols of the VMware specification. Additional circuitry is used to meet the VMware timing and driving requirements. Bus arbiter, so that it can be used as the system controller in a VMware register. Module control register. Module status register. LSB buffer register. Timer number 3 latches. Timer number 3 counter. MSB buffer register. LSB buffer register. Timer number 2 latches. Timer number 2 counter. MSB buffer register. LSB buffer register. Timer number 1 latches. Timer number 1 counter. MSB buffer register. Status register. Control register number 2. No operation. CR20 equals 1, control register number 1. CR20 equals 0, control register number 3. Section B control register. CRB2 equals 1, section B peripheral register. CRB2 equals 0, section B data direction register. Section A control register. CRA2 equals 1, section A peripheral register. CRA2 equals 0, section A data direction register. Command register. Mode register number 1 I mode register number 2. Status register. SYN1 register. SYN2 register IOLE register. Receive holding register. Transmit holding register. Command register. Mode register number 1 I mode register number 2. Status register. SYN1 register I SYN2 register IOLE register. Receive holding register. Transmit holding register. System, the MVME 101 module has an option 1 single level arbiter which arbitrates requests on level 3. System controller operation requires that the module be placed in slot number 1 of the VMware backplane to ensure that the module is first in the daisy chain arbitration structure and has, therefore, the highest priority. The module also has a header from which a jumper is removed to disable the arbiter when the module is used at a lower priority in a multiprocessor system. Motorola Microcomputer Systems and Components 2-31 E I MVME 101 Bus Requester. The module has a type rower, release on request, bus requester so that the module can be used in systems where maximum data transfer rate is essential. The requester monitors all 4 bus request lines and releases the VMware signal BBSY only when another bus request is pending. This operation reduces the number of arbitrations required of a bus master. 2 means of requesting the VMware are provided by the module. the ROR mode in which the bus is automatically requested when the MPU starts either a VMware data transfer cycle or interrupt vector fetch and under program control by setting the bus block transfer request, BBTR, control register bit. The latter method protects routines against interruption by other bus requests. With BBTR set, VMware is never released except when the module is used in a multilevel AR bitration system. Then a higher level request causes the module arbiter to assert BCLA, resulting in a maskable auto vector interrupt request at the MPU, providing the option of clearing BBTR under control of an interrupt service routine. To control idle state time in the software transparent ROR mode, the 128 microsecond bus request timeout counter can be activated by setting an appropriate control bit in the module control register. The module has two headers for jumper determination of the priority level at which the requester will operate. 1. Allows connection of the module's bus request out signal to the VMware signal line of appropriate priority level. The other allows connection of the VMware bus grant in line of the AP appropriate level to the bus requester. Connection of the requester bus grant out signal to the appropriate VMware line. Connection of unused VMware bus grant input to bus grant output lines for propagation of these signals to the system modules having bus requesters of those levels. VMware interface. VMware is characterized by the asynchronous bidirectional operation required for complex, high-performance systems. The VMware interface on NVMe 101 supports operation in a multiprocessor system and the full 16 MB address range of the MC68000 MPU. Access to the backplane address, data, and control lines is provided by the triple row, 96-pin VMware connector at the upper rear of the module. Pin assignments, connector physical characteristics and VMware signal and timing requirements are fully described in the VMware specification manual, MEB/01. On the module, logic independent of the MPU generates the signal handshaking and timing required by the VMware data transfer protocol. Of the 14 address modifier codes defined by the VMware specification, a subset of 6 is supported by the module. These are listed in Table 3. Note that address modifier lines 3 and 5 are not driven by the interface logic but are kept in the high state by terminating resistors. On the backplane, bus supervision counters. The module has two counters for supervising VMware AC accesses, the bus request timeout counter, BRTO, and the OTA transfer timeout counter, AUTO. Each can independently be enabled and disabled under software control by setting in the control register the bit corresponding to that counter. If bit 6 in the control register is set at the time the MPU accesses an off-board location, the BRTO counter starts. After 128 microseconds, if the bus is not yet available, bit 6 in the status register is set and the signal bus error is as served. If bit 7 in the control register is set at the time the MPU asserts a data strobe at the beginning of an off-board data transfer cycle, the auto counter starts. After 8 microseconds, if the data transfer is not yet acknowledged, bit 7 inches, the status register is set and the signal bus error is asserted. Operating mode control. The module has a header for jumper connection to the arbiter of the VMware system control signals required for Table 3, address modifier codes. AM address modifier. Code 543210 function. 3 times 10 to the power of first 11110 standard supervisory program access. 311101 standard supervisory data access. 3A111010 standard non-privileged program access. 39111001 standard non-privileged data access. 21011001 short supervisory 1/0 data access. 29101001 short non-privileged 1/0 d.ada access. Motorola Microcomputer Systems and Components. 2 to 32. MVME 101. Operating in the system controller configuration or in the STAN. DARD non-controller configuration. Included are the output signal SYSCLK, the bidirectional signal sysfail asterisk, and the reset asterisk input and output signals. When the module is up, errat in the isolated mode, none of these signals is connected to VMware of the signals sysfail asterisk and sysreset asterisk required for operating in a particular mode is accomplished by jumper in the mode configuration header, interrupt handler, reset and halt functions. The module interrupt handler circuitry manages all interrupt requests of local and system origin. It determines the pending interrupt request of highest priority and asserts a corresponding code on the 3 MPU interrupt priority lines. The module has 2 headers for jumper determination of which of the system and local reset can be performed by either the power up reset circuitry or the reset switch. Local reset and system halt can be executed by the MPU connection or not. Table 4, Connector P2 pin assignments and signal descriptions. Pin signal. Number mnemonic description. Row A pins 1 through 32 GND system ground. Row C pins 1 plus 5.0 V supply. 2 CB2 PIA peripheral control, side B. 3 CB1 PIA interrupt control, side B. 4 PB7 PIA peripheral data, side B. 5 PB6 PIA peripheral data, side B. 6 PB5 PIA peripheral data, side B. 7 PB4 PIA peripheral data, side B. 8 PB3 PIA peripheral data, side B. 9 PB2 PIA peripheral data, side B. 10 PB1 PIA peripheral data, side B. 11 PBO PIA peripheral data, side B. 12 PA7 PIA peripheral data, side A. 13 PA6 PIA peripheral data, side A. 14 PA5 PIA peripheral data, side A. 15 PA4 PIA peripheral data, side A. 16 PA3 PIA peripheral data, side A. 17 PA2 PIA peripheral data, side A. 18 PA1 PIA peripheral data, side A. 19 PAD PIA peripheral data, side A. 20 CA2 PIA peripheral control, side A. 21 CA1 PIA peripheral interrupt, side A. 22 plus 5.0 V supply. 23 C3 asterisk PTM clock input 3. 2403 PTM output 3. 25 G3 asterisk PTM gate input 3. 26 C2 asterisk PTM clock input 2. 2702 PTM output 2. 28 G2 asterisk PTM gate input 2. 29 C1 asterisk PTM clock input 1. 3001 PTM output 1. 31 G1 asterisk PTM gate input 1. 32 plus 5.0 V supply. Motorola Microcomputer Systems and Components. 2 to 33. MVME 101. 7 VMware interrupt lines, which of the 4 local I/O devices or which of the 2 VMware signals BCLR and SYSF all are used as user vector and auto vector interrupt request sources by the MPU. The non-maskable, AutoVec toward interrupt level 7 is not available but is reserved for software abort and AC power failure. Control register. The module control register is an 8-bit read/write register, which resides in the local I/O segment of the memory map. Bits in the register can be set/cleared to control the module. Hexadecimal display, the SYSF all signal output, the block transfer request, the bus request timeout counter and data transfer timeout counter. Status register. The module status register is an 8-bit read/write register, which resides in the local I/O segment of the memory map. Bits in the register indicate the current level of the VMware bus. Signals ACF all, SYSF all, abort, BCLR, BAV, the low cal signal PCI1RXD and whether or not a bus request TI meout or a data transfer timeout has occurred. VMware bus connector P1. The electrical and mechanical characteristics of VMware bus connector P1 are fully described in the VMware bus specification. Manual MEB/D1. Peripheral input/output connector P2. Peripheral connector P2 is a DIN 41612 connector with 64 pins, rows A and C, installed. Pin assignments and signal descriptions for connector P2 are given in Table 4. Communications interfaces. Interfaces for both serial and parallel communications are provided on the module. An externally accessible triple programmable timer module is also provided. The 2 serial ports are accessible via 2 25-pin connectors on the front panel. The programmable timer module and the parallel port are accessible via a rear panel connector, P2. Serial ports. The serial communication capability of NVMe 101 is derived from 2 MC68661C enhanced programmable communication interface devices. These devices support several synchronous or asynchronous protocols in full or half duplex mode, provide software selectable baud rates ranging from 50 to 19,200 baud. On NVMe 101, both ports are RS-232C compatible and may, by jumper, be configured as dataset or data terminal. Prior to beginning serial data communications, the MC68661C registers must be loaded with a set of mode and command bytes as described in the device data sheet. Parallel port. A universal means of interfacing peripheral equipment to the module is provided by a MC6821 peripheral interface adapter, PIA. This device has 2 8-bit bidirectional peripheral data buses and 4 control lines providing a general parallel communications capability for the control of various peripherals. Each of the peripheral data lines can be programmed as an input or output, and each of the 4 control/interrupt lines can be programmed for operation in one of the several modes. The module has a header in which, to establish interrupt priorities, PIA interrupt output lines can be jumper connected to the desired auto-vectored interrupt request lines. Programmable timer module. A generally useful timing function is provided by a MC6840 programmable timer module, PTM, which contains 3 cascadable, 16-bit binary counters, 3 corresponding control registers and a status register. The module has a header For jumper configuration of the PTM inputs and outputs to obtain various modes of operation. The PTM can be programmed to generate module interrupts and / or output signals, such as square waves, gated delay signals and signal pulses, of controlled or modulated duration for use in event counting, and interval or frequency measurement. Software/firmware support. Motorola provides standard software packages to support VMware module monoboard microcomputers within the categories of real-time executives and operating systems, and debuggers/loaders. The principal features of these software products are as follows. RMS68K real-time multitasking system software. Memory resident, roamable. Physical, channel, I/O. Multitask dynamic scheduling. Software and hardware interrupt processing. High-speed interrupt response. Inter-task communication and task synchronization. Dynamic allocation and management of RAM. User trap handling. Exception processing. Time delay, periodic task activation, time of day. Easy addition of user-written device drivers. Upward compatible to real-time disk operating system. Compatible with EX/ORMAX system software. Customization via Sysgen. Motorola microcomputer systems and components. 2-34. MVME 101. VeraDUS, real-time disk operating system block initialize. Provides all real-time multitasking software features of block move. RMS68K search for a masked value. Device independent I/O and logical I/O trace with optional instruction count. Wait and proceed I/O. Standard device drivers. Multi-level file directories. Shared file access. Downline/upline load. Single-line assembler/disassembler. Hardware/software development support. Dynamic or contiguous file space allocation. The recommended vehicles for developing 16/32-bit microcomputer systems based on a VMware module monoboard microcomputer are the EX/ORMAX MC68000 development system and the VME/10 microcomputer system in either the VeraDUS real-time operating system or System V/68 operating system environment. Both operating systems offer a complete set of high-performance software development tools. Both support Motorola 16/32-bit hardware emulators and bus state analyzer used for hardware/software integration and debugging in the target system. Random, sequential, and indexed sequential file access. VME 101 bug, debug/monitor/loader firmware. Initialization. Display/change memory. Display/change registers. Set and clear breakpoints. Mechanical and environmental specifications. Characteristics specifications. Power requirements plus 5.0 VDC at 180 mAdC, tip. Temperature. Operating 0°C to plus 70°C. Storage, 55°C to plus 85°C. Relative humidity to 95%, non-condensing. Physical characteristics. PC board only. Height 9.2 inches. 234 millimeters. Depth 6.3 inches. 160 millimeters. Thickness 0.63 inches. 16 millimeters. PC board and front panel. Height 10.3 inches. 262 millimeters. Depth 7.4 inches. 188 millimeters. Thickness 0.8 inches. 20.3 millimeters. PC board form factor double high Euro card. Ordering information. NVMe 101 VM module monoboard microcomputer with the MC68000L8 MPU, 2 serial ports, and 2 parallel I/O ports. Includes 8 sockets for 2K to 32K byte RAM/ROM. Devices, 16 bidirectional parallel I/O lines, 3 offboard accessible programmable. 16-bit counters/timers, hexadecimal LED status display and 7 interrupt levels with bus arbitration. NVMe 101/DVM module monoboard microcomputer user's manual. Motorola microcomputer systems and components. 2 to 35. IVMe 101 bug. Debugging packages. For the NVMe 101 monoboard microcomputer. 101 bug resident package. EPROM resident system debug monitor. 30 powerful commands. Single line assembler/disassembler for convenient program monitoring. Full speed execution of system and user developed programs operating in the VM module monoboard micro computer system. Virtual terminal capability for up/downline load from an EX or Max development system or from any host computer. Command set allows access to all VM module 1/0, control and memory facilities plus the full 16-byte direct address range of the VM bus. Includes disk controller initialization and disk 1/0 commands for the NVMe 315 intelligent floppy controller /SUSI interface. Includes boot facilities for loading the VirtuS OS and for dumping VMware system RAM contents to disk. Includes all required installation and operation documentation. 101 bug source and relocatable object module package. Source and relocatable object modules for 101 bug on diskette or cartridge disk. Relocatable object modules allow users to include only the 101 bug items needed in their end system. Source modules allow user modification of 101 bug as desired. Advance information. NVMe 101 bug. NVMe 101 Bugelf. NVMe 101 Bugelk. The NVMe 101 monoboard microcomputer debug pack. Age 101 bug is available as 2 separate product offerings. 101 bug is an EPROM-based resident package ready for installation and immediate use with the NVMe 101 monoboard microcomputer installed in a VMware backplane. Such a backplane is provided within Motorola's NVMe 900 series chassis. 101 bug source and relocatable object modules are a separate product available on either VirtuS compatible floppy disk or cartridge. 101 bug provides a powerful evaluation and system debugging tool for VM module systems. The EPROM resident package will operate in 32K bytes of ROM space. 101 bug uses the first 4K bytes of RAM storage for interrupt vectors and temporary storage. The EPROM resident package is delivered in two 16K byte EPROMs. Table 1 lists the commands available to the user. The package permits execution of system and user developed programs operated in a NVMe 101 monoboard microcomputer system environment under complete operator control. 101 bug may be utilized with a monoboard microcomputer in a standalone environment with only a user provided standard Rs232C asynchronous ASCII terminal. Alternately, it may be used with the second serial I/O port of the NVMe 101 connected to a host computer for up/downline Loading of programs in Motorola's record format. When connected to a host computer in this manner, the NVMe 101/101 bug combination appears as a virtual terminal to the host operating system. NVMe 101 bug also provides program and operating sys tem downloading facilities from floppy or hard disk into the VMware system RAM through the NVMe 315 intelligent floppy controller-less ASI interface. After loading, 101 bug commands may be used to examine and modify memory, set breakpoints to run particular program segments, and track program progress. The user may set up and examine a variety of conditions using any of the powerful commands listed in Table 1, such as the register display / set series and the memory block manipulation commands. Motorola Microcomputer Systems and Components 2-36 NVMe 101 bug, NVMe 101 bugle, NVMe 101 bugle. The data conversion command serves as an aid in examining and modifying data by converting hexadecimal to decimal, and decimal to hexadecimal. If corrections or program patches are required, these may be performed and checked. In the VMware module, the user may send a corrected copy to the host computer files by using the memory dump command for upline load. Alternatively, memory contents can be saved on floppy or hard disk via the NVMe 315 intelligent floppy controller/SUSI interface. Creating program patches may be aided by use of the display offsets command to assist with relocatable and position-independent code. The user may also copy all traffic to the serial port debug terminal on a printer attached to the NVMe 101 parallel port by use of the attach printer command. This may be useful for disk debugging following a debug session. The user may communicate with the host computer as a terminal for purposes other than up/downline load by executing the transparent mode command. By using the port format command, the serial port may be reconfigured for such attributes as baud rate, stop bits, and number of data bits. Bootstrap load and dump commands permit the user to bootstrap from several device combinations through the NVMe 315 intelligent floppy controller/SUSI interface. The drives currently supported are the 5v4 Winchester and the 5v4 floppy and /or 8 floppy. The boot dump command permits the user to write complete memory contents to a diskette/disk in Bootstrap load format for subsequent use in bootloading. The lot command permits the user to create the floppy/hard disk format required. 101 bug may be used for debug in system environments, which include the NVMe 101 monoboard microcomputer, other Motorola VMware modules and user-developed VMware compatible modules. The source and relocatable object module packages provide users with the information to link 101 bug into their specific systems in either modified or unmodified form. The relocatable object modules are designed to permit creation of a load module with or without the record up/downline loader. Source modules permit the user to modify or customize any of the 101 bug functions as desired. Table 1 to 101 bug commands. Command description. MD. MS memory set. A display all address registers. AO, A7. D display all data registers. 0.00 to 0.07. PC. .SR. .SS, display/set supervisor stack pointer. .us. Of display formatted registers, all. BF block fill, with 16-bit data word, memory. BM block move. BSJ. By block initialize. BT block test of memory. DC data conversion. Of display offsets. .ro, .r6. Motorola Microcomputer Systems and Components. 2-37. I. MVME 101 bug, MVME 101 bugle, MVME 101 bugle. Table 1-101 bug commands, continued. Command description. BR, breakpoint set, up to 8. NOBRL, breakpoint remove, any or all. Go execute program. GT go until breakpoint, sets temporary breakpoint. D go direct, no breakpoint or track set, and no exception vector changes. TRL trace, set for number of instructions. TT trace to temporary breakpoint. PA printer attach, print as well as display. NOPA reset printer attach. PF port format, set serial port attributes. TM transparent mode, 2 serial ports. Transparently connected. He help, display VMware commands. Do. Dump, S record upline load. Low, equals text load, S record downline load. VE equals text verify, S record downline load verify. BD, boot dump. BH, boot halt. BO, boot operating system. LOP disk 1/0 physical. LOT disk 1/0 teach. Command line edit and control functions. Break, abort command. Del, delete character. Control D, redisplay line. Control H, delete character. Control W, suspend output. Control X, cancel command line. CR, send line to memory. When Control W is used, the user can cause the output display to continue by entering any character. Ordering information. Part number description. MVME 101 bug 101 bug, the MVME 101 monoboard microcomputer system debug package. Includes EPROM set and user's manual. MVME 101 bugle source and relocatable object modules for the 101 bug system on Veridus. Diskette for the EXORMAX development system. Includes user's manual. MVME 101 bugle source and relocatable object modules for the 101 bug system on Veridus. Cartridge disk for the EXORMAX development system, includes user's manual. MVME 101 budget MVME 101 bug debugging packages user's manual. The MVME 101 bug EPROM set is copyrighted by Motorola and may be copied only under prior written agreement from Motorola. MVME 101 bugle and MVME 101 bugle sources are copyrighted and licensed by Motorola. They may be obtained only under the required license agreement with Motorola. Motorola Microcomputer Systems and Components. 2-38. Advance information. VMware module trademark. VMware bus. Processor module. Low-cost single-board computer offered in 4 versions. Standard features. On all 4 versions. A24/A16D16/D08, EO, VMware bus interface. MC68010 CPU at 10 MHz. 512 KB dual access DRAM, with 0 wait cycle read. 1 wait cycle write. 2 EPROM sockets, for up to 128 KB of 0 wait cycle EPROM. 2 additional sockets, for EPROM, EPROM, or SRAM can also be used for CMOS RAM or clock. Calendar with on-chip battery. Async/sync RS232C serial port on front panel. Async/sync RS485/422 serial port on P2 connector. 8-bit parallel 1/0 port with 4 handshake and 5 control lines, 4 Centronix printer or parallel 1/0. 4 timers, 24-bit timer with 125 ns resolution, local. And VMware timeout, and watchdog timers. Global Control Status Register, CSR. Software readable 8-bit switch. Single level arbiter and system controller. Optional debug monitor available for each VMware. Processor module. Special features. Unique to each version. Each of the 4 versions has a different 1/0 interface. On its P2 connector. NVMe 104, Motorola 1/0 channel bus. NVMe 105. No connect. NVMe 106, 5-1/4 floppy disk. NVMe 107, SCSI bus interface. Optional debug monitor available for each processor. Module. The NVMe 105 family of VMware single board computers are designed for embedded controller and small real-time system applications. They have a common architecture and offer standard features sufficient to satisfy the requirements of most applications. Special 1/0 on the P2 connector optimizes each of the 4 versions for particular markets and applications. The NVMe 104 with Motorola's 1/0 channel bus interface may be used as the controller for a complete system. NVMe 105. NVMe 105. NVMe 104. NVMe 106. NVMe 107. Based on the industrial 1/0 peripherals available for this bus, NVMe 400 and NVMe 600 series modules. For EPROM-based systems or those using VMware for mass storage, the baseboard, NVMe 105, has no special 1/0 interface. As such, it is also the least expensive board in the family. Small systems requiring only a small amount of mass storage can use the NVMe 106 with a 5-1/4 floppy disk interface. Even larger systems with other mass storage might use the NVMe 106 to add floppy disk inexpensively. For those with more elaborate 1/0 and mass storage requirements, the NVMe 107 with its standard small computer systems interface, SCSI, bus provides access to high-speed disk, tape, and other peripherals for a small additional cost. This will become increasingly attractive as more peripheral vendors offer their products with an embedded SCSI interface. The common architecture means easy portability of user application software from one CPU to any of the others as system requirements change. One might, for example, develop programs on the NVMe 107, with its SCSI mass storage, and then use an NVMe 105 or NVMe 106 in the production system. Or, if a working NVMe 105 based system develops problems at the end customer's site, the service technician can simply replace it with the NVMe 106 or NVMe 107 to run diagnostics on the rest of the system and the software. Motorola Microcomputer Systems and Components. 2-39. NVMe 105, NVMe 104, NVMe 106, NVMe 107. NVMe 104, 1/0 channel RS485. NVMe 105. Not used, serial. NVMe 106, 5-1/4 floppy. NVMe 107, SCSI bus. Figure 1. NVMe 105 series block diagram. Microprocessor. All four members of the NVMe 105 family are based on the MC68010, a microprocessor of proven architecture, optimized for efficient support of high-level LAN gauges and secure operating systems. MC68010 features include 32-bit internal data, address, and stack registers, 14 addressing modes, 16 MB direct addressing range, 57 instruction types, operation on 5 data types, bit, byte, word, long, word, and BCD. 256 multi-level vectored interrupts. Fast loop mode execution for frequently needed sequences. Onboard memory. 512 KB of dynamic RAM, DRAM, and sockets for up to 256 KB of EPROM provide sufficient memory for large single board computer, SBC, applications. The DRAM is dual access, meaning that it can be accessed by the on-board CPU or by other CPUs and peripherals from the VMware. There is no parity checking on the DRAM. Read accesses of DRAM by the onboard CPU take 4 CPU clock cycles. This is the maximum possible speed, also known as zero-wait cycle operation. Write cycles are slower, taking 5 CPU clock cycles, 1 wait cycle. Access from the VMware is slightly slower, since the onboard CPU must complete whatever cycle is in process and release control of the DRAM to the VMware. Access times from the VMware will range between approximately 650 ns to 1200 ns, depending on what operation the local CPU was performing when the request was made. From the point of view of the onboard CPU, the DRAM normally occupies the bottom of the memory map, 000, 000 through 07FFFF, hexadecimal. See Table 1. Optionally, the DRAM can be mapped to address E80000 through EFF. FFF if the user wishes to access the VMware at address 0. From the point of view of a device on the VMware, the DRAM may be set to occupy any address range in the 16 MB address space of the A24 VMware, on a 512 KB boundary. Switches are provided for this selection only. The DRAM and a global control/status register are accessible from the VMware. Other onboard resources, EPROM, serial ports, etc., are all private, and are accessible only from the onboard CPU. There are 4 28-pin memory sockets on the board. 2 of these are dedicated for EPROM, and accept either 32kx8 or 64kx8 devices. Accessed as a SINGIE 16-bit wide memory, they provide up to 128 KB of EPROM MEM. ORI. With 300 ns or faster EPROMs, these memories also provide zero-wait cycle operation. The board is shipped with these sockets empty, but in a typical application, as with the Veridu's operating system, they would be used for the debug/monitor firmware. Motorola microcomputer systems and components. 2 to 40. NVMe 105, NVMe 104, NVMe 106, NVMe 107. The other 2 sockets, also accessed as a single 16-bit wide memory, can be used for additional EPROM, for a total of 256 KB, but also support read/write access for use with static RAM, non-volatile memory like EEPROM, CMOS RAM with built-in battery, or special purpose devices which combine RAM with a clock/calendar function. A logical configuration might be a RAM with on-chip battery in one socket and a RAM/clock/calendar with on-chip battery in the other. Serial 1/0. The Zilog Z8530, a serial communications controller, provides two multi-protocol serial ports for the NVMe 105 family of microcomputers. On the front panel is an RS-232C compatible serial port with a standard DB25 connector. Jumpers can be used to configure the port for DCE or DTE operation, and for synchronous or asynchronous protocol. The second serial I/O port is brought out through the P2 connector on the module's back edge. It is wired as an RS-485 differential interface, and jumpers are used to configure the interface as master or slave, and to select 8-, 4-, or 2-wire operation. The RS-485 interface is an extension of the RS-422 differential interface, with greater current drive and tri-state capability. It can be used for point-to-point communications, or in a multi-drop configuration with several RS-485 interface devices sharing a common serial line. Differential drive is much less sensitive to noise than RS-232C and is particularly well suited for use in an electrically noisy environment and/or for very long cable lengths at high data transfer rates. A typical system configuration might be a series of small control or data collection nodes, each with an NVMe 105 single board computer as the local intelligence, and all linked together and to a central host computer by means of an inexpensive 2-wire RS-485 multi-drop line. The Z8530 serial port controller chip offers the following features: software programmable baud rates from 50 baud to more than 64K baud. Software selectable NRZ, NRZI, or FM data encoding. Asynchronous mode, with software programmable 5 to 8 bits per character. 1.5 or 2 stop bits per character. Break detection and generation. Parity, overrun, and framing error detection. Synchronous mode, with internal character synchronization on 1 or 2 characters. CRC generation and checking with CRC16 or CRC chit. Digital phase locked loop for clock recovery. Local loopback and auto echo features. Parallel 1/0. A full Centronics compatible 8-bit parallel I/O port is provided on each of the NVMe 105 family of CPUs. Meant as a standard 36-pin shielded Centronics connector on the front panel, it can directly support parallel printers or can be used for general parallel I/O. There are 8 I/O data lines, 4 handshake lines and 5 control lines, all controlled by means of an onboard MC68230 parallel interface/timer. Timers. 4 timers are implemented on the module. 3 are dedicated to error recovery functions, local bus timeout, VMware bus timeout, and watchdog timing. They are designed to aid the CPU in regaining control if an addressed device on the local bus or VMware bus fails to respond, or if an executing program gets lost. Watchdog timer. The fourth timer, a 24-bit timer running at 8 MHz, 125 ns. Resolution is available for use by the operating system or application software. A special clock/calendar device, such as the TOMP Sun/Mistec MK48T02/25, may be installed in one of the auxiliary memory sockets, if desired. System Controller I-Bus Requester. The NVMe 105 series microcomputers can work as the VMware system controller in the slot 1 position in a VMe bus chassis. A system controller is responsible for VMe bus arbitration, in this case, single-level arbitration on Level 3, SYSCLK generation, the 16 MHz reference clock. On VMware System Reset, SysReset**, generation on Power Up or from the front panel, and VMware Timeout. A switch disables these functions when another board is acting as system controller. Bus request logic on the NVMe 105 boards allows the modules to request access to the VMware on any of the 4 VMware request levels, jumper selectable. Only. Level may be used if the system controller functions are enabled. The bus release protocol is release on request. ROR, an early release of bus busy is supported to allow concurrent arbitration for optimum bus utilization. VMware interface. The NVMe 105 series modules all have a 24-bit address /16-bit data VMware interface, A24D16, for both master and slave operations. They may be used in a standard a 24D16 VMware system with a P1 only backplane, or in an extended a 32D32 system with a combined P1 and P2 backplane. If used in a 32-bit system, the designer must recognize that they will still respond only to trans FERS with A24 or A16 address modifier codes. There is no connection to the extended VMware address and data signals on row B of the P2 connector. But P2 rows A and C are used for 1/0, so a P2 backplane, if used, must have pass-through pins for this purpose. There are, in a sense, 3 interfaces between the NVMe 105 series CPUs and the VMware. 1. What the local CPU sees of VMware when it is VMware master. 2. The dual access DRAM as it appears on VMware 2 other VME masters. 3. The 105 CSR space as it appears on VMware 2 other VME masters. Motorola Microcomputer Systems and Components. 2-41. I. NVMe 105, NVMe 104, NVMe 106, NVMe 107. As VMware master, the NVMe 105 family module can access most of the lower 16 MB of VMware address space. As shown in the memory map in Table 1, VMware occupies all of the memory space except where onboard DRAM and other local resources are decoded. In addition, the VMware address modifier lines can be manipulated to access any of the alternate VMware memory spaces reserved for user-defined applications. Control/status register. The control status register, CSR, is a special purpose dual-ported, 16-bit memory that exists both in the local CPU's memory space and in the short 1/0 space on VMe bus. It is used to control certain functions on the NVMe 105 family module, to allow the status of those functions to be read both by the local CPU and other devices on VMware, and to provide a quick means for a VMware device to signal the local CPU. As seen from the VMware, the CSR register resides at one of two switch selectable short 1/0 space addresses relative to the selected address of the 512 KB DRAM module base address. Seen from the local CPU, the CSR resides at a fixed address in local memory. Figure 2 shows the CSR bit functions. Control functions in the lower 8 bits include the watch, dog timer, enable/disable, interrupt enable, enable all/, disable all, the system fail signal to VMware, drive actival, not driven, and 2 of the address modifier control lines mentioned above. These can all be read or written by the local CPU, but are read-only for a device on VMware. The upper 8 bits, bits 8, F, are read-write for both VME bus and the local CPU. Primarily intended to allow a VME bus device a means other than VMware interrupts to SIG. NAL the local CPU, it works by writing values with a 0 in any of the bits 8. B, which generates a local interrupt on level 2 or level 7. The other bits can be used as desired, possibly as a source identifier or command code. 1. Use of this mechanism might be to implement the buff aired pipe protocol, where the signal tells the local CPU to look for data in global memory. Short VMware I0 address space. VMware read-write VMware read-only. CPU read-write. Figure 2. Module CSR register. 1/0 channel, MVME 104 only. The 1/0 channel is an 8-bit data, 12-bit address bus for specific application system expansion. Modules from Motorola's MVME 400 series and MVME 600 series can be added to provide a wide range of functions including serial and parallel port expansion, Winchester, and floppy disk, with the M68RWIN1. 9-track tape, analog 1/0, digital 1/0, and even AC power 1/0. Except for the M68RWIN1, all of these conform to the single high Eurocard form factor, and are supported with cables and backplanes for use in VMware chassis. Appearing in the MVME 104's local memory space as a 4 KB block, the 1/0 channel is easy to use and is fully supported by the VeraDOO's real-time operating system. Floppy disk interface, MVME 106 only. The MVME 106 has a direct interface to Shugart SA400. Compatible 5-1/4 floppy disks, up to 4 daisy-chained disks. Implemented with the Western Digital WD1770 disk controller, it supports 125 KB/SFM or 250 KB/SMFM. Formats for single or double density disks, single or double-sided, 48 or 96 tracks per inch. SCSI bus, MVME 107 only. The small computer SIDEMS interface, SCSI, bus is quickly being accepted as the standard bus interface for peripheral 1/0. Designed as an extension of Shugart's SCSI bus, SCSI is a medium performance bus supporting data transfer rates up to 1.5 MB/s, asynchronous, and up to 7 peripherals. Supported peripherals under the VeraDOO's operating system include floppy disk and Winchester disk. Other peripherals available with the SCSI bus interface that could be used with the MVME 107, but not currently supported with VeraDOO's drivers, include SMD disks, optical disks, streaming tape, 9-track tape. and even system-to-system communications. Using the NCR 5380 SCSI bus controller chip, the NVMe 107 implements a single-ended, arbitrating, asynchronous SCSI bus interface as defined in revision 16 of the ANSI X3T 9.2 committee specification. It can operate in either the initiator or target roles, and supports disconnect, reconnect and the common command set. Data transfer between SCSI bus and the onboard memory, or VMware memory, is handled by the local CPU using what NCR calls the pseudo-DMA mode of the NCR 5380 running at 10 MHz, the MC68010 CPU can transfer data over SCSI bus at approximately 700 kb/s. Table 1. Physical address map. View from onboard CPU, typical configuration. 000000 through 000007 reset vector, from EPROM, for the first 4 memory cycles after reset. RAM thereafter. 000000 through 07FFFF dynamic RAM. 080000 through EFFFFF VMware. FU 000 through F1FFFF EPROM, 2 sockets, possibly R.repeated. F20000 through F3FFFF auxiliary RAM/ROM/EPROM/clock. Sockets. F40000 through FBFFFF VMware. FC000 through FCFFFF local resources, serial and parallel ports. FDO000 through FDFFFF control/status register, CSR. 110 channel, etc. FFO000 through FFFFF VMware short 110 space. Motorola Microcomputer Systems and Components. 2 to 42. NVMe 105, NVMe 104, NVMe 106, NVMe 107. Software support. A debug monitor for the NVMe 105 series of VMware processors is available in 2 EPROMs that plug into sockets on a module. To allow customization, it is also available as source code on 5-1/4 diskettes readable on any system running the Motorola Veridu's real-time operating system. A powerful, sophisticated tool, NVMe 105 bug, or 105 bug for short, allows full-speed execution of system and user programs under complete operator control. It offers 35 powerful commands for application program development and modification and for hardware diagram gnosis and debugging of systems based on any of the processor modules. Facilities for loading an operating system and programs from floppy or hard disk into a target system are included in 105 bug. Supported disk and tape controllers for each module are shown in Table 2. Test and diagnostic capabilities in 105 bug include a power-up sequence self-test that tests the MC68010 microprocessor, ROM, and RAM resources required to bring up the monitor, and a test invoked by user command that performs more intensive testing. A trap number 15 handler is included in 105 bug that facilitates calls from a user program to input, output, and other useful 105 bug functions, and also facilitates, in the NVMe 107, communication with the MCR 5380 device used for the SCSI interface implementation. A complement of functions is provided that can be used to obtain read, write, and other activities from disk drives connected to controllers on the SCSI bus. Table 2. Controllers supported by NVMe 105 bug. NVMe 104, NVMe 105, NVMe 106, NVMe 107. NVMe 319XXXX. NVMe 320AXXXX. NVMe 360XXXX. Local floppy X. SCSI X. NVMe 350XXXX. X supported. Mechanical and environmental specifications. Characteristics specifications. VMware configuration DTB master A24/A16D16/D08, EO. DTB slave A24/A16D16/D08, EO. Single level arbiter, level 3. Requester, any one of R0. R3, static rower, early release. Interrupt handler, any of IH0. IH7. Static. Form factor double high Euro card. Physical dimensions. Card dimensions: height 234 mm, 9.2, depth 160 mm, 6.3. Front panel height 261 mm, 10.2. Width 21 mm, 0.83. Power requirements. NVMe 105 plus 5V, 5 ATIP. Plus or minus 12V preliminary values. NVMe 104/1061107 plus 5V, 5 ATIP. Plus or minus 12V. Environmental limits. Operating temperature 0 degrees C to 55 degrees Celsius. Inlet air temperature with forced air cooling. 0 degrees C to 40 degrees Celsius ambient, convection cooling. Storage temperature, 40 degrees Celsius to 85 degrees Celsius. Humidity 5% to 90% relative humidity, non-condensing. Motorola microcomputer systems and components. 2 to 43. E. NVMe 105, NVMe 104, NVMe 106, NVMe 107. Ordering information. I. Part number description. NVMe 105 VMware single board computer module featuring 10 MHz MC68010. CPU, 512 KB shared DRAM, sockets for up to 256 KB EPROM. RS-232C serial port, RS-485 serial port, 8-bit parallel port, 24-bit timer, and system controller. NVMe 104 same as NVMe 105, but with I/O channel interface. NVMe 106 same as NVMe 105, but with 5-1/4 floppy interface. NVMe 107 same as NVMe 105, but with SCSI bus interface. NVMe 105 bug. The debug monitor for the NVMe 104, NVMe 105. NVMe 106 and NVMe 107 VMware processor modules. Includes set of 232 KB EPROMs and user's manual. M68 VXPG 105105 bug source modules on 5-1/4 diskette readable on any system. Running the Motorola Veridus operating system. Includes users manual. Motorola microcomputer systems and components. 2 to 44. VMware module. Mono board. Microcomputer. High-performance 16-bit monoboard microcomputer. MC68000 16-bit MPU. 1632-bit data, address and stack registers. 14 addressing modes. 16 MB direct addressing range. Memory mapped I/O. 56 powerful instruction types. Operations on 5 data types including bit, byte, word, long word, and BCD. Provides interlock instruction for multiprocessor systems. 256 multilevel vectored interrupts including internal exceptions, traps, and external interrupts. Architecturally optimized for efficient support of high-level languages. VMware compatibility with bus arbitration logic. Double Eurocard form factor. Incorporating high reliability pin/plug type connectors. 8 MHz version available, customer upgradable to 10 MHz. RS-232C serial port configured as DCE, may be connect to DTE for debugging. I/O channel support for offboard serial, parallel 110 and A/D, D/A, AC and DC switching and mass storage. Functions. 8 28-pin sockets for user provided 2, 4, 8, 16, 32K. X8 ROM/PROM/EPROM or 2, 4, 8K X8 RAM devices. Zero wait state operation at 8 MHz with 150 ns or faster. Static onboard RAMs. Up to 7 levels of interrupt priority may be jumper selected. 3 16-bit, cascadable programmable timers/counters. Jumper selectable MPUE clock or baud rate clock input. VMware requester and interrupt support. Push button reset and abort controls. Fail, halt, and run LED status displays. 0°C 70°C operating temperature range. MVML0L. Functional description. The VMware module monoboard microcomputer is a high-performance processing module, designed to function as a standalone microcomputer, as a single CPU/controller in a VMware system, or as a single CPU element in a multi-processor VMware configuration. This module features Motorola's MC68000 16-bit microprocessor with a total address range of 16 megabytes. Sockets are provided to accommodate up to 256 KB of user-supplied memory. Full support is provided for the Motorola 110 channel, which provides access to a large variety of peripheral and industrial 110 functions. An onboard serial communications port is also included. The NVMe 11.0-1 monoboard microcomputer in combination with the VMware module chassis, VMware module accessory cards, 110 channel accessory cards and Veridu's real-time multitasking disk operating system provides a complete design environment that frees the system designer to develop the unique software/firmware required for the application. Figure 1 diagrams the major functional components of the NVMe 110-1 monoboard microcomputer. Local memory. Sockets are provided for use of 28-pin 8K, 16K, and 32K byte ROM/PROM/EPROM and RAM devices. A jumper header is provided so that compatible 24-pin 2K, 4K, and 8K byte devices may optionally be used. Another header facilitates jumper selection of operation with memory devices of various access times. Local onboard RAM is not accessible from the VMware interface and, under Progr.m control, local RAM can be protected against a program executing in the MC68000 user state. Any number of 2K byte blocks in the ranges 0000000. Motorola microcomputer systems and components. 2 to 45. NVMe 110-1 through 03FFFF and foo through F3FFFF can be configured for software-controlled write protection by reprogramming the VMe 110-1 map decoder PROM. Local bus. The VMe 110 employs a Motorola MC68000 16-bit micro Processor operating at 8 MHz. To allow full speed processing. While another VMware master is operating, a local bus is used to interconnect the MPU with ROM, RAM, the serial 1/0 port, the 1/0 channel, the programmer timer module, PTM, and the VME11.0 status and control registers. A header is also provided to allow jumper enabling of a local bus time out counter that generates a bus error signal for any SI equals LE not completed within 200 IJS. Serial port. An RS-232C serial port is provided to facilitate downloading of programs and use of a terminal. This front accessible port is implemented as data circuit terminating equipment, DCE, and may be connected to a data terminal equipment, DTE, device for use in debugging. Programmable timer/counter. For implementing various interrupts and interval timers, an MC6840 programmable timer module provides 3 independent cascadable 16-bit counters. Input to one counter may be jumper connected to the MPU clock or baud rate clock. 2 counters and an enable/disable bit in the module. Control register, MCR, may be used to implement a watch dog timer for resetting the VME11.0 or external system if the processor fails to service an interrupt within a specified interval. This feature can be used to protect hardware and software and facilitate recovery from fault conditions. Status monitoring and control. Push buttons are provided for the functions of reset and abort. These buttons may be disabled by the user, after system development, if the board is to be used in a critical application. LED status lights are provided to indicate run, halt, and fail status of the board. Fail indication may be due to system failure, or to an error detected in a user supplied power on self-test routine. Figure 1, block diagram. VMware module monoboard microcomputer. 828 pin. ROM/RAM. Sockets. Motorola microcomputer systems and components. 2 to 46. MVME 110-1. VMware interface. VMware is characterized by the asynchronous bidirectional operation required for complex, high-performance systems. The VMware interface provided on the VME11.0 module supports direct memory access, DMA, multiprocessor operation, and the full 16 MB address range of the MC68000 MPU. Designs requiring an expanded microcomputer function can utilize the VMware interface to add other resources, such as RAM and intelligent 110 controllers. Pins for all VMware address, data and control lines are provided in the triple row, 96-pin VMware connector P1. Data transfer bus arbitration. Each VME 110 module contains the requester logic required to request and acknowledge mastership of the data transfer bus, DTB, on any one of 4 priority levels, bus request lines. In a multi-master system, one VME 11.0 module is configured as system controller and performs single-level arbitration for all DTB masters on bus request level 3 only. On any level when a request is received and the bus is not busy, the arbiter issues a bus grant via the bus grant daisy chain and waits for the grantee to activate bus busy. The cycle is then completed by the arbiter deactivating bus grant in DTB request/release. Programmed access by a VME 11.0 module to an off-board VMware bus resource is obtained by a request being placed on bus request line corresponding to the level selected by strap on the requesting module. When the DTB is no longer busy, the bus arbiter grants mastership to the requester via the bus grant daisy chain. After using the bus, a VME 11.0 requester releases the bus according to the mode determined by the bus release bits in its own module control register. Interrupt handler. The VME 11.0 can respond to 7 levels of prioritized interrupts. This capability is used to accommodate 2 distinct groups of 7 interrupts each, interrupts incoming over the VMware bus interrupt lines IRQ1 through IRQ, and local interrupt requests. For the latter group, the MPU's auto vector feature is used to obtain service for interrupts from local sources such as the asynchronous communications interface adapter, ACIA, and the programmable timer module, PTM, for the sysfail signal and for the I/O channel interface. 4 interrupt levels are assigned to the I/O channel. Vectors for IRQ and signals are read from the DTB during an interrupt acknowledge. In this cycle, after gaining bus master ship, the VME 110 places on the lower 3 address lines the interrupt level to be acknowledged and activates LAC and the appropriate strobe signals. The interrupting device then places the interrupt vector on the lower data byte lines and acknowledges the data transfer. The vector is then used as a pointer to the MPU exception vector table. I/O channel. The Motorola I/O channel is specifically designed to provide efficient low-cost distributed communications to peripheral and I/O controller boards. It provides a 12-bit address bus, and an 8-bit bidirectional data bus, and supports asynchronous operation at data rates up to 2 MB/section. 4. Those modules performing time-critical operations, for prioritized interrupt lines are also provided. The I/O channel is designed to operate over either a backplane, or a ribbon cable up to 12 feet in length. Available I/O channel modules include NVMe 400 dual channel RS-232C serial port, synchro, new/asynchronous, NVMe 410 dual channel 16-bit parallel port, Centronix, compatible, NVMe 420 SUSI peripheral adapter, NVMe 600,605 analog input and output, NVMe 610, 615, 616 opto-isolated 120V/240V input and output, NVMe 620, 625 opto-isolated 30V DC input and output, M68RWIN1 Winchester disk controller module, M68 RAD1 remote intelligent analog to digital conver Xeon module, M68RI01 remote input/output module. Memory mapped I/O. The memory map for the NVMe 110:1 monoboard microcomputer is shown in Figure 2. Software/firmware support. Motorola provides software packages to support the VMware module monoboard microcomputer, within the categories of real-time executives and operating systems, and debuggers/loaders. The principal features of these software products are as follows. RMS68K, real-time multitasking system software. Memory resident, roamable. Physical, channel, I/O. Multitask dynamic scheduling. Software and hardware interrupt processing. High-speed interrupt response. Inter-task communication and task synchronization. Motorola microcomputer systems and components. 2 to 47. I. MVME 110-1. 015. FFFFFE. FUO. FEF. FE8032. FE8030. FE802E. FE8022. FE8020. FE801E. FE8010. FE800E. FE8004. FE8002. FE8000. FE7FFE. FE6000. FE5FFE. FEOU. FDFFFE. F40000. F3FFFE. FU. F. 040000. 03FFFF. 000000. Notes. Figure 2, MVME 110.1 memory map. 0807. VME short 1/0 address. VME. High block. Local memory or VME. Selectable on 2K byte boundaries. VME. Low block. Local memory or VME. Selectable on 2K byte boundaries. Do. FFFFFF. FF0001. FEF. FE8033. FE8031. FE802F. FE8023. FE8021. FE801F. FE8011. FE800F. FE8005. FE8003. FE8001. FE7FFF. FE6001. FE5FFF. FE0001. FDFFFF. F40001. F3FFFF. FU01. F. 040001. 03FFFF. 000001. Shaded portions indicate redundant 110 addresses and should not be accessed. The initial addresses for the SSP and the PC are obtained from the first forward locations of the ROM installed in socket pair 1. Motorola Microcomputer Systems and Components. 2 to 48. MVME 110-1. Dynamic allocation and management of RAM. User trap handling. Exception processing. Time delay, periodic task activation, time update. Easy addition of user-written device drivers. Upward compatible to real-time disk operating system. Compatible with EX or Mac system software. Customization via Sysgen. Veridues, real-time disk operating system. Provides all real-time multitasking software features of RMS68K. Device-independent I/O and logical I/O. Wait and proceed mode I/O. Standard device drivers. Multi-level file directories. Shared file access. Dynamic or contiguous file space allocation. Random, sequential, and indexed sequential file access. VMware, debug/monitor/loader firmware. Initialization. Display/change memory. Display/change registers. Set and clear breakpoints. Block initialize. Block move. Search for a masked value. Trace with optional instruction count. Downline/upline load. Single line assembler/disassembler. Boot routine for M68RWIN1, Winchester controller, and MVME 420, SUSE peripheral adapter. Hardware/software. Development support. For development of VMware applications utilizing any MO. Torola 16-bit or 8-bit MPU/CPU chips. The recommended development system is the VME/10 microcomputer system. VME/10 is a 5-1/4 floppy disk and 5-1/4 Winchester-based system designed around the MC6801016/32-bit microprocessor unit and the MC68451 memory management unit. VME/10 provides an I/O channel interface, offers I/O channel and VMware card cages, and can host all Motorola family hardware development tools. These include the HDS400 for M68000 family 16/32-bit emulation, the HDS200 for M6800 family emulation, and the bus state analyzer for logic analysis. The VME/10 incorporates the real-time, multitasking operating system VeraDOS, an MC68000 family macro assembler, a symbolic debugger and a diagnostic/bootstrap monitor, and offers advanced software development tools. These include a Pascal compiler with a fast floating point option, a Fortran compiler, and CRT and linkage editors. The Unidos operating system package is also available for VME/10 for multi-user development of VMware applications based on the MC68000. The EXORMAC : development system is recommended. Since EXORMAC also supports VeraDOS, it can utilize the same hardware and software development tools as VME/10. Application programs designed to operate under VeraDOS may easily be developed and checked out in the EXORMAC environment, then downloaded into the VMware target system for final debug. System expansion. VMware modules designed for use with NVMe 110-1 include 64K and 256KB DRAM modules, 16-socket RAM/ROM/EPROM module, IEEE 488 listener talker/controller modules, I/O channel modules in single high Eurocard format. For use with NVMe 110-1 module include dual port, synchronous/asynchronous serial module, dual port parallel, Centronix compatible, module, SUSI peripheral adapter, interface for 8 or 5-1/4 disks, buffered 9-track magnetic tape adapter, multichannel, 12-bit ND module, multichannel, 12-bit D/A module, opto-isolated AC/I/O module, opto-isolated DC/I/O module. I/O channel modules in non-Eurocard format include remote, intelligent ND module, remote, 16-socket, solid-state relay, opto-22 type module, Winchester disk controller module, hard and floppy 8 and 5% disks. Packaging and accessories. 5-9- and 20-slot backplanes, 20-slot card cage, 40 amps at 5 VDC power supply with optional power monitor, single, 30, and double, 60, wire wrap and extender cards, adapter to front mount I/O channel to 50-pin ribbon, connector, Motorola microcomputer systems and components. 2-49 NVMe 110-1 Specifications. General specifications for the VME 110 are as listed. Table 1, VME 110 specifications. Characteristic specification. Power requirements plus 5 VDC, plus or minus 5%, 2.1A, typical, 2.4A, maximum. With all 8 sockets unpopulated, plus 12 VDC, plus or minus 5%, 25 mA, typical, 50 mA, maximum. -12 VDC, plus or minus 5%, 25 mA, typical, 50 mA, maximum. See note. Power requirements plus 5 VDC, plus or minus 5%, 2.6 A, typical, 3.0 A, maximum. With all 8 sockets populated, plus 12 VDC, plus or minus 5%, 25 mA, typical, 50 mA, maximum. -12 VDC, plus or minus 5%, 25 mA, typical, 50 mA, maximum. See note. Temperature. Operating 0 degrees -70 degrees Celsius. Storage, 55 degrees to plus 85 degrees Celsius. Relative humidity 0% to 90%, non-condensing. Physical characteristics: double high VME board. Height 9.2 inches. 234 millimeters. Depth 6.3 inches. 160 millimeters. Thickness 0.662 in. 16.77 millimeters. Note, the currents at plus 12 VDC and minus 12 VDC are specified for the NVMe 11.0 module with the serial port connectors open. The actual required values depend on the load of the RS-232C port. All serial port outputs are current limited to sink or source 12 mA, maximum, each. Table 2, RS-232C serial port connector J15 pin assignments and signal descriptions. Signal. Pin number, mnemonic signal name and description. 1,4,9-19,21-25, reserved, not connected. 2TXD transmit data from terminal. This signal is connected to the ACIA receive data input. 3RXD receive data to terminal. This signal is connected to the ACIA transmit data output. 5CTS clear to send, indicates terminal may send data. This signal is controlled by the ACIA RTS output. 6DSR data set ready, indicates to terminal that port is ready. When power is applied, this signal is true. 7GND signal ground. 8DCD DTA carrier detect, indicates to terminal that data carrier is present. When power is applied, this signal is true. 20DTR data terminal ready, indicates to port that terminal is ready. This signal is connected to the ACIA CTS input and must be true for the ACIA to transmit data. Motorola microcomputer systems and components. 2 to 50. NVMe 110-1. Ordering information. I part number description. NVMe 110-1 VM module monoboard microcomputer. This module contains the MC68000L8 MPU. Sockets for up to 256 KB of RAM/ROM/EPROM, serial port, a triple programmable timer/counter, VMBus interface, 110 channel interface, and system controller features. Operates at 8 MHz clock. Includes user's manual. NVMe 110/DVM module monoboard microcomputer user's manual. Related documentation. MC68000 MC68000 16-bit microprocessor user's manual. MC6840 MC6840 programmable timer fundamentals and applications. Bug/DVM bug debugging packages user's manual. HB212/DVM specification manual. M68 RIOX input/output channel specification manual. Accessory modules include part number description. NVMe 264K dynamic RAM VM module. NVMe 201256K dynamic RAM VM module. NVMe 210 static RAM /ROM 1K, 2K, 4K, 8K, 16K x8 VMe module. NVMe 211 static RAM /PROM 1K, 2K, 4K, 8K x8 plus 5V standby for CMOS RAM VMe module. NVMe 300 GPIB listener, talker, controller VMe module. NVMe 400 dual channel RS232C serial port I/O channel module. NVMe 410 dual channel 16-bit parallel port I/O channel module. NVMe 420 SUSI peripheral adapter 110 channel module. NVMe 612-bit, 16-channel single-ended, 8-channel differential ND/I/O channel module. NVMe 601 16-channel expansion board for NVMe 600. NVMe 605 12-bit, 4-channel D/A/I/O channel module. NVMe 610 opto-isolated, 8-channel AC input 110 channel module. NVMe 615 opto-isolated, 8-channel, 0-crossing AC output I/O channel module. NVMe 616 opto-isolated, 8-channel, non-zero crossing AC output I/O channel module. NVMe 620 opto-isolated, 8-channel, DC input I/O channel module. NVMe 625 opto-isolated, 8-channel DC output I/O channel module. M68 RAD1 remote, intelligent ND conversion module. M68 R101-1 remote input/output module. M68 RWIN1 Winchester disk controller module. Note: all VMe Module 100 series and 200 series modular products are of double Eurocard form factor, VMware compatible. Applicable software/firmware. MVMebug VMware debugging packages, 32K x8 EPROM, diskette, or cartridge. M68 GDOS 4.5 Veridus operating system. Motorola microcomputer systems and components. 2-51. I. Advance information. VMe module trademark. Mono board. Microcomputer. MC68010 microprocessor running at 10 MHz. Provision for MC68881 floating point peripheral, CUS. Timer supplied option. 0 wait state memory, 512 KB, 1 wait cycle. Memory with parity enabled. 1 multi-protocol RS232C serial port, P2 interface. And 1 asynchronous serial debug port, to null interface only. 2 independent 8-bit parallel ports with I/O hand. Shake lines. SCSI bus interface with pseudo DMA channel. Time of day clock/calendar with battery backup. Battery back socket accepts 2K x8 or 8K x8 CMOS. RAM. MC68B40 programmable timer module provides 3 independent timers/counters. Interrupt handler with programmable vectors for on board interrupts, PROM. VMware system controller. Provides system clock, SYSCLK. Single level arbiter, level 3 only. VMware timeout. System reset generator. VMware interface, D8/D16, A24 master. Standalone operation require 5 a terminal, power supply, and optionally a SCSI disk. 4 EPROM sockets accept 8K x8, 16K x8, 32K x8, or 64K x8 JEDEC standard parts. Devices with 250 ns. Access times, or less, run with 1 wait cycle. Devices with 450 ns access times, greater than 250 ns. And less than 450 ns, run with 3 wait cycles. VMware requester. Status LEDs for halt, run, and fail. Reset and abort switches. Remote reset, P2 interface. 8-bit software readable front panel switch. 8 bits of software readable board configuration. PROM. NVMe 7081 interconnect transition module available to direct P2 interface to remote reset in addition to standard SCSI, RS-232C, and printer connectors. Advanced information. Software support. MVML 17.3. NVMe 117.3 FP. NVMe 117.4. 117 bug debug monitor with SCSI support available. In source or object code. RMS68K real-time multitasking kernel available in source or object code. Veridu's real-time operating system available in source or object code. ROM-based basic interpreter. An application note describing the software macros required to implement the MC68881 floating point coprocessor as a peripheral in an MC68000/008/010/012 system. High-level language support, Veridu's, Pascal, and Fortran available in source or object code. The NVMe 117 VMware monoboard microcomputer is a high-functionality, high-performance VMbus compatible microprocessor module that offers most functions needed for a complete computer system on a single EU record. This microprocessor module is versatile enough to run standalone as a packaged single-board computer or as a part of a modular, user-configurable VMware computer system. There are 5 versions of the NVMe 117, designed to meet the processor needs of a wide array of users. Refer to the ordering information for descriptions of the 5 versions. Figure 1 is a functional block diagram of the NVMe 117 module. Motorola Microcomputer Systems and Components. 2-52. NVMe 117-3, NVMe 117-3 FP, NVMe 117-4. Serial 110. VMware bus. Interface bus. Requester. PL. Figure 1. NVMe 117 functional block diagram. MC68010 MPU. Processing on the NVMe 117 is performed by the MC68010 16-bit microprocessor operating at a fixed 10 MHz. This microprocessor has a proven architecture, optimized for efficient support of high-level languages and secure operating systems. The MC68010 offers the following popular features: 32-bit data, address, and stack registers, 14 addressing modes, 16 MB direct addressing range, 57 instruction types, operation on 5 data types, including bit, byte, word, long word, and BCD. Interlock instruction for multiprocessor system operation. Fast loop mode operation. 256 multilevel vectored interrupts. MC68881 floating point peripheral. The NVMe 117 module is equipped with a socket to accept the MC68881 floating point peripheral, a customer supplied option. The MC68881 is a high performance, single chip MOS VLSI floating point processor. The MC68881 is primarily intended to operate as a closely coupled coprocessor with the full 32-bit MC68020 MPU, but it can also operate as a memory mapped peripheral as it is on the NVMe 117. When installed, The MC68881 functions as a 16-bit peripheral to the ME68010 that performs floating point arithmetic functions to full IEEE compatibility. The NVMe 117 can supply frequencies of 10 MHz, 16 MHz, or 20 MHz to the MC68881 socket, thereby allowing the maximum performance POS possible with the available MC68881 onboard memory. The NVMe 117 is equipped with 512 KB of onboard local RAM with byte parity. When parity is disabled, programs operating from onboard RAM run without wait cycles using a 10 MHz MC68010 microprocessor. When parity is enabled, these programs encounter one wait cycle. 4 28-pin sockets are available for EPROMs. For example, these sockets may contain the NVMe 117 bug monitor with the intelligence for the SCSI bus interface, self-test, and bootload. The user may install up to 256 KB of ROM in these sockets. Motorola Microcomputer Systems and Components 2 to 53. NVMe 117-3, NVMe 117-3 FP, NVMe 117-4. One socket is provided for battery-backed CMOS RAM. This 28-pin socket accepts a 24-pin 2K-X8 CMOS RAM or a 28-pin 8K-X8 CMOS RAM. System constants and other parameters that can change over time but must not be lost in a power down or power fail condition may be stored and retrieved in this battery-backed memory. Serial 1/0. The Zilog Z8530, a serial communications controller, provides 2 serial ports for the NVMe 117. A RS-232C compatible serial port with a DCE to terminal, asynchronous interface is accessible on the front panel of the NVMe 117. The other RS-232C compatible multi-protocol serial port is accessible at the P2 connector of the NVMe 117, or optionally, on the front panel of the NVMe 708 transition module. The multi-protocol port has the following hardware features: software programmable baud rates, digital phase locked loop for clock recovery, multi-protocol operation under software control, programmable for NRZ, NRZI, or FM data, encoding, asynchronous mode with 5 to 8 bits per character, and 1.5, or 2 stop bits per character, programmable clock factor, break detection and generation, parity, overrun, and framing error detection. Synchronous mode with internal character synchronization on 1 or 2 characters and CRC generation and checking with CRC16 or CRC chit reset to either 1s or 0s. SDLC/HDLC mode, local loopback and auto echo modes, DCE or DTE interface, jumper selected on NVMe 708 module. Parallel 110 ports. 2 independent 8-bit parallel ports are provided on the NVMe 117. Each port has one output handshake line and one input handshake line. The input handshake SIG NAL may be programmed to interrupt on a high level or a low level. Each 8-bit port may be programmed as buffered or latched input or as latched output. The 2 ports may be combined and used as CI Centronix printer port. These ports may be interfaced via the NVMe 117 P2 connector or, optionally, they may be interfaced through the NVMe 708 transition module. SCSI bus interface. The NVMe 117 provides a small computer systems interface, SCSI, bus interface on the P2 connector. Alternatively, the user may employ a standard connector. SCSI bus interface on the optional NVMe 708 transition module. Implemented with the NCR5380, this interface supports the SCSI bus as defined by the ANSI X3T 9.2 committee. With the NCR5380, the NVMe 117 can operate in either the initiator or target roles and therefore can be used as a host or as a control unit. The MC68010 interface to the NCR5380 incorporates a pseudo DMA channel that, with the loop mode of the MC6S010, allows a burst data transfer rate of approximately 500 kb/sec between the on-board RAM and the SCSI bus in either direction. Time of day clock/calendar. A battery-backed real-time clock is provided on the NVMe 117 to provide timekeeping and calendar functions. This clock provides timekeeping from tenths of seconds to tens of years. This clock also may interrupt the processor periodically every 0.1 second, 0.5 second, 1 second, 5 seconds, 10 seconds, 30 seconds, or 60 SEC. ONS. The device used is a CMOS MM58274 programmable timer module. The MC68B40 provides 3 independent 16-bit timer counters. One of these is used as a watchdog and the other as a tick timer. The third timer is available for application-specific users. Battery backup system. A battery is provided along with the necessary circuitry to back up the CMOS RAM and the real-time clock whenever power is turned off. The battery is capable of 750 mAh, with an estimated data retention time of approximately 5 years. Interrupt handler. The NVMe 117 interrupt handler manages interrupts from the serial ports, timer, SCSI, parallel ports, a board switch, real-time clock, sysfail, acfail, and the 7 interrupts from the VMware bus. Interrupt vectors for the low-cal interrupts may be assigned in the vector prom. The serial ports have software programmable vectors. VMware bus system controller. The NVMe 117 may work as a VMware bus system controller for other VMware bus masters if it is physically located in slot 1 of a VMware bus chassis and if the VMware bus system controller function is enabled with a jumper. VMware bus requester. The NVMe 117 VMware bus requester operates in either the release on request, ROR, or the release when done, RWD, mode with early release of bus busy, BBSY. The mode is software selected through the module control register. In addition, the VMware bus requester can operate on any of the 4, 0 to 3, VMware bus levels. Motorola microcomputer systems and components. 2 to 54. NVMe 117-3, NVMe 117-3 FP, NVMe 117-4. I. Mechanical and environmental specifications. Characteristics specifications. Configuration DTB master, A24, D16. Requester, any one of R, O, R1, R2, R3, static, ROR or RWD. Arbiter, R3, only. Interrupt handler, any of IH, O. 7. Form factor double high Eurocard. Physical dimensions. Card size. Height 9.2 inches. 23.37 m. Width 6.3 inches. 16.00 m. Front panel. Height 10.2 inches. 26.10 m. Width 0.83 inches. 2.10 m. Power requirements plus 5 VDC 3.9A. Plus 12 VDC 50 RNA. Minus 12 VDC 50 RNA. Operating temperature 0 degrees C to 55 degrees Celsius. Inlet air temperature, forced air cooling required. Storage temperature, 40 degrees Celsius to 85 degrees Celsius. Humidity 5% to 90% relative humidity, non-condensing. Ordering information. Part description. NVMe 117-3 VMware single board computer with 10 MHz MC68010 MPU, 512 KB. 0 weight state DRAM, SCSI bus interface, battery back time of. Day clock, 4 EPROM sockets, MC68881 floating point processor. Socket, 2 serial ports, and 1 parallel port. Includes user's manual. NVMe 117-3 FP same as NVMe 117-3, but with MC68881 processor on board. NVMe 117-4 same as NVMe 117-3, but without SCSI. NVMe 117 bug NVMe 117 debug monitor with self-test, debug utilities, and SCSI bus. Support. Includes user's manual. NVMe 708-1. NVMe 708-1 interconnect transition module for the NVMe 117 family of microprocessor modules. Includes user's manual. NVMe 117/D NVMe 117 monoboard microcomputer user's manual. NVMe 117 bug/D NVMe 117 debug monitor user's manual. NVMe 708/D NVMe 708 interconnect transition module user's manual. Related documentation. MCSysAM/D VME system architecture guide. MC68010/D microprocessor data manual. MC68881/D floating point peripheral data manual. Motorola microcomputer systems and components. 2-55. I. VMware module trademark. VMware bus. Microprocessor. Modules. MC68010 microprocessor running at 10 or 12.5 MHz. Hardware virtual memory support, with instruction. Continuation after a fault. 512 KB dual-ported dynamic RAM with byte parity. 4 KB of zero-weight state instruction cache, providing significant execution speed-up, optional. MC68451 Memory Management Unit, MMU. NVMe 121. 2 28-pin sockets for user-supplied ROM/EPROM. Devices. A24, D16 VMware bus interface. Status/control registers. Interrupt handler. Any one of the 7 interrupt request levels. 4 onboard timers. System tick, watchdog, baud, and delay. RS-232C serial port, for debug terminal. Local reset switch. Status display LEDs, run, halt, fail. Optimized for multiprocessor applications. No common system controller functions on board. Removed to system controller. Large onboard RAM and private RIJM, can work at full speed in parallel with other processors without causing unnecessary loading of the bus. Dual port memory between the MC68010 MPU and the VMware bus allows efficient communication between cooperating processors without the time Consuming delays required to copy from global memory to onboard memory. Note, a module with system controller functions, AR. Bitration, such as the NVMe 050 or the NVMe 025, is required for operation. The NVMe 121 family of VMware microprocessor modules are versatile, VMbus-compatible microprocessor modules that offer the performance required for high-speed data processing, data management, and industrial control. Applications range from high-speed single-processor systems through systems with complex multi-processor architectures. NVMe 121. NVMe 123. The two versions of the microprocessor module are the NVMe 121 and NVMe 123. The following options are available: 10 MHz or 12.5 MHz MC68010 microprocessor, MC68451 Memory Management Unit, MMU. Table 1 lists the specific features of each module. The NVMe 121 derives its processing power from the superior resources of the MC68010 16-bit virtual memory microprocessor, which supplies hardware support for virtual memory environments. The combination of the MC68010, the MC68451 Memory Management Unit, and a 4 KB no-wait state instruction cache create a NVMe 121. Design highly suited for multiprocessor systems. As a result, such mainframe computer features as virtual machine, virtual I/O, and virtual memory, a key requirement for the Unix operating system, are able to be implemented on an internationally standard microprocessor bus. Figure 1 is a functional block diagram of the NVMe 121. Table 1. NVMe 121 Family Options. NVMe 121, NVMe 123. MC68010 MPU 10 MHz 12.5 MHz. MC68451 MMU Yes No. Dynamic RAM 512 KB 512 KB. Cache memory Yes Yes. Motorola Microcomputer Systems and Components. 2-56. NVMe 121, NVMe 123. RS-232C Terminal Port. MC68901 Multi-Function Peripheral Controller. Async RS-232C Port. Status Register. 4 timers. Test and control switches. Reset abort. PL. VMware. Interrupt handler. Figure 1. NVMe 121 Functional Block Diagram. MC68010 MPU. At 10 MHz, the MC68010 executes 25% faster than the 8 MHz MC68000 and has all of its popular features: 32-bit data, address, and stack registers, 14 addressing modes, 16 MB direct addressing range, 57 instruction types, operation on 5 data types, including bit, byte, word, long word, and BCD. Interlock instruction for multiprocessor system operation. 256 multi-level vectored interrupts. Proven architecture, optimized for efficient support of high-level languages and secure operating systems. In addition, the MC68010 provides hardware support for the implementation of virtual memory through instruction continuation on a page fault. Also included is a program control instruction that speeds loop mode Execution by suppressing operation code prefetches until an exit condition is met. MC68451 Memory Management Unit, MMU. The MC68451 MMU maps the MPU 16 MB logical memory space into the system physical memory, and provides for the isolation and protection of the supervisor and user segments of memory. The MC68010 MPU and MC68451 MMU are designed to work together to simplify implementation of main frame-style virtual memory, a requirement for the Unix multi-user operating system. MC68901 Multifunction Peripheral, MFP. Several NVMe 121 functions are implemented in the MC68901 peripheral chip. 4 timers, system tick function, interrupt at programmable intervals for multiprocessing task, switching, etc., watchdog, baud, delay. Asynchronous RS-232C functions for debug port. Status register. Cache. Zero wait state instruction fetch is a mainframe hardware feature on a VME format processor. The cache is a small, very fast memory situated between the MPU and its regular memory. As each instruction is fetched from anywhere in regular memory, with attendant delays for memory and / or bus access, it is stored in the cache on its way to the MPU. If this same instruction is then needed again, as when executing tight loops for example, the next fetch will be able to get the Motorola microcomputer systems and components. 2 to 57 E. NVMe 121, NVMe 123. Instruction from cache, called a cache hit, with minimal delay, zero wait state access. The cache memory is single set associative with a block size of 2 bytes and a total capacity of 4096 bytes. The cache is used for instruction and program counter relative data storage, and holds up to 2048 instructions. Performance improvement calculations give the following: executing a fast floating point multiply, where the instruction to data mix on memory fetches is 7.75:1. There would be an 86% hit rate, 86% of the memory accesses would be from the cache, with execution AP approximately 40% faster than the same program without cache. Onboard memory. 2 28-pin sockets are available for private memory. For example, they may contain self-test or bootload. They may be configured for several standard EPROM/ROM devices from 4K x8 to 64K x8. The onboard memory includes 512 KB of 150 NS access. Shared dynamic RAMs that are accessible both as local memory and from the VMware bus. VMware bus access is used for fast DMA loading from disk or for communication with other VMware bus processors. Data is then accessible for program execution and data manipulation with no bus load or bus delay. Bus requester. The bus requester requests VMware bus mastership on any of 4 request levels, user configurable via jumpers, and fully supports the bus grant daisy chain. The bus requester operates in the release on request, ROR, mode, and requests bus mastership only if the MPU attempts a VMware bus transfer when the module does not already possess VMware bus mastership. Interrupt handler. The interrupt handler enables the MC68010 microprocessor to sense and respond to all onboard interrupts and all 7 VMware bus interrupts. The VMware bus interrupts are Independently routed through onboard headers to Pro. VIDIA means whereby the onboard MPU can selectively ignore individual VMware interrupts. Physical address map, as seen from the MC68010. 00000THRU0000007 reset vector for first 4 memory cycles, RAM thereafter. Vector may be from onboard ROM or VMware, jumper option. 000008 through 01 FFFF onboard RAM. Dual port. 020000 through FVMware. Foo through FOF onboard ROM/EPROM. F20000 through F2002 FMFP, MC68901. F40000 module control register. F60000 through F6003 FMMU registers. F80000 through F80006 cache control signals. FAO through FVMware. FOO through FFFFFVMware, global short I/O page. Address map of MVME 121/123, as seen from VMware. 000000 through 01 FFFF dual port RAM, with standard decoder. Memory timing, wait cycles, memory timing, wait cycles. MVME 121. Read-write. MVME 123. Read-write. Wait access, wait access, wait access, wait access. Cycles time, cycles time, cycles time, cycles time. Cache 0n/a/n/a cache 0n/a/n/a. Onboard RAM *2 150 ns to 150 ns onboard RAM *2 150 ns to 150 ns. Onboard EPROM/ROM *5 250 ns/n/a/n/a onboard EPROM/ROM *5 250 ns/n/a/n/a. VMware 370 ns, VMware 4150 ns 493 ns. 4170 ns 4113 ns 5230 ns 5173 ns. 5270 ns 5213 ns 6310 ns 6253 ns. 6370 ns 6313 ns 7390 ns 7333 ns. 7470 ns 7413 ns. Asterisk access times are device access times. VMware access times are from data strobe to OTAC star. Motorola microcomputer systems and components. 2 to 58. MVME 121, MVME 123. Mechanical and environmental specifications. Characteristics specifications. Configuration DTB master, A24, D16. DTB slave, A24 D16. I. No arbiter on board. Use MVME 050 or other system controller. Requester, anyone of R, OL. R, LL. R2, R3, static, rower. Interrupt handler, any of IH, 0, 7, static. Form factor double high Euro card. Card dimensions height 9.2 inches. 234 mm, X width 6.3 inches. 160 mm. Front panel dimensions height 10.2 inches. 261 mm, X width 0.83 inches. 21 mm. Power requirements at +5 VDC. MVME 121 4A tip, 4.45 A max. MVME 123 4.3 A tip, 4.65 A max. 17 mA tip, 20 mA max at +12 VDC. 12 mA tip, 14 mA max at -12 VDC. Environmental limits. Operating temperature 0 degrees C to 55 degrees Celsius. Inlet air temperature, forced air cooling required. Storage temperature, 40 degrees Celsius to 85 degrees Celsius. Humidity 5% to 90% relative humidity, non-condensing. Ordering information. Part number description. NVMe 121 VMware microprocessor module featuring 10 MHz MC68010 MPU, MC68451 MMU, 512 KB RAM, and 4 KB no wait state instruction cache. Includes user's manual. NVMe 123 VMware microprocessor module featuring 12.5 MHz MC68010 MPU, 512 KB RAM, and 4 KB no wait state instruction cache. Includes user's manual. NVMe 120 LD NVMe 121, NVMe 123 microprocessor module user's manual. NVMe 120 Bug Debug Monitor firmware for the NVMe 121 family of microprocessor modules. Includes users manual. NVMe 120 Bug/D NVMe 120 Debug Monitor Users Manual. Compatible System Controller VMware modules. The NVMe 121 processing module requires another module with bus arbitration capabilities to act as system controller. VMware modules compatible with the NVMe 121 include: part number description. NVMe 025 VMware System Controller Module. NVMe 050 VMware System Controller Module. Related documentation. Part number description. MISASAM/DVMe System Architecture Guide. MC68010 LD Microprocessor Data Manual. MC68451/D Memory Management Unit Data Manual. MC68901 LD Multifunction Peripheral Data Manual. Motorola Microcomputer Systems and Components. 2-59. I. VMware Module. 32-bit mono board. Microcomputer. The VMware Module 32-bit mono board microcomputer. NVMe 130, is designed to function in those applications requiring maximum performance while maintaining the versatility inherent in VMware module systems. Highest performance is attained when the NVMe 130 is used in conjunction with one or more NVMe 204 dual-ported RAM cards operating as a main memory. The NVMe 130 is the first VMware module product to offer the following: MC68020 microprocessor with 32-bit address and data. VMware interface. Provision for MC68881 floating point coprocessor, CUS. Timer supplied option. Provision for demand paged virtual memory management. Board, MMB, implemented with gate array technology. 2 28-pin JEDEC sockets for up to 16 KB onboard static. RAM. VSB** interface provides high-speed data path to /from memory. VMware interface allows user configuration of microcomputer system to fit the application. VMware interrupter, interrupt handler, and arbiter on board. Programmable timer module. Dual multi-protocol serial I/O ports. Accepts NVMe 130 Bug Debug Monitor firmware, option. Ally available. 2 ROM sockets configured for industry standard 28-pin HOM/EPROM devices. 4 ROM sockets available. When no sockets are devoted to RAM. Broadcast interrupt capability for multiprocessor synchronizing applications. CPU. NVMe 130. NVMe 131. The NVMe 130 uses an MC68020 microprocessor operating at a fixed speed of 12.5 MHz. This CPU will eventually operate at 16.67 MHz on the NVMe 130. The MC68020 is the first product within the popular MC68000 family to offer external 32-bit address and data paths. With its higher clock rate, advanced architecture, enhanced addressing modes, and on-chip instruction cache, this product offers state-of-the-art performance while maintaining software compatibility with its widely accepted predecessors. Debug Monitor Firmware. The NVMe 130 Bug Debug Monitor firmware package is optionally available for use with the NVMe 130 module. This firmware offers 32 debug, up/downline load, 1-line assembler/disassembler and disk bootstrap load commands. Coprocessor. The NVMe 130 module is equipped with a socket to accept the MC68881 floating point coprocessor, a customer supplied option. When available and installed, the MC68881 floating point coprocessor will improve computing speed of the NVMe 130 when the system is utilized in applications requiring arithmetic operations. The NVMe 130 utilizes the MC68020 coprocessor interface to provide a logical extension to the MC68020 architecture and instruction set. Figure 1 is a block diagram of the NVMe 130 module. Motorola Microcomputer Systems and Components. 2-60. I/S. O. D. D. O. S. N. D. O. O. S. 0. C. I. M. D. CJ. and T. S. CJ. Z. O. O. S. 0 O. Z. M. Z. Figure 1, NVMe 130 32-bit microcomputer module. 50-pin ribbon cable. Connector. TTL to external. RS-232C transition. Module. MK68564. 2 multi-protocol. Serial ports. Status N. Control. Registers. VSB. Interface. 3. Z8036A. 16-bit. Timers. P2. 16 KB. Static. RAM. MC6881. FPCP. Socket. 228-pin. Sockets for ROM/EPROM. 16 KB, 128 KB. Data. Onboard. N. Logical address. MC68851. PMMU. Physical address. 4-level. VMware. Arbiter. S. O. S. L. I. NVMe 130, NVMe 131. Memory management. The NVMe 130 is designed to eventually utilize the MC68851 demand-paged virtual memory management unit. However, one initial version of the NVMe 130, NVMe 131, utilizes a memory management board, MMB, which conforms to a subset of the MC68851. This subset is implemented via gate array technology together with other semiconductor devices mounted on a secondary PC board. The socket assigned for future use with the MC68851 is utilized To mount the secondary PC board in a mezzanine fashion. On the introductory version of the NVMe 130. The MMB offers the following features. Logical address consisting of 32-bit address, 3-bit function code, physical address output of 32 bits, logical to physical address translation, table walking algorithm, single logical bus master, single page size, 1 KB, used, modified, and write protect bits. Supports MC68020 and external data cache. 512 entry set associative cache. The eventual use of the MC68851 will add multiple protection/privilege capabilities. The principal operating function of the MMB on the NVMe 130 is to provide the hardware logical to physical address translation and access protection necessary for operating system support. The MMB logical to physical translation mapping function utilizes a table walking algorithmic search through memory resident translation tables. The MMB utilizes a cache architecture to eliminate table walking for most CPU bus cycles. The MMB utilizes the MC68020 clock circuitry, but does not use the coprocessor interface. This requires the internal registers to be in the CPU address space, whereas the MC68851 internal registers will be accessed via the coprocessor interface. This will require a change in driver routines. When the MC68851 is used with the NVMe 130 onboard static RAM. The NVMe 130 static memory is implemented with two 28-pin industry standard JEDEC sockets. The NVMe 130 will provide 16 KB of single-ported memory for the MC68020 local processor. However, if the user does not require the onboard memory, the two static RAM sockets can be reconfigured to accept EPROMs up to 512K in size. vSphere interface. The vSphere interface occupies 64 P2 I/O pins and is designed to serve as the system's high-speed memory access channel. The signals utilize multiplexing of address and data in order to accommodate full 32-bit functionality, along with appropriate control signals, into the 64-pin allotment. The vSphere interface on the NVMe 130 is limited to one MOS. The interface can be turned off via a control bit to force all accesses to go to the VMware bus, and speed up VMware bus accesses. The NVMe 130, with one or more NVMe 204s, creates a memory system with performance similar to that of a VMware module with onboard memory, but with virtually unlimited memory size constraints. Memory map. The address map, referred to Table 1, indicates the 32-bit address map for different devices addressed by the NVMe 130. The 24-bit address map is determined by eliminating the two most significant hex digits from the 32-bit addresses. A control bit on the control register allows the user to switch between 16 and 32-bit data paths, and between 32-/24-bit address modifier codes. Table 1, Address Map. Device Physical Address Comments. VMware bus low VSB OFF 32/16-bit port size, R/W. ROM FUO FFF8 FFFF 16-bit port size, read only. Local static RAM FFF 20000 FFF2 FFFF 16-bit port size, R/W. Spare FFF 40000 FFF6 FFFF 32-bit port size, R/W provided for cache expansion ability. Timer FFFBXX00 FFFBXX2 F8-bit port size, RIW. Status and control FFFBXX30 FFFBXX3 F32-bit port size, status is read-only, control is R/W. Serial I/O port FFFBXX40 FFFBXX5 F8-bit port size, most are R/W. Reserved FFFBXX60 FFFBXX6F unimplemented. Spare FFFBXX70 unimplemented, access will cause LBTO, source, cycle. Termination. VMware short IO FO FFFFFFF 16-bit, R/W, VMware short IO address modifier will be generated. Motorola Microcomputer Systems and Components. 2-62. NVMe 130, NVMe 131. Programmable Timer Module. The NVMe 130 Programmer Timer Module provides the following: 3 cascadable, independent 16-bit counters. Interrupt capability. Serial I/O. The NVMe 130 is equipped with 2 multi-protocol serial I/O ports with connection via a 50-pin flat ribbon cable connector at the top of the board. Signal levels at this connector correspond to TTL specifications. A transition board/cable/connector, NVMe 707, is made available to transform the TTL levels to RS-232C and provide a standard DB25 interface. The ports have the following features: programmable baud rates, full and half duplex compatibility, 5 to 8 bits per character plus parity, synchronous or asynchronous operation, including byte-oriented protocols, BYSync, bit-oriented protocols, SDLC. Data rate capability to 800 kilobits/second. Status/control registers. The NVMe 130 status and control registers provide local and system-wide status information to the onboard MPU. By reading the status and control register bits, the MPU can determine VMware information, interrupt status, the source of a particular burp, and which self-test to perform. The NVMe 130 status/control register bits control the module's hardware by providing configuration and control information to the VMware interrupter, the interrupt handler, the VMware arbiter and VSB. For example, the multiprocessor interrupt request, MPIRO, is an input from the VMware IR01 signal. MPIRO * enables the user to interrupt several NVMe 130 modules in a multiprocessor system with a single VMware interrupt. The control register bits are software alterable. The STA/control registers are privileged resources and in special cases can be made accessible by the user. The status register format is shown in Table 2 and the control registers are described in Table 3. Table 2, Status Register Format. 31 Front Panel Switch Selectable 24. I. Mode AMSL SC *IGPC IGPB IGPA GP9 GP8 I. 23 Front Panel Switch Selectable 16. I. GP7 GP6 GP5 IGP4 IGP3 I. GP2 GP1 GPO I. Provides VME 130 networking base address 1 and useful as general purpose status point 1. 15 Power up reset condition 108. Abort ISIS fail * IVBR * IVSPR * IMUBR ILBTOI. Bur source status register -.j. Denotes, unimplemented, always read as 1. Mode, AMSL. SC star. GPC GPO. Abort. Sysfail star. vBur star. vSphere star. Muber star. LBTO star. Motorola Microcomputer Systems and Components. 2-63. I. MVME 130, MVME 131. 31. VBV7 VBV6. Table 3, Control Register Format. Power Up Reset Condition, 1. VBV5 IVBV4 IVBV3 IVBV2. 24. VBV1 VSVO dash equals. Dash dash, VMebus IRQ vector, FILJ. Dash, dash, port A on the Z8036 timer dash +1. 31 Power Up Reset Condition, 124. Perk asterisk reserved I. Dash dash colon dash port B on the Z8036 timer. 31 Power Up Reset Condition, 124. IVBIMSK 7 IVBIMSK 6 IVBIMSK 5 IVBIMSK 4 IVBIMSK 3 IVBIMSK 2 VBIMSK 1 VBISMSK. R. Which VMebus IRQs this interrupt handler responds to dash. 23 Power Up Reset Condition, 016. I reserved I alien sysvn I reserved I IL2 I IL1 ILO reserved I. R dash, interrupt enables, dash 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 VME IRQ request level, status. 15. 07. PMEN. VBV7 VBVO. Perk star. VBIMSK 7-1. VBISMSK. Alien. Sysvn. IL2 ILO. 08. Power Up Reset Condition, 100. Vistes VXRR star. Iveston IUXERC I32/24 star. 32/16 asterisk fail. I. VXDLS. VXRR star. Veston. VCirc. 32/24 star. 32/16 star. Fail. Motorola Microcomputer Systems and Components. 2-64. MVME 130, MVME 131. VMebus Interface. The VMebus interface provides for VMebus arbitration, for buffering of data, address, and control signals, forward data. Manipulation to accommodate MC68020 and VMebus data. Handling differences and for interrupt handling. The VMebus arbiter arbitrates up to 4 levels of bus. Mastership on a priority basis, utilizes a PAL chip, and insert. Ports the release on request, ROR, option described in the VMebus specification, HB 212. Interrupt handler. The MVME 130 allows interrupts to the onboard CPU from up to 20 sources. The interrupt handler pre-processes interrupt sources into 3 groups of 7 interrupts corresponding to the 7 possible MC68020 interrupt levels. The groups are labeled Group 1, Group 2, and Group 3. The interrupt service priority is determined by the interrupt level and the group number. Interrupts with different interrupt levels are processed according to the standard interrupt processing discipline. Interrupts within an interrupt level are processed according to the group number. Group 1 is reserved for VMebus interrupts. The interrupt handler processes Group 2 and 3 interrupts differently from Group 1 interrupts. If the interrupt being acknowledged is a Group 2 or 3 interrupt, the interrupt handler fetches the appropriate exception vector number from PROM and sends it to the CPU via the local bus. if the interrupt being acknowledged is a group 1 interrupt, the exception vector number is fetched from the VM bus where it was placed by the interrupting device. The interrupt assignments are described in Table 4. VM bus low NTERRUPTER. The VM bus interrupter can generate any level of VM bus interrupt under software control. When the VM bus interrupt is acknowledged, the interrupter places the appropriate vector from a hardware register on the VM bus. Table 4, Interrupt Handler Priority Assignments. Priority within a particular IRQ level determines the service order. IRQ, highest, middle, lowest. Level Group 3 Group 2 Group 1. Abort ACK fail interrupt IRQ, asterisk, VM bus. ACK star. 6 TMRIRC asterisk sysferc asterisk IRQ 6 asterisk, VM bus. 5 COIRC asterisk VBIZIRC asterisk IRQ 5 asterisk, VM bus. 4 unassigned VCIRC asterisk IRQ 4 asterisk, VM bus. 3 unassigned IRQ 3 asterisk, VM bus. 2 unassigned IRQ 2 asterisk, VM bus. 1 n/a unassigned IRQL asterisk, VM bus. Within a group X, interrupt priority decreases from top to bottom in the table. Within a particular IRQ level, interrupt priority decreases from left to right. Group 3 interrupts Group 2 interrupts. Abort ACK star. TMRIRC asterisk sysferc star. COIRC asterisk VBIZIRC star. VCIRC star. Group 1 interrupts. IRQ 7-1 star. Motorola Microcomputer Systems and Components. 2-65. MVME 130, MVME 131. Mechanical and Environmental Specifications. I. Characteristics Specifications. Power Requirements. MVME 130 plus 5 VDC, 5A, tip, 6A, max. MVME 131 plus 5 VDC, 6A, tip, 7A, max. Plus 12 VDC, 250 mA, max. Minus 12 VDC, 250 mA, max. Clock signal 12.5 MHz clock frequency. Addressing. Total system size 4 GB, 32-bit addressing. ROM/EPROM/RAM 428-pin sockets for 16/32/64 KB devices using plus 5 VDC only. Operating temperature 0 degrees to 50 degrees Celsius. Storage temperature -40 degrees to 85 degrees Celsius. Relative humidity 5% to 95%, non-condensing. Physical dimensions. Height 6.3 in, 16.0 centimeters. Width 9.19 in, 23.34 centimeters. Thickness, MVME 130, 0.71 in, 1.8 centimeters. MVME 131, 1.51 in, 3.84 centimeters. Ordering information. Part number description. MVME 130 VM module 32-bit monoboard microcomputer with MC68020 CPU. In. CLUD's User's Manual. MVME 131 VM module 32-bit monoboard microcomputer with MC68020 CPU and hardware memory management. Includes User's Manual. MVME 130/DVM module 32-bit monoboard microcomputer User's Manual. Related product. Part number description. MVME 130 bug MVME 130 bug debugging package for VM module 32-bit monoboard microcomputer. Includes User's Manual. MVME 204 VM module 1024 KB dynamic RAM module with VSB. Includes User's Manual. NVMe 214 VM module static RAM/ROM module with VSB. Includes users. Manual. NVMe 707 NVMe 130 Rs232C distribution board with dual Rs232C serial I/O. Cable assembly. Includes user's manual. Motorola microcomputer systems and components. 2-66. Advance information. 130 bug debug / diagnostic monitor. 130 bug resident package. Debug and diagnostic monitor in EPROM for the MC68020 based NVMe 130 and NVMe 131 mono board microcomputers. Full speed execution of system and user programs in a NVMe 130/NVMe 131 mono board microcomputer. System. More than 20 debug and program development. Commands. 18 diagnostic and hardware debug commands. Provides access to all lid, control, and memory facil. IDs of a NVMe 130/NVMe 131 base system plus the full 4 GB direct address range of the VMware. Support for the MC68881 floating point coprocessor. FPC. Supports the NVMe 320 disk controller. Virtual terminal capability for up/download to/from any host via Motorola S records. One-line assembler/disassembler for convenient program monitoring/modification. 21 I/O data conversion and timing routines callable from user-written programs. Complete NVMe 130/NVMe 131 hardware diagnostics with loop continuous and loop on error modes. Self-test verifies system integrity on power up. 130 bug source module package. 130 bug source module supplied on VMe/10 micro computer system or EXORMAX development SYS. TEM diskette. Source modules allow modification of 130 bug as required. 130 bug debug/diagnostic monitor. The debug/diagnostic monitor, 130 bug, is supplied as 2 separate products for resident use. The object code is supplied in 232 KB EPROMs, which plug into sockets provided on the NVMe 130 and NVMe 131 monoboard microcomputers. For customization, the source code is supplied on VMe i10 microcomputer system compatible 5 to 114 diskettes or on EXORMAX development system compatible 8 diskettes. NVMe 130 bug. Any NVMe 130 or NVMe 131 system having a VMware backplane such as that provided by the chassis for one of Motorola's new open system microcomputer families, the 9-slot NVMe 943 VM module chassis and the 20-slot NVMe 944 VM module chassis can use 130 bug. The 130 bug firmware monitor is a versatile, effective tool. It offers many powerful commands for application program development and modification and for NVMe 130 or NVMe 131 system hardware diagnosis and debugging in a VMware or standalone environment. It permits, under complete operator control, full speed execution of system and application programs including code utilizing the MC68881 floating point coprocessor. Memory space required by 130 bug includes 8 KB of RAM storage for exception vectors and stack/workspace, and 8 KB for user space. The monitor normally reserves the 16 KB of static RAM on board NVMe 130 and NVMe 131 but can optionally search system memory space for offboard RAM. To operate the 130-bug/mono board combination in the standalone mode requires that the onboard memory be used, with a user-supplied module translating the TTL levels of the two NVMe 130 or NVMe 131 serial ports to RS-232C to create standard D8-25 interfaces. One such board is the Motorola NVMe 707 RS-232 serial port distribution module, a standard RS-232C, asynchronous ASCII terminal can be connected to one serial port so that the 130-bug/mono board system can be operated in a standalone mode. This mode allows full use of the 130-bug program development and hardware diagnostic capabilities and is also commonly used for the final debugging of the application system. Figure 1 depicts operating in the standalone mode. Figure 1. Standalone operation. The translation board also allows a direct or dial-up RS-232C link from a host computer to be interfaced to the second serial port so that programs in Motorola's record format may be up/downloaded. For this purpose, 130-bug provides commands used to place the mono board in the transparent mode and to configure the Motorola microcomputer systems and components. 2-67 NVMe 130-bug ports for the desired communication protocol. For example, both host and target must be set to the same baud rate. Viewed from the host, while in the transparent mode, the monoboard appears to be an asynchronous ASCII terminal, virtual terminal. Figures 2 and 3 show operation in the transparent mode for communication with the host computer. Support provided within 130-bug for the NVMe 320 disk controller includes a command which can be used to load into a system any versatile bootable operating system. Figure 2. Transparent mode, direct serial connection with host computer. Debug/diagnostic facilities. The 130-bug monitor is a command-driven program which has facilities for accepting a command entered at the system console and for operating in the debug or in the diagnostic mode. To indicate the current operating mode, 130-bug displays an individual prompt, 130-bug or 130 diagram. Debugging activities are supported by a large set of versatile commands, many of which can be used for diagnosis or self-test of the NVMe 130 and NVMe 131 mono boards. On power up and reset, 130-bug follows certain default condition procedures according to the value of a switch settable flag on the mono board. These include the allocation of onboard or of system memory. Program debugging. Debugging support includes commands for examining and modifying registers and memory, commands which allow blocks of memory to be filled, moved, or searched for the occurrence of specified data, breakpoint commands which allow program segments to be run, trace commands for examining the execution of instructions or small program portions, commands for beginning execution at a specified address, commands which facilitate host/target communication, printer attach/detach commands and utility commands which provide the capabilities of switching to the other operating mode, formatting the monoboard serial ports, displaying or modifying the offset registers, converting the number base of data and displaying the name and a brief description of the entire command set. Table 1 lists all debugging commands. Several commands are included for performing disk I/O using the NVMe 320 disk controller module. The parameters of several commonly used disk configurations are already known to the monitor, and a command, I/O teach, is included, which allows a user to teach the monitor the specifics of another configuration. Particular sectors can be read from or written to using the I/O physics equal to disk command. Another command, boot operating system and halt, is useful for debugging bootable code. In a typical debug session after loading the program under development, appropriate commands from the debug set are invoked so that operation of a particular program portion can be checked and, if necessary, the code modified. Often, using the powerful register display/modify, memory display/modify, and block memory move commands, trial conditions for a program portion are established and the code executed. Results can be determined by examining the processor registers or memory values. A user may also examine the registers of the MC68881 FPC and display or change the contents of memory in any one of the various floating point formats. An alternative method is to set a breakpoint in place of an appropriate instruction to halt execution and obtain automatic display of processor register values. A more detailed examination of program validity is offered by the trace commands, which allow execution of one instruction at a time, with accompanying processor register display following each execution. If required, program code is easily modified with the aid of the one-line assembly/disassembly function provided by the memory modify command. The data conversion command, which converts values from decimal to hexadecimal or hexadecimal to decimal, is also a useful modification tool. Debugging of modular code is done using the commands for displaying and modifying the offset registers, which 130bug provides to make this task easier. When the program is fully debugged, it is saved to disk, or the dump srecords command is used to format and upload the code to the host for storage. Yen. Host computer. Modem. Figure 3. Transparent mode, dial-up. Serial link with host computer. Motorola microcomputer systems and components. 2-68. NVMe 130 bug. Memory commands. Memory display. Memory modify/disassembly/assembly. Memory set. Register command star. Register display. Register modify. Block of memory commands. Block of memory fill. Block of memory move. Block of memory search. Disk support commands. Boot operating system. Boot operating system and halt. I/O physical to disk. I/O teach. Host communication commands. Dump srecords. Load srecords. Transparent mode. Verify srecords. Go commands. Go direct, ignore breakpoints. Go execute user program. Go to next instruction. Go to temporary breakpoint. Trace commands. Trace. Trace on change of control flow. Trace to temporary breakpoint. Breakpoint commands. Breakpoint insert. Breakpoint delete. Printer commands. Printer attach. Printer detach. Miscellaneous utility commands. Data conversion. Help. Offset registers display/modify. Port format. Switch directories. Hardware diagnostics. Table 1. 130 bug debugging commands. Syntax: MDS, IBIWILIDJ, MMNBIWILILEDI, MS hexadecimal number string. Syntax: RD, RM. Syntax: BF, BIWIL, BM, BIWIL, BSI, BIWIL/N, BO, BH, LOP, LOT. Syntax: do N, BIWILJ, low C/X equals TM, VE, CLX equals J, go J, go, GN, GT, T, TC, TT, BR, NOBR, PA, NOPA, DC, he, of RN, A, PFN. So. Syntax: Syntax, Test and diagnostic capabilities offered by 130 bug are provided by commands which include: when the 130 bug diagnostic mode is entered, the mon-iter displays the prompt 130 diagram indicating that any of the commands in the diagnostic directory may be used. The 130 bug diagnostic commands are listed in Table 2. Set up utilities for selecting an operating mode such as stop on error. Tests of MVME 1301131 hardware including tests of the onboard memory, MC68020 cache, counter timer. Serial 110, VMware NSB, tests of the memory man. Agement board and final assembly tests. Commands for hardware debugging which provide a self-test sequence and continuous write and read loops. Callable 130 bug routines. A trap number 15 handler is included in 130 bug which allows calls from user-written programs to input, output and other useful routines within 130 bug. Such a system call is made by including in the source program a trap number 15 instruction line followed by a dc.w instruction line containing the code of the desired function. The callable 130 bug functions and their codes are listed in Table 3. Motorola Microcomputer Systems and Components 2-69 E. MVME 130 bug. Table 2. 130 bug diagnostic commands. 2. Command type mnemonic description. Command type mnemonic description. LE loop on error mode FAT final assembly tests. SE stop on error mode MT memory tests. Diagnostic LC loop continuous mode. Setup NV non-verbose mode. Utilities DP display pass count. ZP clear pass count. CA20 MC68020 on chip cache. Tests hardware CIO counter timer tests. Diagnostics SIO serial IO tests. To display errors bus VMware and VSB. ZE clear error counters tests. Hardware ST run self-test sequence. Debugging WL continuous write loop. MMB memory management. Board tests. Tools RL continuous read loop. Table 3. Callable 130 bug functions. Code function description. $0000. Input character from default input port. $0001. Instat input serial port status of default input port. $0002. INLN input line from default input port, format 1. $0003.readStr input string from default input port, format 2. $0004.readLine input line from default input port, format 2. $0020.outr output character to default output port. $0021.outstr output string to default output port, format 1. $0022.outline output line to default output port, format 1. $0023.write output string to default output port, format 2. $0024.writeln output line to default output port, format 2. $0025.writedln output line with data to default output port, format 2. $0026.pcrlf output carriage return and line feed to default port. $0027.erase erase line being input from default input port. $0040.tmeni initialize MVME 130's onboard timer. $0041.tmstro start timer at t equals 0. $0042.tmrd read timer. $0060.reader redirect IO of a trap15 function to use other than the default input or output port. $0061.reader I change the default input port number. $0062.reader 0 change the default output port number. $0063.return return to 130 bug. $0064.bindec convert binary to decimal. Format 1, pointer/pointer format. Format 2, pointer/count format. Ordering information. Part number description. MVME 130 bug. 130 bug, the debug/diagnostic monitor for the MVME 130 and MVME 131 monoboard microcomputers. Includes EPROM set and User's Manual. M68v2 FSBG 130 bug source modules on EX-ORMAX 8 diskettes. Includes User's Manual. M68v2 XSBG 130 bug source modules on VME/105-1/4 diskettes. Includes User's Manual. MVME 707 TTL2 Rs232C level translator module and dual Rs232C. Serial I/O cable assembly. Includes User's Manual. MVME 130 bug/D130 bug debug/diagnostic monitor User's Manual. Motorola microcomputer systems and components. 2-70. VMware module trademark. 32-bit microcomputer. With cache accelerator. MC68020 microprocessor with 32-bit address and data bus. MC68881 floating point coprocessor. Demand paged virtual memory management capability, MVME 131 XT only. VSB** interface for high-speed data path to and from memory. 16 KB cache memory for concurrent data storage with accelerated data access, and zero wait state. Operation. Onboard interrupt, interrupt handler and arbiter. Programmable timer. Dual multi-protocol serial 1/0 ports. The MVME 130 XT is a two-board VME-based micro computer assembly utilizing state-of-the-art components to achieve the highest level of performance currently available. It consists of an MVME 130 monoboard micro computer module, factory coupled to an mixed COC cache accelerator module, a combination which provides up to 100% improvement in system speed 1 paired with the MVME 130 monoboard microcomputer alone. The two-board system plugs into a standard VMware bus backplane and is fully compatible with the wide selection of VME peripheral modules Utilizing the MC68020 microprocessor, the NVMe 130XT has onboard provisions for plugging in an MC68881 floating point coprocessor and an MC68851 paged memory management unit when the latter becomes available. In the meantime, a second version of the system, the NVMX131XT, employs an optional auxiliary memory management board which conforms to a subset of the MC68851 and plugs into an onboard socket of the assembly to provide interim memory management functions. NVMe 130XT, NVMe 131XT. General description. The NVMe 130XT microcomputer assembly combines the processing power of the 32-bit MC68020 microprocessor with the speed enhancement properties of a 16 KB cache memory accelerator. The cache accelerator, a small, fast memory system, compensates for the typical speed mismatch between a very fast CPU and its relatively slow associated dynamic RAM main memory system. It does so by concurrently storing the data most recently stored in main memory locations. This data can subsequently be obtained by fast accesses of cached locations rather than by much slower accesses of main memory. To accommodate for the fact that the cache memory normally has much less capacity than the main memory system, little used accesses stored in the cache MEM ORI are routinely replaced with more active ones, based on the bus traffic between the NVMe 130 microprocessor SOR module and the VMware and VSB memory interfaces. This assures maximum utilization of the cache. Motorola microcomputer systems and components. 2-71 NVMe 130XT, NVMe 131XT. 50-pin ribbon cable. Connector. TTL to external. RS232C transition. MODUE. 16 KB. Static. RAM. MC68881. Floating point coprocessor. Socket. 228-pin. Sockets for ROM/EPROM. 16 KB 128 KB. 3. Z8036A. 16-bit. Timers. VMware interface. VSB. Interface. Address. Data IJLIONBOARDNMBus. 4i interrupt handler. 4-level. VMware. Arbiter. Control. Interrupter. Requester, rower. P2. Figure 1. NVMe 131 functional block diagram. The microcomputer board, NVMe 130/NVMe 131. Microprocessors. A block diagram of the NVMe 131 microcomputer board is shown in Figure 1. The heart of the system is the MC68020 microprocessor operating at a fixed frequency of 16.67 MHz. This latest member of the Motorola M68000 family offers full 32-bit operation with 32-bit external address and data paths. With its high clock rate, enhanced addressing modes, and on-chip instruction cache, this advanced MPU provides leading-edge performance while maintaining software compatibility with its widely accepted predecessors. On the NVMe 130XT module, the MC68020 microprocessor is supported by an onboard socket that is pre-wired to accept the MC68881 floating point coprocessor. This optional accessory chip greatly improves computing speed of the system and is recommended for applications involving a high level of arithmetic operations. Optional memory expansion. In support of the microprocessor, the microcomputer board has two pre-wired 28-pin sockets for up to 16 KB of static RAM. If the intended application does not require onboard RAM, however, these JEDEC sockets can be configured to accept EPROMs up to 512K in size. With one or more NVMe 204-1 or -2 DRAM with VSB modules which provide 1 MB and 2 MB, respectively, the NVMe 130 can avail itself of virtually unlimited memory capacity while maintaining a performance level similar to that of a monoboard VMware module microcomputer with onboard memory. Also available for high performance memory expansion is the NVMe 214 static RAM/ROM with VSB. This module has provisions for battery backup and has 16 sockets which accept many standard JEDEC 24-pin and 28-pin RAM, ROM, and EPROM devices. It can provide up to 1 MB of storage capacity. Memory modules for expanding VME system memory include the NVMe 202, NVMe 222-1, and NVMe 222-2. DRAM modules which have a 8/16-bit data bus width and offer 512K, 1 MB, and 2 MB of capacity, respectively. The NVMe 225 DRAM, a full 32-bit module offering 2 MB of capacity, the NVMe 215-1, -2, and -3 CMOS RAM mod. Ules with onboard power monitor and battery for power down backup and which offer 256 KB, 512 KB, and 1 MB of capacity, respectively, and the NVMe 211 static RAM/ROM module with 16 sockets for JEDEC 24-pin and 28-pin devices and which can provide up to 1 MB of storage capacity. Motorola microcomputer systems and components. 2-72. NVMe 130 XT, NVMe 131 XT. Memory Management Unit. The NVMe 130 XT anticipates the eventual utilization of the MC68851 demand-paged virtual memory management unit with an onboard socket pre-wired for this device. In the interim, until the MC68851 MMU becomes available, Motorola furnishes the NVMe 131 XT system, which includes a daughter board plugged in the socket that is allocated for the MMU chip. This auxiliary board contains circuitry that conforms to a subset of the MC68851, and provides the hardware logical to physical address translation and access protection necessary for operating system support. VMware interface. The VMware interface permits VMware arbitration, buffering of data, address and control signals, word data manipulation, interrupt handling. The VMware arbiter arbitrates up to 4 levels of bus mastership on a priority basis, and incorporates the release on request option described in the VMware specification. NVMX32 bus interface. This interface occupies 64 I/O pins which provide access to the system's high-speed memory channel. The signals utilize multiplexing of address and data to accommodate full 32-bit functionality, along with appropriate control signals, within the 64-pin allotment. On the NVMe 130 module, this interface is limited to serving one master. It can be turned off via a control bit to force all Accesses to go to the VM bus, and speed up VM bus. Accesses. Programmable timer. The onboard programmable timer provides 3 dependent cascadable 16-bit counters with interrupt capability. Serial I/O. The module is equipped with 2 multi-protocol serial I/O ports accessible via a 50-pin flat ribbon cable connector at the top of the board. Signal levels at this connector correspond to TTL specifications, but can be transformed to RS-232C levels by means of a SEPA readily available distribution board and cable assembly. NVMe 707. The ports have full and half duplex compatibility with programmable baud rates. They are suitable for synchronous or asynchronous operation, with 5 to 8 bits per character, plus parity. Figure 2. Exploded view showing NVMe 131xt. Assembly details. Memory map. Table 1 indicates the 32-bit memory address map for various devices addressed by the NVMe 130 module. A 24-bit address map is determined by eliminating the 2 most significant hex digits from the 32-bit addresses. A control bit on the control register permits a switch between 16 and 32-bit data paths, and between 32-24-bit modifier codes. Table 1. Address map. Device physical address comments. VMware NSB OFF 32/16-bit port size, RIW. ROM FUO FFF8 FFFF 16-bit port size, read only. Local static RAM FFF 20000 FFF2 FFFF 16-bit port size, RIW. Spare FFF 40000 FFF6 FFFF 32-bit port size, RIW provided for cache expansion ability. Timer FFFBXX00 FFFBXX2 F8-bit port size, RIW. Status and control FFFBXX30 FFFBXX3 F32-bit port size, status is read-only, control is RIW. Serial 1/0 port FFFBXX40 FFFBXX5 F8-bit port size, most are RIW. Reserved FFFBXX60 FFFBXX6 F unimplemented. Spare FFFBXX70 F unimplemented, access will cause LBTO, source, cycle. Termination. VMware short 1/0 FUO FFFFFFF 16-bit, RIW, VMware short IO address modifier will be generated. Motorola Microcomputer Systems and Components. 2-73. 2. I. NVMe 130xt, NVMe 131xt. Interrupt handler. The NVMe 130 allows interrupts to the onboard CPU from up to 20 sources. The interrupt handler pre-processes interrupt sources into 3 groups of 7 interrupts corresponding to the 7 possible MC68020 interrupt levels. The groups are labeled Group 1, Group 2, and Group 3. The interrupt service priority is determined by the interrupt level and the group number. Interrupts with different interrupt levels are processed AC according to the standard interrupt processing discipline. Interrupts within an interrupt level are processed according to the group number. Group 1 is reserved for VMware interrupts. The interrupt handler processes Group 2 and 3 interrupts differently from Group 1 interrupts. If the interrupt being AC acknowledged is a Group 2 or 3 interrupt, the interrupt handler fetches the appropriate exception vector number from PROM and sends it to the CPU via the local bus. If the interrupt being acknowledged is a Group 1 interrupt, the exception vector number is fetched from the VMware, where it was placed by the interrupting device. The interrupt assignments are described in Table 2. VMware interrupter. The VMware interrupter can generate any level of VME bus interrupt under software control. When the VMware interrupt is acknowledged, the interrupter places the appropriate vector from a hardware register on the VMware status/control registers. The NVMe 130 status and control registers provide local and system-wide status information from which the onboard MPU can determine VMware information, interrupt status, the source of a particular Burp, and which self-test to perform. The NVMe 130 status/control register bits control the module's hardware by providing configuration and control information to the VMware interrupter, the interrupt handler, the VMware arbiter, and VSB. The control register bits are software alterable. The status/control registers are privileged resources and in special cases can be made accessible by the user. The status and control register formats are described in Tables 3 and 4, respectively. Table 2. Interrupt handler priority assignments. Priority within a particular IRQ level determines the service order. IRQ: highest, middle, lowest. Level Group 3, Group 2, Group 1, VMware. 7 Abort ACK fail interrupt. ACKFERC. 6 TMRIRC SysFERC. 5 COIRC VBIZIRC. 4 Unassigned vCIRC. 3 Unassigned Unassigned. 2 Unassigned Unassigned. 1 N/A Unassigned. Within a group X, interrupt priority decreases from top to bottom in the table. Within a particular IRQ level, interrupt priority decreases from left to right. Group 3 interrupts, Group 2 interrupts. IRQ 7. IRQ 6. IRQ 5. IRQ 4. IRQ 3. IRQ 2. IRQ 1. Abort ACKFERC. TMRIRC SysFERC. COIRC VBIZIRC. vCIRC. Group 1 interrupts. IRQ 7-1. Motorola Microcomputer Systems and Components. 2-74. NVMe 130 XT, NVMe 131 XT. 31. Mode. 23. GP7. AMSLSO. GP6 GP5. Table 3. Status register format. Front panel switch selectable. GPC GPB GPA GP9. Front panel switch selectable. GP4 GP3 GP2 GP1. 1. Provides VME 130 networking base address, --1. And useful as general purpose status, L. 15. Abort. Denotes, unimplemented, always read as 1. Mode, AMSL. SC. Power up reset condition, 1. Sysfail vBur vSphere Bur source status register. GP8. GPO. LBTO. GPC GPO. Abort. Sysfail. vBur. vSphere. Mubur. LBTO. 31. Table 4. Control register format. Power up reset condition, 1. 24. 16. 08. 24. VBV7 1 VBV6 VBV5 VBV4 VBV3 1 VBV2 VBV1 1 VBV01. 1. Dash, VMware IRQ vector, dash, dash 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 1. Port A on the Z8036 timer dash 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 1. 31 power up reset condition, 124. 1. Port B on the Z8036 timer, I. 31 power up reset condition, 124. I vBIMSC 7 vBIMSC 6 vBIMSC 5 vBIMSC 4 vBIMSC 3 vBIMSC 2 vBIMSC 1 vBIMSC. I, which VMware IRQs this interrupt handler responds to, L. 23 power up reset condition, 0. 1 interrupt enables. 15. 07. PMEN. VBV7 VBVO. Perk. vBIMSC 7-1. vBIMSC. Alien. SysVN. IL2 ILO. Power up reset condition, 1. Power up reset condition, 1. VSTs VXRR VSTN. UXCIRC. VSTs. VXRR. VSTN. VCIRC. 32/24. 32/16. Fail. 32/24. 32/16. Fail. Motorola Microcomputer Systems and Components. 2-75. 16. 08. 00. I. MVME 130 XT, MVME 131 XT. VME ADR. V. Address. CPU ADR. Multiplexer. Cache RAM. V. J. Cell tag. I. 7. Paging timing CPU data. VMware. N. Loss. N. Hit/miss. Monitor. MMU control. V control. PA control. VM. Bus CPU US CPU on 1 roll. 7. VMware MVME 130 IPMU socket. Figure 3. Mixed cock functional block diagram. The Cache Accelerator Module. The Cache Accelerator Module, MVME XTCACL, NOR. Mali, an independent product of the Motorola VME module family, is plugged into the MMU socket of the MVME 130 microcomputer module and becomes an integral part of the assembly. Its function is to accelerate the performance of MC68020 based systems without modification of existing programs. The degree to which this objective is being achieved is indicated by the results of the 2 benchmark programs tabulated in Table 5. The first of these utilized EN benchmarks to which perform commonly used character and data manipulations. The second utilized user-supplied routines for forming data-intensive array operations. The tests run for 4 combinations of cache memory utilization, indicate the degree of improvement attributable to the use of the cache accelerator. Table 5. Performance test results. MC68020 and no MC68020 mixed cock. Test cache. EDNE. Char. String search, 285 141 131 99 ILS. EDNF. ISETI RESTI test bit, 60 36 33 30 ILS. EDNH. I-link list insertion, 121 194 70 70 ILS. EDNI. iQuicksort, 22,320 11,792 11,072 9001 ILS EDNK IBIT matrix Translation 243 173 159 136 ILS Customer Benchmark 125 104 73 68 seconds 2 EDN, September 16, 1981. The accelerator is a single set, direct mapped cache. Comprising 16 KB of high-speed static memory, organized as 4K, 32-bit data entries. Each entry replicates a 32-bit word located in memory across the VMware or VSB memory space, and is updated concurrently with a processor write access or initial read access. Any combination of bytes from an access can be cached at a time. And a data fill function implemented for VSB enables the caching of the entire 32-bit entry for byte and word read operations. The accelerator caches both program and data transactions throughout, and it can be configured by function code to cache any combination of supervisor program, supervisor data, user program, and user data mode accesses. An onboard monitor automatically cleanses the cache of stale data and enables the cache accelerator to operate in both single and multi-processor environments without software intervention. The cache accelerator module supports any speed MC68020 microprocessor, and is jumper selectable to support either the MC68851 memory management unit or M68KVMMB851 memory management board, or an MMU bypass board if the MMU function is not required. With an MMU installed, the page detection circuitry on the cache enables its RAMs to operate in parallel with the MMU address translation RAMs to maximize system performance. A cache page is defined by the physical address bits PA08 PA13, and if they remain the same on a following cycle, then the address access time of the cache RAMs is buried in the MMU address translation period. With a bypass board installed, the cache receives the address signals directly from the MC68020 microprocessor, and zero-wait state operation is obtainable. Zero-wait state operation is achieved at a processor frequency of Motorola microcomputer systems and components 2 to 76, NVMe 130XT, NVMe 131XT, 12.5 MHz 3, and it may be achieved at 16.67 MHz when faster static RAMs become available. The cache accelerator provides direct access to the cache RAMs for diagnostic and inquiry purposes, and provides a test mode of operation to establish general system confidence. Memory organization. The complete memory section of the cache accelerator is organized as 4K entries of 55 bits per entry, see Table 6. It consists of a tag section and a data section, where the tag section stores the physical addresses of the offboard memory locations, and the data section stores the data residing at those locations. The lower address bits, PA02 PA13, form an index that directly addresses the cache RAMs to select the particular entry to be used, and the remaining address bits, PA14 PA31, are stored and read from the tag RAMs as data. An address valid bit, AB, is generated internally for each entry to indicate that the address stored in the tag is valid information. It may not be valid either because the tag entry has not been written to since power up or since the cache was last cleared, or because the VMware monitor has set the entry invalid. The data RAMs contain the corresponding bytes that were cached from the bus, and the 4-byte valid bits, BVO BV3, are generated internally to qualify those bytes. BVO is associated with byte address O of the long word entry, and operates on the most significant byte of the data bus, D31 D24. The other byte valid bits operate in sequence. Basic cache operation. When the processor drives an address for a read operation, the index section PA02-13 addresses the tag and data RAMs to select one entry from the cache. The remaining address bits from the processor are then compared to the corresponding address bits read from the tag section of that entry. If they match, and the address valid bit is set, and if the byte valid bits for the bytes the processor is requesting also match, then the cycle hits, and the cache supplies the requested data to the processor and terminates the cycle. If any event does not match, then the cycle misses and a VME or VSB bus access is initiated. The cache entry is updated with the new address and data information, and the valid bits are set appropriately. Note that a write cycle will always cause a miss since the processor, and not the cache, is supplying the data. Several other factors determine the hit qualification and cacheability of a processor cycle. These include the control bits, the type of processor cycle, the MMU cache enable signal, and the onboard address decoder. VMware monitor. The VMware monitor is a separate machine on the cache accelerator that operates asynchronously with the processor to prevent stale data from remaining in the cache. It operates automatically so that the host user benefits from the performance advantages offered by the cache without even being aware that the cache accelerator has been installed in the system. Stale data could occur in the cache when other VMware masters modify data in main memory which was previously cached. To prevent this, the bus monitor has a two-level FIFO register stack which captures the addresses of write operations initiated by bus masters other than the host, and presents the addresses to the cache for processing. The cache services the monitor by comparing the captured address with the corresponding entry in its tag memory. If the tag is valid and compares, a monitor hit occurs and the cache invalidates the entry by resetting its address valid bit. If the processor then accesses that physical address, the cache will miss because of the reset address valid bit, and the cycle will be routed out to main memory for the new data to update the invalid entry. User interface. The user interface in Table 7 shows the devices on the cache accelerator used to control and diagnose its operation. These are cache control and mask registers, and two hard-decoded address spaces used to directly access the cache RAMs for diagnostic and inquiry purposes. The cache powers up in a cleared and disabled state, and can be enabled for software transparent operation by storing an F1 to the cache control register. In addition, the cache can be tested or configured for a specific user application through the various control bits shown. Since the entire user interface address space can safely be accessed with or without the cache accelerator installed, a cache utility can be implemented without prior knowledge of its presence in the system. Memory Management Board. The M68K VMMB851 Memory Management Board, Fig. UR4 is an interim solution for implementing demand paged virtual memory operations prior to the availability of the MC68851 single-chip paged memory management unit. It provides the required logical to physical address translation by performing chip-controlled searching of translation tables in main memory. The 4.5x 3.5 mezzanine board plugs into a socket of the 131XT board, which is reserved for the MC68851 chip. It contains an MC68461 memory management controller and an external address translation cache. The controller contains address translation circuitry and a state machine which, together, execute the table walking algorithm of the MC68851. The address translation cache, a 512-entry set associative cache, is a fast memory that translates logical addresses and function codes to COR, responding physical addresses and protection bits. It speeds address translation by avoiding the overhead of searching translation tables for each bus access. The functional differences between the MC68851 PMMU and the MMB are detailed in Table 8. The MMB requires an addition to the supervisor's bus error handler to allow the use of indivisible memory cycles, i.e. the TAS instruction. The MMB must use the bus error signal to inform the MC68020 microprocessor that the address of this indivisible cycle is not resident in the address translation cache. When the MC68020 takes the bus error sig NAL, the MMB is allowed to request the bus and to perform 3 with MMU bypass card installed and dependent on MC68020 clock to address strobe tiering. Motorola Microcomputer Systems and Components 2-77 I. MVME 130XT, MVME 131XT. The necessary address translation table walk. The MC68020 then proceeds to the bus error routine where software must perform an instruction retry to the indivisible cycle. Functionally, the MMB is compatible with the MC68851 PMMU to the extent that algorithms and programs developed for a system using the MMB can be moved to one using the MC68851 after a few minor changes. Table 6. Mixed COC, Memory Organization. Tag section OTA section. Dash physical address. Index I. A02, A13, A14, A31-T-. 4KX18. Address. AV star. 4KX1. ADR. VLD. OTA. 031-23-023-16-015-08007-00. 4KX32. OTA. BVO3 star. 4KX4. Byte. VLD. Table 7. Mixed COC, User Interface. Cache Control Register, Address FCO Mask Register, Address FFFC0001. 031, Reset State equals FF, 024 023, Reset State equals XF, 016. 1 Vipson Imonen 1 MLBK 1 MBLC 1 CCLR 1 CWEN 1 CREN 1 ETST -x comma dot x comma dash x dash dot dash x dash dot dash MSOT MSPT MUO dash 1 MUP. Data Access Space, Address FDU FFFD3 FFC. Data Entries, 000 FFF. Tag Access Space. Read Only. 031000. Addresses, FOFFFE3FFC. Tag entries, OOOFFF. By DOI. 031-024. Definitions. Vibson. Munnen. MLBK. MBLC. CCLR. CWEN. CREN. CTST. MSO. Byte 1I. 023-016. Byte 2I. 015-008. VMware cache enable. VMware monitor enable. Byte 3. 007-000. Monitor loopback, for diagnostic use. Monitor block, for diagnostic use. Cache clear. Cache write enable. Cache read enable. Cache test, for diagnostic use. Mask supervisor OTA. 031. MSP. MUO. MUP. AV. BVO. BV1. BV2. BV3. 014007. PA031 PA014. INAIAV1. Mask Supervisor Program. Mask User OTA. Mask User Program. Address Valid Status. 003-000. BVO BV3. Byte Valid Status for 031-024, byte address 0. Byte Valid State for 023-016, byte address 1. Byte Valid Status for 015-008, byte address 2. Byte Valid Status for 007-000, byte address 3. Motorola Microcomputer Systems and Components. 2-78. MVME 130XT, MVME 131XT. Enable E. FC2-0. LA31-10. MC68461. Memory flush. Tag. Management. Load comp controller. Hit 1-0. PA310. CI. PA310. CI. WP. MLA3.0, FC2-0. B. 031-00. Adapter. OS socket. So. LBGAC. S1. PDS. POW loss. DLAS. Figure 4. M68 KVMMB851 Memory Management Board. Table 8. Functional differences between chip and board. Feature MC68851 PMMU MC68 KVMMB851 boards. Address translation cache internal, fully associative external, set associative. Page size 256,512, 1K, 2K, 4K, 8K, 16K and 32 KB 1 KB. Logical address support from 17 to 32 bits 24 or 32-bit. Supports multiple logical bus masters yes no. Logical and physical bus arbitration yes, but not identical to the MC68851. Support. Access level support yes does not support supervisor root. Pointer, root pointer cache or DMA. Root pointer. Coprocessor interface support yes no, operations are performed by accessing memory mapped locations. Translation table configuration supports several expects one given table walking. Algorithm. Translate CPU space accesses yes no, acts as peripheral only. Pinout, compatible with MC68851. Motorola Microcomputer Systems and Components. 2-79. NVMe 130 XT, NVMe 131 XT. 2. Mechanical and environmental specifications. Characteristic specification. Cache implementation single set, direct mapped, physical. Memory organization 4K, 32-bit data entries. Replacement algorithm single entry, write through. Hit timing, no MMU, 60 nanoseconds. Loss to DSACKX with MMU, 70 nanoseconds, page hit. 130 nanoseconds, page miss. Power requirements. NVMe 130 XT plus 5 VDC, 9.3 ATIP, 12.4 A max. NVMe 131 XT plus 5 VDC, 10.3 ATIP, 13.4 A max. Plus 12 VDC, 250 RNA max. 12 VDC, 250 RNA max. Clock signal 16.67 MHz clock frequency. Addressing. Total system size 4 GB, 32-bit addressing. ROM/EPROM/RAM 4 28-pin sockets for 16/32/64 KB devices using plus 5 VDC only. Operating temperature 0 degrees to 50 degrees Celsius. Storage temperature -40 degrees to 85 degrees Celsius. Relative humidity 5% to 95%, non-condensing. Physical characteristics. Height 6.30 in, 16.00 centimeters. Width 9.19 in, 23.34 centimeters. Thickness, NVMe 130 XT, 1.438 in, 3.652 centimeters. NVMe 131 XT, 2.238 in, 5.684 centimeters. Component projections. Component side 0.50 in, 1.27 centimeters, max. Solder side 0.067 in, 0.17 centimeters, max. Except for interconnect header. Ordering information. Part number description. NVMe 130 XT VMware module 32-bit monoboard microcomputer with 16.67 MHz. MC68020 CPU and MC68881 floating point coprocessor. Mixed COC1 cache accelerator module and NVMe 130 bug. Debug/diagnostic monitor. Includes set of users manuals. NVMe 131 XT VMware module 32-bit monoboard microcomputer with 16.67 MHz. MC68020 CPU, MC68881 floating point coprocessor. Mixed COC2 cache accelerator module with memory man. Agement unit and NVMe 130 bug debug/diagnostic monitor. Includes set of users manuals. NVMe 130 XT/D users manual set for NVMe 130 XT. NVMe 131 XT/D users manual set for NVMe 131 XT. NVMe 130 bug/D 130 bug debug/diagnostic monitor users manual. Related documentation. Part number description. NVMe 204-1 VMware module 1024 KB dynamic RAM with byte parity and VSB. Includes user's manual. NVMe 204-2 VMware module 2048 KB dynamic RAM with byte parity and VSB. Includes user's manual. NVMe 214 VMware module static RAM/ROM with VSB and up to 1 MB RAM capac. ITY. Includes user's manual. NVMe 707 dual RS-232C serial I/O cable assembly. Includes user's manual. Motorola microcomputer systems and components. 2-80. NVMe 130 XT, NVMe 131 XT. The VME system. Y. NUJ. New. NVMe 131. CPU. Mixed cock. Cache. Accelerator. IVMebus. YN. GSL, / CE. US. CE. Dash, / LCE8::UO. NACE-0. NVMe 320A-. Weenie / floppy. Disk CTLA. NVMe 350. QIC02. Streaming. Tape CTLA. A typical high-speed NVMe 130/131 XT microcomputer VME system. The NVMe 131 XT 32-bit microcomputer with cache accelerator module conforms to the VMebus interconnect system, which has emerged as a world-wide standard for 8/6/32-bit microcomputers. It is part of the VME module product family whose M68000 based processing power, EuroCardMe, Chen-Eichel format, powerful Veridus real-time software support and international multiple sourcing have made it one of the most popular product lines in the industry. The VME system architecture, and a board-level component complement that relate to the cache accelerator, are illustrated in the above block diagram. Of particular significance are the well-established functional versatility of the VMebus, whose non-proprietary technical specification is widely used for system implementation, an auxiliary VSB for high-speed memory expansion, an MC68020 based 32-bit CPU board, NVMe 131, utilizing the latest advances in microprocessor design, a large repertoire of peripheral, controller, modules and memory boards. The unrivaled acceptance of VME system philosophy has yielded a selection of compatible board-level products from well over 100 vendors, to offer systems manufacturers the basic tools with which to implement their designs quickly, efficiently, reliably, and cost-effectively. Motorola Microcomputer Systems and Components. 2-81. VME module trademark. 32-bit mono board. Microcomputer. MC68020 microprocessor with 32-bit address and data at 12.5 MHz or 16.67 MHz. MC68881 floating point coprocessor at 12.5 MHz or 16.67 MHz. 1 MB of shared local DRAM accessible from the VME bus, 32 bits wide. 4 28-pin JEDEC sockets for ROM/PROM/EPROM, 2 bank/16 bits wide. 1 front panel serial debug port. 1 RS-232C multi-protocol serial port. 1 RS-485/RS-422 multi-protocol serial port. 3 8-bit timers. Real-time clock. A241D32 VMebus master interface. VMebus system controller functions with level 3 arbiter. Single level bus requester, level jumper selectable. Level 3 VMebus interrupter. 7-level interrupt handler. The NVMe 133 VME module 32-bit monoboard micro computer is designed to function in those applications requiring medium performance and functionality. With its 1 MB of onboard DRAM and MC68881 floating point processor, the NVMe 133 is an excellent choice for applications requiring real-time operation and arithmetic capability, such as industrial automation and robotics. CPU. The MVMe 133 and MVMe 133-1 use an MC68020 microprocessor operating at a fixed speed of 12.5 MHz and 16.67 MHz, respectively. The MC68020 is the first product within the popular MC68000 family to offer external 32-bit address and data paths. With its higher clock rate, advanced architecture, enhanced addressing modes and on-chip instruction cache, this product offers state-of-the-art performance while maintaining software compatibility with its widely accepted predecessors. Debug Monitor Firmware. The MVMe 133 Bug Debug Monitor firmware package is optionally available for use with the MVMe 133 module. This firmware offers 32 debug, up/downline load and disk Bootstrap load commands, as well as a full set of onboard diagnostics and a one-line assembler/disassembler with full IVLC 68881 support. MVMe 133. MVMe 133-1 Coprocessor. The MVMe 133 module is equipped with the MC68881 floating point coprocessor, which substantially improves computing speed in applications requiring arithmetic computations. The MC68881 is a full implementation of the IEEE standard, P754, for binary floating point arithmetic, providing the following operations: add, subtract, multiply, divide, remainder, square root, integer part and compare. Each of these operations supports 7 different data formats: byte, word, and long word integers, single, double, and extended precision real numbers, and packed binary coded decimal string real numbers. In addition, the MC68881 supports a full set of trigonometric and transcendental functions. Figure 1 is a block diagram of the MVMe 133 onboard dynamic RAM. The onboard dynamic RAM uses 32-256K x1 dynamic RAM zips, zigzag inline package, making a total of 1 MB of local DRAM. It is accessible by the MC68020, the refresh circuitry, and the VMware bus, each of which requests and is granted the DRAM by a multi-port arbiter. The user can select the address at which the onboard DRAM appears from the VMware bus by changing a jumper header or by reprogramming a PAL, programmable array logic. As shipped from the factory, the 4 address spaces which can be selected by the jumper header are $O off, 100,000 to $1 FFFFF, $2000000-$2 FFFFF, $3000000-$3 FFFFF. Onboard DRAM responds to the VMware bus only when address modifier lines AMO AM5 indicate standard, priv. Motorola microcomputer systems and components. 2-82. MVMe 133, MVMe 133-1. Serial. RS-232C port. Timers. Interrupt ROM sockets. Debug port, handler, and MC6BBBL serial ports. Status/control. Reset, real-time. Abort, Leo's clock. /ERF. RE. Data bus. VT_J L0. V/1.1/.//0 \R/1/0 I/I \. Address bus/VV. IF%7 Multi-port RAM control MPU, clocks, I-R Map decoder Arbiter, refresh, sequencer and stacks TJ VRAM array and local generator dual port N F% timeout F.T1 map decoder address mux TIVMEBUS 8 I plus VMEBUS master VMEBUS data VMEBUS interface system buffers requester address controller buffers interrupter IT -I serial 1 IM 1 I J 7 1 P2PL VMEBUS connector Figure 1 MVME 133 functional block diagram privileged or non-privileged data or program space, and when the MVME 133 on which it resides is not VMEBUS. Master code signal lines which are driven by the MC68020. Function code map decoder. At the beginning of each MPU cycle, the space decoder determines what kind of cycle is taking place and which device or function is selected within that cycle type. The cycle types, shown in Table 1, are determined by the func memory map. The memory map, referred to Table 2, indicates those devices that occupy user data, user program, supervisor data and supervisory program spaces. The MVME 133 supports only 24-bit addressing, so the two most significant hex digits in the address map are ignored. Table 1 Function code space decoder FC2 FC1 FCD cycle type responding MVME 133 devices / functions 000 reserved none except dynamic RAM 001 user data all except interrupt handler and MC68881 010 user program all except interrupt handler and MC68881 011 reserved none, causes local timeout 100 reserved none except dynamic RAM 101 supervisory data all except interrupt handler and MC68881 110 supervisory program all except interrupt handler and MC68881 111 CPU, LAC, VMEBUS, 28530, MC68901, interrupt handler 111 CPU coprocessor MC68881 Motorola Microcomputer Systems and Components 2-83 I MVME 133, MVME 133-1 Notes Table 2 Memory map Address Range 031 024 023 016 015 008 007 THKO onboard ROM for first 4 memory cycles after reset. XX0007 onboard dynamic RAM thereafter. XX0008 onboard dynamic RAM. XXOFFFFF. XX100000. VMEBUS. XXEFFFFF. XXF00000 onboard ROM/PROM/EPROM/EPROM. XXF1FFFF Bank 1. XXF20000 onboard ROM/PROM/EPROM/EPROM. XXF3FFFF Bank 2. XXF 40,000 onboard ROM/PROM/EPROM/EPROM banks 1 and 2. XXF7FFFF repeat in this space. XXF 80,000 MSR *MFPGPIP MSR *MFP air. XXF 80004 MSR *MFP DDR MSR *MFP IERA. XXF 80008 MSR *MFP IERB MSR *MFP IPRA. XXF 8000C MSR *MFP IPRB MSR *MFP ISRA. XXF 80010 MSR *MFP ISRB MSR *MFP IMRA. XXF 80014 MSR *MFP IMRB MSR *MFP VR. XXF 80018 MSR *MFP TACR MSR *MFP TBCR. XXF 8001C MSR *MFP TCDCR MSR *MFP TADR. XXF 80020 MSR *MFP TBDR MSR *MFP TCDR. XXF 80024 MSR *MFP TDDR MSR *MFP SCR. XXF 80028 MSR *MFP UCR MSR *MFP RSR. XXF 8002C MSR *MFP TSR MSR *MFP UDR. XXF 80030 the status and MFP registers appear. XXF 9FFFF repeatedly in this space. XXF A0000. Slob RRO Slob RX data SIOA RRO SIOA RX data. Slob WRO Slob TX data SIOA WRO SIOA TX data. XXF A0004 the above SIO registers appear repeatedly. XXF AFFFF in this space. XXF B0000 URDC01 URDC02 URDC03. XXF BOC04 URDC04 URDC05 URDC06 URDC07. XXF B0008 URDC08 URDC09 URDC10 URDC11. XXF B00C URDC12 URDC13 URDC14 URDC15. XXF B0010 the above real-time clock registers appear. XXF BFFFF repeatedly in this space. XXF C0000. VMware. XXF EFFFF. XXFF0000. VMware short 1/0 space. XXFFFFF. Denotes don't. However, when A24 is 0, the VMware is treated as a 32-bit data port for long word-aligned transfers, and when A24 is 1, the VMware is treated as a 16-bit port for all transfers. Reading the real-time clock with A25 equals 1 causes the VMware interrupter to assert a level 3 interrupt, while reading it with A25 equals 0 has no effect on the interrupter. The module status register, MSR, is read-only. It should not be written to. Cycles that access the status register also access the multi-function periphery MFP. The status register is connected to 024-031 and the MFP is connected to 016-023. Writes to the EEPROM must always be 16-bit wide. U denotes undefined bits. RDC denotes real-time clock. Motorola Microcomputer Systems and Components. 2-84. MVME 133, MVME 133-1. Coprocessor Register Map. The MVME 133 devices and functional blocks respond to only two types of CPU space accesses, FC2 FCO equals 111 coprocessor and interrupt acknowledge. The func. Code space decoder selects the MC68881 anytime. The MPU executes a coprocessor cycle, FC2FCO equals 111. And A19A16 equals 0010. The recommended coprocessor ID, bits 9 to 11 of the coprocessor instruction word, for the MC68881 is 001. However, the MVME 133 selects the MC68881 regardless of the ID. The MC68881 registers are addressed by A04AOL as shown in Table 3. Table 3. Coprocessor register map. A04AOO MC68881 register. In binary, 0310160150000. 00000 response, read only, control, write only. 00100 save, read only, restore, read write. 01000 reserved command, write only. 01100 reserved condition, write only. 10,000 operand, read write. 10,100 register select, read only, reserved. 11,000 instruction address, write. 11,000 operand address, read write. Interrupt handler and interrupt acknowledge map. The interrupt handler gives the onboard MPU the ABIL level by examining A01 A03. It then decides which ITY to sense and respond to all onboard interrupts, all vice the interrupt acknowledge cycle is 4. If the AC 7 VMware interrupts, VMware ACK-fail, VMware knowledge cycle was for VMware ACK-fail, abort. Sysfail asterisk and the abort switch. All of the VMware in switch or real-time clock, the interrupt handler causes the interrupts and the abort interrupt can be enabled /dis MC68020 to generate the interrupt vector internally. If not enabled by jumpers. All other interrupts are enabled /dis the interrupt handler initiates a vector fetch cycle for the enabled individually under software control. Also all appropriate device. If both onboard and VMware interrupts may be disabled with a software control bit. Interrupts are activated on the same interrupt level. The in function code space decoder selects the interrupt interrupt handler will acknowledge the onboard handler anytime the MC68020 executes an interrupt AC first. Knowledge cycle, FC2FCO equals 111 and A19A16 equals 1111. Table 4 summarizes all the interrupt sources and their. The interrupt handler then determines the acknowledge associated interrupt vectors. Table 4. Interrupt sources and vectors. Interrupt source path vector past vector offset level. VMware IR01 asterisk direct. From interrupting. 4x vector 1. VMware slave. VMware IR02 asterisk direct same as above 4x vector 2. VMware IR03 asterisk direct same as above 4x vector 3. VMware IR04 asterisk direct same as above 4x vector 4. MM58274A. Direct none $70 for. Real-time clock. VMware IR05 asterisk direct. From interrupting. 4x vector 5. VMware slave. DDTR star. MC68901 refer to MC68901. 4x vector 5. GPU datasheet. VMware per star. MC68901 refer to MC68901. 4x vector 5. GPI01 datasheet. LTO MC68901 refer to MC68901. 4x vector 5. Local bus timeout GPI02 datasheet. MC68901 timer DMC68901. Refer to MC68901. 4x vector 5. Datasheet. MC68901 timer CMC68901. Refer to MC68901. 4x vector 5. Datasheet. Continued. Motorola Microcomputer Systems and Components. 2-85. I. MVME 133, MVME 133-1. Table 4. Interrupt sources and vectors, continued. Interrupt source path vector past vector offset level. MC68901 timer BMC68901. Refer to MC68901. 4x vector 5. Datasheet. Transmit error. MC68901. Refer to MC68901. 4x vector 5. Serial, datasheet. Transmit buffer empty. MC68901. Refer to MC68901. 4x vector 5. Serial, datasheet. Receive error. MC68901. Refer to MC68901. 4x vector 5. Serial, datasheet. Receive buffer full. MC68901. Refer to MC68901. 4x vector 5. Serial, datasheet. MC68901 timer AMC68901. Refer to MC68901. 4x vector 5. Datasheet. OIRO MC68901. Refer to MC68901. 4x vector 5. Bus interrupter, GPI06 datasheet. VMware fail. MC68901. Refer to MC68901. 4x vector 5. GPI07 datasheet. VMware IR06 * direct. From interrupting. 4x vector 6. VMware slave. Z8530. Direct. Refer to Z8530. 4x vector 6. Serial ports datasheet. VMware IR07 * direct. From interrupting. 4x vector 7. VMware slave. VMware ACK direct none $7C7. Abort * direct none $7C7. Multifunction peripheral MC68901 general purpose I/O. The NVMe 133 uses the multifunction peripheral MC68901 for its front panel debug port, tick timers, watchdog timer and the status and control registers. The MC68901 has the ability to interrupt the MPU on level 5. When required for the timers, debug port, and GPIO, STA, TUS, bits. The MC68901 has 8 general-purpose I/O pins. The NVMe 133 uses 5 of these pins as status inputs and 3 of them as control outputs. The assignment of GP100 GP107 is shown in Table 5. Module Status Register. MC68901 Debug Port. The front panel debug port is a minimal implementation of an RS-232C serial port. It uses RxD as its transmit data output and TXD as its receive data input. DSR is driven true and DCD is pulled up to +12 VCTS is controlled by a software bit and RTS is monitored by another software bit, providing minimal flow control. The baud rate generator for the serial port is timer C. in the MC68901. The XTAL input to the MC68901 is 1.23 MHz, supporting baud rates from 110-9600 baud. MC68901 timers. There are 4 timers in the MC68901. They are as signed as follows. Timer A, software tick timer. Timer B, tick timer overflow / watchdog timeout. Timer C, baud rate generator for the front panel serial. Debug port. Timer D, delay mode only. Unassigned. Note, the watchdog timeout resets the MPU module when the timer B output is high. In addition to the general purpose status and control bits of the MC68901, the NVMe 133 has 8 read-only status bits. Collectively, these bits are called the module status register, MSR. The MSR and the MC68901 are grouped together and appear as a 16-bit word port to the MPU. Therefore, it is important to note that even though the MSR ignores all write accesses, a write to the MSR will affect the MC68901. The bit assignments for the module status register are shown in Table 6. Z8530 dual serial ports. The NVMe 133 uses the Z8530 to implement its 2 ReLULT protocol serial ports, providing multifunction support for handling the large variety of serial communications protocols available. The Z8530 can be programmed to satisfy special serial communications requirements as well as to follow standard formats such as byte-oriented, synchronous, bit-oriented synchronous, and asynchronous. In addition, protocol variations are supported within each operating mode by checking odd or even parity, character insertion or deletion, CRC generation and Motorola microcomputer systems and components. 2-86 NVMe 133, NVMe 133-1. GPI 07, VMware fail flag. GPI 06, VMware IRQ3 request flag. GPI 05, board or system failure control. GPI 04, enable/disable interrupts control. GPI 03, DCTS control. GPI 02, local bus timeout flag. GPI 01, vSphere flag. GPIO, DRTS flag. Table 6. Module status register. Bit 15, bit 14, bit 13. AC fail, VMware AC power fail. Syscan, VMware system controller. Perp***, power up reset. SR bit 4, status register bit 4. Bit 12. Checking, break, and abort generation and detection and many other protocol-dependent features. Because of the internal structure of the Z8530, there are several means of obtaining the baud rate clocks for each of the 2 serial channels. Many of the more frequently used baud rates are supported by the NVMe 133 internally, with additional support provided for external generation of any other desired frequency. Reference should be made to the Z8530 data manual and the NVMe 133 user's manual for additional information. All drivers and receivers for both serial channels are provided on the NVMe 133, with port A implemented for RS485/RS422 and port B for RS232 communications. User can configure the RS232C port, port B, as DCE or as DTE using the jumpers provided by NVMe 133. The RS-485 port may be configured by software to be master or slave, full duplex or half duplex. All signals are made available on rows A and C of the VMware P2 connector. The RS-232 connections can be made directly from P2 to a DB25 connector, although the RS-485 may require a crossover cable. Refer to the NVMe 133 User's Manual for pinout information. Real-time clock. The real-time clock on the NVMe 133 is an MM58274, providing a timekeeping function from tenths of seconds to tens of years in independently accessible registers, an hours counter programmable for 12 or 24-hour operation, an independent interrupting timer and its own on-board crystal controller oscillator. The counters are AR ranged as 4-bit words and can be randomly accessed for reading and setting time. Onboard ROM/PROM/EPROM/EPROM. The NVMe 133 has 4 28-pin ROM/PROM/EPROM/EPROM sockets that are organized as 2 banks with 2 sockets per bank. Each bank appears as a 16-bit word port to the MPU and can be separately configured for 8K x8, 16K x8, 32K x8 or 64K x8 ROM/PROM/EPROMs or bit 11 bit 10. SR bit 3, status register bit 3. SR bit 2, status register bit 2. SR bit 1, status register bit 1. SR byte, status register bit 0. Bit 09 bit 08. For 2K x8, 8K x8 or 32K x8 EEPROMs. When a bank is configured for EPROM, writes to that bank must always be 16 bits wide. There are several different algorithms for erasing/writing to EEPROMs, depending on the manufacturer. The NVMe 133 supports only those devices which have a static RAM-compatible erase/write mechanism. Note that the NVMe 133 requires that the EEPROMs must allow wired or on the RDY/BSY* pin VMware interface. The NVMe 133 provides an A24/D32 VMware interface for buffering of data, address and control, forward data manipulation to accommodate MC68020 and VMware data handling differences and for interrupt handling and control of misaligned transfers. In addition, system controller functions are available including a VMware time out generator, a SYSCLK driver, an IACK* daisy chain driver, a sysresep driver and a level 3 arbiter. All of these system controller functions are enabled/disabled by a jumper on the NVMe 133. VMware requester. The VMware requester is used to obtain and relinquish mastership of the VMware. The NVMe 133 operates in the early release and request, ROR, mode and can request VMware mastership on any one of the 4 request levels, depending upon jumper configurations on the NVMe 133. VMware interrupter. The NVMe 133 single-level interrupter generates interrupt requests on IR03*. It provides the value $FF as its status ID byte. It is an 8-bit interrupter and responds to all sizes of interrupt acknowledge cycles. The interrupter drives IR03* whenever the MPU reads the real time clock with 825 = 1. The state of the interrupter is reflected as the OIRO, GPI06, bit of the MFP GPIO port. Motorola Microcomputer Systems and Components. 2-87. I. MVME 133, MVME 133-1. Table 7. MVME 133 timing. All times are total cycles. Access. MVME 133 MVME 133-1. Sequence read-write. MPU to local DRAM 4 cycles 4 cycles 4 cycles 4 cycles. MPU to local ROM / 6 cycles 6 cycles 6 cycles 6 cycles. PROM / EPROM / EPROM. VMware to local DRAM. 9 cycles 9 cycles 9 cycles 9 cycles. 720 NS, 720 NS, 540 NS, 540 NS. MPU to global RAM. 13 cycles 14 cycles 13 cycles 14 cycles. MVME 133. MPU to global RAM. 9 cycles 7 cycles 11 cycles 8 cycles. MVME 204-1. Notes: 1. No arbitration overhead. 2. Accept RMW cycles where MVME 133 is required to obtain VMware mastership before RAM cycle can be started. 3. Device access time must be 300 ns or less for MVME 133 and 250 ns or less for MVME 133-1. 4. DSO/DS1 asserted to DAC** time. 5. Typical values. Actual values may be greater or less depending on the state of the slave MVME 133-1. 6. Assume the master MVME 133-1 is the current VMware master. Notes: 1,2, 1,3, 4,5, 5,6, 6,7, 7. The total number of clock cycles 4 plus, TAL-T, for a read and 5 plus, TAFT, for a write, where TA DSO/DS1 to DAC** time, and TMPU clock period. Mechanical and environmental specifications. Characteristics specifications. Power requirements. MVME 133 plus 5 VDC, 5A max, 4A tip. Plus or minus 12 VDC, 250 mA max. MVME 133-1 plus 5 VDC, 6A max, 4.5A tip. Plus or minus 12 VDC, 250 mA max. Clock frequency. MVME 133 12.5 MHz clock frequency. MVME 133-1 16.7 MHz clock frequency. Operating temperature 0 degrees to 55 degrees Celsius inlet air temperature with forced air cooling. Storage temperature -40 degrees to 85 degrees Celsius. Relative humidity 5% to 90%, non-condensing. Physical dimensions. Height 10.31 in, 261.8 mm. Width 7.40 in, 188.0 mm. Thickness 0.83 in, 21.0 mm. Ordering information. Part number description. MVME 133 VMware Module 32-bit monoboard microcomputer with 12.5 MHz. MC68020 CPU. Includes user's manual. MVME 133-1 VMware Module 32-bit monoboard microcomputer with 16.7 MHz. MC68020 CPU. Includes user's manual. MVME 133/D User's Manual for MVME 133/MVME 133-1. Related products. Part number description. MVME 133 Bug MVME 133 Bug Diagnostic/Debug Package for the MVME 133i. MVME 133-1. Includes user's manual. NVMe 225 VM module 2 MB dynamic RAM with byte parity. Includes user's manual. NVMe 215-1i2/3256 KB/512 KB/LMB CMOS RAM module. Includes users manual. Motorola microcomputer systems and components. 2 to 88. VM module. 32-bit mono board. Microcomputer. MC68020 microprocessor with 32-bit address and data at 20 MHz. 1 MB of shared local DRAM accessible from the VM bus. 32 bits wide. 4 28-pin JEDEC sockets for ROM/PROM/EPROM, 2 bank/16 bits wide. 1 front panel serial debug port. 1 RS-232C multi-protocol serial port. 1 RS-485/RS-422 multi-protocol serial port. 3 8-bit timers. Real-time clock. A 32/D32 VMware master interface. VMware system controller functions with level 3. Arbiter. Single level bus requester, level jumper selectable. Level 3 VMware interrupter. 7 level interrupt handler. The NVMe 133A VM module 32-bit monoboard microcomputer is designed to function in those applications requiring medium performance and functionality. WRTH its 1 MB of on-board DRAM, the NVMe 133A is an excellent choice for applications requiring real-time operations such as industrial automation and robotics. CPU. The NVMe 133A uses an MC68020 microprocessor operating at a fixed speed of 20.0 MHz. The MC68020 is the first product within the popular M68000 family to offer external 32-bit address and data paths. With its higher clock rate, advanced architecture, enhanced addressing modes and on-chip instruction cache, this product offers state-of-the-art performance while maintaining software compatibility with its widely accepted predecessors. Debug Monitor Firmware. The NVMe 133A Bug Debug Monitor firmware package is optionally available for use with the NVMe 133A module. This firmware offers 32 debug, up/downline load and disk bootstrap load commands, as well as a full set of onboard diagnostics, and a one-line assembler/disassembler coprocessor. The NVMe 133A is equipped with a 20.0 MHz MC68881 floating point coprocessor which will substantially improve computing speed in applications requiring arithmetic computations. The MC68881 is a full implementation of the IEEE standard, P754, for binary floating point arithmetic, provided. NVMe 133A. Ing the following operations: add, subtract, multiply, divide, remainder, square root, integer part, and compare. Each of these operations supports 7 different data formats: byte, word and long word integers, single, double, and extended, precision real numbers, and packed binary coded decimal string real numbers. In addition, the MC68881 supports a full set of trigonometric and transcendental functions. Figure 1 is a block diagram of the NVMe 133A. Onboard dynamic RAM. The onboard dynamic RAM uses 32-256KXL dynamic RAM. ZIPs, zigzag inline package, making a total of 1 MB of local DRAM. It is accessible by the MC68020, the refresh circuitry, and the VMware, each of which requests and is granted the DROM by a multi-port arbiter. The onboard shared DROM address is controlled by U82 and by J2. U82 selects one 16-byte block within the 4 GB range for the NVMe 133A. The default factory program for U82 puts the base address of this 16-byte block at $000000000. J2, then, selects one of the 16 address spaces within this 16-byte block for the 1 bytes of onboard shared DROM. Furthermore, the NVMe 133A allows the user to select 32-bit or 24-bit address option for VMware references. By properly jumpering J18, the user can configure the NVMe 133A to operate in a mixed 32-bit and 24-bit address system or a fully 32-bit address system. The NVMe 133A VMware memory map is directly affected by the address option selected as follows. If NVMe 133A is in a mixed 32-bit and 24-bit address system, OF 00100000-00F UFUO FF FUO FFFBFFFF FKUFF FUO FFFFFFF. No VMware activity, onboard DROM area. VMware standard, 24-bit address space. VMware extended, 32-bit address space. No VMware activity, local resource area. VMware extended, 32-bit address space. VMware short-lived, 16-bit address space. Motorola Microcomputer Systems and Components. 2-89. I. NVMe 133A. Serial. Rs MC port. I. timers. I. Debug port. I. Status control. Interrupt. Handler. Reset. Abort. LEOS. ROM sockets. N. Real-time. Clock. Plus. Serial ports. Selects. Dash. Data bus / dash asterisk. Add SSS. \:\. T%0. Comma dash T / dot comma dash V dash 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 comma I0 dash 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 shocked rebulletin TIJ / V // KV %L W underscore MPU clocks R0 and stacks IRBTL : SHRCO SIR F dash dash RAM array and local 1 dash dot generator V timeout I plus map decoder address mux IVMware IJ VMware master interface data VMware system buffers register address buffers controller interrupter L P2 I T RI FRI Pi VMware connector R Figure 1 NVMe 133A functional block diagram. If NVMe 133A is in a fully 32-bit address system, indicate privileged or non-privileged data or program space. And when this board is not the current VMware master, OFFF 00100000 FF. FUU, FFFBFFFF. FKUFF. FUFFFFFFFF. No VMware activity, onboard DROM area. VMware extended, 32-bit, address space. No VMware activity, local resource area. VMware extended, 24-bit, address space. VMware short I/O, 16-bit, address space. Function code map decoder. The MVME 133A's DROM responds to the VMware accesses only when the addresses match and the address modifiers. At the beginning of each MPU cycle, the space decoder determines what kind of cycle is taking place and which device or function is selected within that cycle type. The cycle types shown in Table 1 are determined by the function code signal lines, which are driven by the MC68020. Table 1. Function code space decoder. FC2Fe1 FCO cycle type are ONDIN 9 MVME1 _33A DeviCFL8, FUROD, NS. 000 reserved none, causes local timeout. 001 user data all except interrupt handler and MC68881. 010 user program all except interrupt handler and MC68881. 011 reserved none, causes local timeout. 100 reserved none, causes local timeout. 101 supervisory data all except interrupt handler and MC68881. 110 supervisory program all except interrupt handler and MC68881. 111 CPU, LAC, VMware, Z8530, MC68901, interrupt handler. 111 CPU coprocessor MC68881. Motorola microcomputer systems and components. 2 to 90. MVME 133A. Memory map. The memory map, referred to Table 2, indicates those devices that occupy user data, user program, supervisor data and supervisory program spaces. Table 2. Memory map. Address. Range 031 024 023 016 016 DOS. O onboard ROM for first 4 memory cycles after reset. 0000007 onboard dynamic RAM thereafter. 0000008. Onboard dynamic RAM. UF. 001000000. VMware. FEF. FUO onboard ROM/PROM/EPROM/EPROM. FFF1 FFFF Bank 1. FFF 20000 onboard ROM/PROM/EPROM/EPROM. FFF3 FFFF Bank 2. FFF 40000 onboard ROM/PROM/EPROM/EPROM Banks 1 and 2. FFF7 FFFF repeat in this space. FFF 80000 status MFPGP-IP status. FFF 80004 status MFP-DDR status. FFF 80008 status MFP-IERB status. FFF 8000C status MFPPERB status. FFF 80010 status MFP-ISRB status. FFF 80014 status MFP-IMRB status. FFF 80018 status MFP-TACR status. FFF 8001C status MFP-TCDCR status. FFF 80020 status MFP-TBDR status. FFF 80024 status MFP-TDDR status. FFF 80028 status MFP-UCR status. FFF 8002C status MFP-TSR status. FFF 80030 the status and MFP registers occur. FFF9 FFFF repeatedly in this space. FAO. Slob RRO Slob RX data SIOARRO. Slob WRO Slob TX data SIOAWRO. FAO 04 The above SIO registers appear repeatedly. FAF in this space. FBO URDC01 URDC02. FBO 4 URDC04 URDC05 URDC06. FBO 8 URDC08 URDC09 URDC10. FBO URDC12 URDC13 URDC14. FBO 10 The above real-time clock registers appear. FFFB7 FFF repeatedly in this space. FFFB 8000. VMware interrupt. FFFB FFFF. FKU. VMware. FF. FUO. VMware short 1/0 space. FFFFFFFF. D070QO. MFP Air. MFP-IERA. MFP-IPRA. MFP-ISRA. MFP-IMRA. MFP-VR. MFP-TBCR. MFP-TADR. MFP-TCDR. MFP-SCR. MFP-RSR. MFP-UDR. SIOARX data. SIOATX data. URDC03. URDC07. URDC11. URDC15. Notes, asterisk the status register is read-only. It should not be written to. Cycles that access the status register also access the MFP. The status register is connected to ID24J, D31J and the MFP is connected to D16J, D231. Writes to the EEPROM must always be 16-bit wide. UUUU denotes undefined bits. Motorola Microcomputer Systems and Components. 2-91. I. MVME 133A. Coprocessor Register Map. The NVMe 133A responds to only two types of CPU space. Accesses, FC2, FCO equals 111 coprocessor and interrupt AC. Knowledge. The function code space decoder selects the MC68881 anytime the MPU executes a coprocessor cycle. FC2 FCO equals 111 and A19 A16 equals 0010. The recommended coprocessor ID, bits 9 to 11 of the coprocessor instruction word. For the MC68881 is 001. However, the NVMe 133A selects the MC68881 regardless of the ID. The MC68881 registers are addressed by A04 A01 as shown in Table 3. Table 3. Coprocessor Register Map. Amigo MC68881 Register. In Alnary, D31 D16015. Dog. 00000 response, read only, control, write only. 00100 save, read only, restore, read/write. 01000 reserved command, write only. 01100 reserved condition, write only. 10,000 operand, read/write. 10,100 register select, read only, reserved. 11,000 instruction address, write. 11,100 operand address, read/write. Interrupt handler and interrupt acknowledge map. The interrupt handler gives the onboard MPU the ability to sense and respond to all onboard interrupts, all 7 VMware interrupts, VMware ACK fail, VMware sysfail and the abort switch. All of the VMware interrupts and the abort interrupt can be enabled. Disabled by jumpers. All other interrupts are enabled. Disabled individually under software control. Also all interrupts may be disabled with a software control bit. Function code space decoder selects the interrupt handler. Anytime the MC68020 executes an interrupt acknowledge cycle, FC2 FCO equals 111 and A19 A16 equals 1111. The interrupt handler then determines the acknowledge level by examining A01 A03. It then decides which device the interrupt acknowledge cycle is for. If the acknowledge cycle was for VMware fail asterisk, abort switch or real-time clock, the interrupt handler causes the MC68020 to generate the interrupt vector in turn ally. If not, the interrupt handler initiates a vector fetch cycle for the appropriate device. If both onboard and VMware interrupts are activated on the same interrupt level, the interrupt handler will acknowledge the onboard interrupt first. Interrupt source: VMware IRQ1, VMware IR02 star, VMware IRQ3 star, VMware IRQ4 star, MM58274A. Real-time clock: VMware IRQ5 star, DDTR star, VMware per star. LTO. Local bus timeout. MC68901 timer D. MC68901 timer C. Table 4 summarizes all the interrupt sources and their associated interrupt vectors. Table 4. Interrupt sources and vectors. Path vector, past vector, offset level. Direct. From interrupting. 4x vector 1. VMware slave. Direct same as above 4x vector 2. Direct same as above 4x vector 3. Direct same as above 4x vector 4. Direct none $70 for. Direct. From interrupting. 4x vector 5. VMware slave. MC68901 refer to MC68901. 4x vector 5. GPU datasheet. MC68901 refer to MC68901. 4x vector 5. GPI01 datasheet. MC68901 refer to MC68901. 4x vector 5. GPI02 datasheet. MC68901. Refer to MC68901. 4x vector 5. Datasheet. MC68901. Refer to MC68901. 4x vector 5. Datasheet. Continued. Motorola Microcomputer Systems and Components. 2-92. MVME 133A. Table 4. Interrupt sources and vectors, continued. Interrupt source path vector, past vector, offset level. MC68901 timer B. MC68901. Refer to MC68901. 4x vector 5. Datasheet. Transmit error. MC68901. Refer to MC68901. 4x vector 5. Serial, datasheet. Transmit buffer empty. MC68901. Refer to MC68901. 4x vector 5. Serial, datasheet. Receive error. MC68901. Refer to MC68901. 4x vector 5. Serial, datasheet. Receive buffer full. MC68901. Refer to MC68901. 4x vector 5. Serial, datasheet. MC68901 timer A MC68901. Refer to MC68901. 4x vector 5. Datasheet. OIRQ MC68901 refer to MC68901. 4x vector 5. Bus interrupter, GPI06 datasheet. VMware fail. MC68901 refer to MC68901. 4x vector 5. GPI07 datasheet. VMware IRQ6 * direct. From interrupting. 4x vector 6. VMware slave. Z8530. Direct. Refer to Z8530. 4x vector 6. Serial ports datasheet. VMware IRQ